So surveillance is basically the eyes of the air traffic controllers.
They need all these surveillance systems to have the situational awareness to know where the aircraft are at any time.
It gives you the ability to have oversight, have visibility when there is no visibility.
Scattered throughout the country, we have short-range and long-range radars that are continually operating and gathering that information and sending it to air traffic control centers.
The future for surveillance is bright.
I think it's going to grow, it's going to evolve, it's just going to pull everyone together, leverage off the advancing technology and just moving everyone forward.
It's not really a whole large community, but I think we do very important work. We all have the same interest at heart, and that's safety.
I depend on other people and other people depend on me. So as a community, we all work together to accomplish the same outcome.
Everybody works well together for the most part. We get along. There's definitely a team and a small community there.
We do have a need for each other, that there are many things we can learn from each other. And we have to have that dialogue and be willing to have that dialogue.
There's so much in the surveillance world. So nice to be able to go through and talk to somebody else and say, here's what I've got going on. Have you ever seen this before? And what did you have happen with it? Because everybody has a little bit different experience.
When you look up in the sky and that plane's flying over your house, you know you had a little bit to do with that. You know that those folks are going to land safely because of the work of you and the team that you put together to work on that equipment.
In a moment, I'll be handing over to Vice President of Technical Operations, Jeff Blancy. As a reminder, all participants are video and audio disabled by default. Jeff, the floor is yours when you are ready.
Hey, thanks, Alexander. I appreciate it. Hopefully everybody can hear me and see me. To have a new setup on my computer, but let me know if you can't. So good morning. Thank you, surveillance community. That video just like pumped me up as a former radar technician in the Air Force, and then quasi within the FAA because I started doing different specialties. Excited to see that. It's important for me and for all of us to understand the history of surveillance and also the future of surveillance. I think they looked at the agenda. You've got the whole gambit here, and that's exactly what we were hoping to put together. A big shout out to the entire surveillance community for pulling together. When the idea came up, there was just this tremendous outpouring of energy from everybody involved. Our second level engineering, the PMO, everybody currently working on this stuff. Really, this provided an avenue for us to outreach to our entire surveillance community, both in the tech services, the service center, the technicians, the SSCs. Everybody that you saw in that video, it's important to understand the importance of surveillance and where we're headed in the future. So I can tell you, having connected with the team 3 or 4 times as this was coming together, the energy was off the chart, and I'm sure they're just like me, sitting in front of their cameras, ready to go and excited. So I think this will be a great conversation for everybody that's involved. It's the first of, I hope, many type of symposiums. We grew up doing workshops and those type of things back in the day in ILS and some surveillance, really leveraging the experience with our second level engineers and team. This is an expansion of that. This is pulling in all of the community and hopefully informing our new hires and some of our journeymen about where we're headed and the importance of surveillance. So I think this is going to be key. This kickoff is going to be critical for our success and really educating in a different manner. We've been in this public health emergency for 7 months now, and I see this really as a critical point for us in opening up new forms of education and connection, communications with our workforce. This is all of that. So you're going to see a lot of information. You get 2 full days. I know that's a lot. The team has built in break periods and times for you to just kind of step away and come back. But please stay engaged with this. We need your input and feedback. As I mentioned, this is the first of several of these, hopefully, that will next focus on nav or comm. There's so much going on in all of these areas that I think having these type of platforms to have discussions with our team will be great for us. So we don't do it without you. We need your feedback. Input is important to us to shift where we can improve, where we can tweak a little bit on these forums. So please engage fully, ask questions. There's a wealth of information in this surveillance community that's on here, and I know you'll learn a lot. So I will turn it back over to Noel and we'll get this thing started. Thanks, everybody.
All right, thank you, Jeff. As those of you that know me, I normally start off my meetings with smile, everyone, smile. Welcome to the 2020 Surveillance Symposium. My name is Noel Cavazos. I'm the OESG manager in the Central Service Area, and I'll be your moderator for the next 2 days. For the past 7 weeks, members of the surveillance community have been feverishly working to put the agenda and the content together for this symposium. We have 7 great topics that we're going to be covering. Day 1 today, we'll be covering surveillance overview. What does surveillance mean to the FAA mission? We'll be talking about the entire surveillance community. And then we'll finish off the day with how to get assistance. Tomorrow, we'll be covering the current state of surveillance, the major challenges facing the surveillance community, and the future of surveillance. We want this to be interactive, so we encourage you to submit questions in Q&A. After each session, we'll answer as many of the questions as possible. And at the end of each day, we'll be bringing back our panelists for a Q&A at the end of the day. So thank you for taking the time to join today. I ask you to put your radar ears on, increase your receiver sensitivity, lean in and learn. So let's get started with the surveillance overview and our keynote speaker, Don Taylor.
Thank you, Noel. My name's Don Taylor. I'm the AJW 135 Surveillance Weather Manager for the in-service management team, and I will be presenting the surveillance overview. Marzan, please pull up the first slide. Thank you. In 2019, there were 45,000 average daily flights handled, providing approximately 2.9 million passengers with flight service every day, accumulating to 16,405,000 flights handled for the year. Aviation contributed 5.2% to the US gross national product while generating $488 billion in annual earnings from aviation. There are 26 million square miles of oceanic airspace and 5.3 million square miles of US airspace operated and safeguarded by FAA personnel. To put things a little in context, I'd like to bring an Focus FAA article, which was presented in September 2016, which I believe is very relevant to this presentation. And it featured Admiral Rickover's 7 rules of leadership, specifically rule number 2, which informs, and I quote, "People running complex systems should be highly capable," end quote. And our FAA professionals are. This article closes with the following paragraph. I quote, "There is no question to the degree of complexity of the NAS and to maintain the high level of safety and efficiency, the FAA consistently relies solely on the highly capable people who run it every second, every minute, every hour of every single day. While the operation is dynamic with many different aspects at play to carry on the mission, it is crucial to acknowledge that training, positive attitudes, and adherence to every policy and regulation is at the core of our foundation. Working together to collaboratively and consistently improve our NAS should be our cornerstone, and it is. And acknowledging that our very capable employees are our strengths, the daily norm," end quote. Now, today's technology advances in cooperative and non-cooperative surveillance systems are opening up opportunities to deliver a broader range of services and to operate within a wider range of environments. To ensure the most thorough airway coverage possible, the FAA's NAS consists of 4 distinct complementary radar system classifications. Excuse me. Number 1, surface surveillance radar systems provide coverage from pushback of the airport gate through taxiway, initial takeoff, as well as final approach and landing. Number 2, terminal, non-cooperative, or primary surveillance radar systems provide coverage for takeoff from 1 mile off the end of the takeoff runway and within the radial range of 60 nautical miles from takeoff or descent final approach for the associated airport. Number 3, en route, non-cooperative, or primary surveillance radar systems provide coverage for domestic cruise altitudes to a radial range from 200 to 250 nautical miles, depending upon the surveilling en route radar system. And number 4, cooperative, such as secondary surveillance radar and automatic dependent surveillance broadcast, ADSB, are systems that perform two-way communication with appropriately equipped aircraft. Now, secondary surveillance radar systems are co-located with all terminal and en route non-cooperative or primary systems. These cooperative systems may also be installed as standalone systems, as in the case of a BOS, beacon-only system. The ADSB is a surveillance technology in which aircraft with the ADSB equipage determines its position via satellite navigation and periodically broadcast it, enabling it to be tracked. Systems from each of these classifications are situated such that their coverages overlap, ensuring proper aircraft tracking throughout the phases of flight. Next slide, please. Let's take a closer look at surface movement, or the SMR. Is used to detect aircraft and vehicles of an airport. It is used by air traffic controllers to supplement their visual observations. It may also be used at nighttime and during low visibility to monitor the movement of aircraft and vehicles on the runway. Total SMR systems in the NAS inventory is 44, consisting of the ASD 3, the Airport Surface Detection Equipment Model 3, the ASD-X, and the Airport Surface Surveillance Capability, ASSC. The 9 ASSC sites used the ASD-3 to provide airport movement area safety system, which was safety logic used to help prevent runway incursions. And the similar ASD-X program also used ASD-3 radar, but the primary difference between ASSC and ASD-X is that the ASSC does not require ASD-3 input. Originally, the FAA installed 38 ASD-3 radar systems at the nation's busiest airports, but the cost-effective alternative to the ASD-3 AMAS capability, referred to as the ASD-X, is a runway safety program that come into being, and it's used to improve ATC situational awareness by providing tools to supplement their tasks. The data that the ASD-X uses comes from a surface movement radar located on the airport traffic control tower or a remote tower, giving you the perspective from the air traffic controller when it's on the tower, and for purposes of clear line of sight for those airways, for those lanes that they're trying to view, it might be on a remote tower. It also pulls in information from multilateration sensors, ADSB sensors, terminal radars, the terminal automation system, and from aircraft transponders. Now, by fusing the data from these sources, ASD-X is able to determine the position and identification of aircraft vehicles on the airport surfaces, as well as aircraft flying within 5 miles of the associated airport. Next slide, please. The airport surveillance radar, ASR systems, are terminal airport non-cooperative surveillance systems used by air traffic control to collect aircraft position and tracking information for airborne aircraft within the operational range of the system without needing to rely on aircraft avionics. These ASR systems provide a ground-based, two-dimensional digital radar capability. These systems transmit S-band 2700 to 2900 megahertz radio frequency RF pulses and detects the resulting reflected RF energy from the airborne aircraft or weather phenomena at ranges up to 60 nautical miles from the system's rotating antenna using a narrow fan beam rotating at the rate of once every 4.8 seconds. There are three separate models of the ASR system supporting the NAS. The first is the ASR-8. It's our oldest ASR system, to be followed by the ASR-9. And our newest ASR system is the ASR-11. All three systems are in our NAS and provide us surveillance coverage at terminal airports. Now, the legacy ASR-8, the analog precursor to the ASR-9, used the moving target indicator technology in its legacy form, whereas the ASR-9 and the ASR-11 use the moving target detector technology, which is an advance on the simpler MTI technology, enabling full advantage to be taken in both the Doppler and range domain to achieve better clutter suppression. The ASR-8 and the ASR-9 use a klystron-based transmitter, whereas the ASR-11 uses a solid-state transmitter. With the modification of the common terminal digitizer to the ASR-8, we've upgraded our legacy ASR-8 from its analog form to now a digital digitized form to allow for the interface with new digital automation platforms, being the standard terminal automation replacement system, or STARS. Next slide, please. The Common Airport Surveillance Radar, CARSR, system is a joint use, non-cooperative surveillance system used by air traffic control, ATC, to support the collection of aircraft position and tracking information for airborne aircraft. The CARSR replacement program subsumed the legacy ARSR-1, ARSR-2, and ARSR-3 models, as well as the FPS series radars, bringing the equipment to a common configuration baseline. The CARSR system provides a ground-based 2D digital radar capability at ranges up to 200 nautical miles from the system's rotating antenna, using a narrow fan beam rotating at a rate of once every 10 seconds. The CARSR system is always co-located with a cooperative surveillance system such as an ATCBI-6 or a mode select beacon system. The ARSR-4 system is a joint use, non-cooperative surveillance system used by air traffic control to collect aircraft position and tracking information for airborne aircraft within the operational range of 250 nautical miles. The ARSR-4 system also provides ATC with selected weather information within its operational range to support ATC operations. Specifically, the ARSR-4 system provides a ground-based 3D digital radar capability. The system uses moving target detection techniques to extract its airborne aircraft surveillance and weather contour data. The ARSR-4 system is always co-located with an ATCBI-6 Model M cooperative surveillance system, where the ATCBI-6 Model M correlates the ARSR-4 surveillance data with its own cooperative surveillance data and forwards the combined aircraft surveillance data to the ATC automation systems. The ATCBI-6 Model M is capable of Mode 4 and Mode 5 IFF transmissions, which is identification friend or foe, which it has a DoD, Department of Defense function. Next slide, please. The cooperative surveillance systems used by the air traffic control support the safe and efficient movement of aircraft within the NAS in both terminal and en route airspace. These systems, working in conjunction with aircraft transponders, provide ATC with aircraft position, identification, tracking information for airborne aircraft within the operation range of the system. Cooperative systems in the NAS include the ATCBI-5, the Mode Select, the ATCBI-6, and the monopulse secondary surveillance radar, or MSSR. It's to be noted that the MSSR, a Raytheon product, is part of the ASR 11, an integrated system in its own part. The ATCBI 5 does not, oh, next slide, please. Yes. Back up one slide, please, Marzan. Thank you. I've shown here a representation of the transmitted beam for the beacon systems. On the left is the ATCBI 5, and on the right is our monopulse beacon transmissions, which would include the mode select MSSR as well as the ATCBI 6. You can notice a little less complexity on the left with the ATCBI 5 and a little bit more complexity on the right with the monopulse transmissions. The ATCBI 5 does not have the delta beam transmission, which is you can notice that to the left and the right of the main beam on the monopulse picture, or very clearly represented in the center picture. You can see the beam steering left and right of the bore sight. This allows us to collect better azimuthal accuracy. The ATCBI 5 does not have that azimuthal accuracy as a result of that lack of those beams steering to the left and right of the main beam. The ATCBI 5 uses a sliding window detector where multiple hits allowed from the dwell time, approximately 8 to 16 pulse repetition times, or PRTs, are used to determine the target detection criterion. So it takes a lot of hits for an ATCBI 5 to declare a target. The Mode S, ATCBI 6, and MSSR integrators use the sum, otherwise known as sigma, and difference, delta, channels to provide a monopulse capability to measure the off-bore sight angle, again represented in the center picture, angle of the transponder reply, allowing for improved azimuthal accuracy. So we can determine whether the target is to the left or the right of the bore sight. Further, the Mode S and ATCBI 6 reduce interference by assigning aircraft a discrete mode select address derived from the aircraft's internationally assigned registration number. It then provides a mechanism by which an aircraft can be selected or interrogated such that no other aircraft reply in response. Accordingly, excessive 1090 megahertz downlink replies from aircraft transponders are avoided. Next slide, please. This brings us to our cooperative surveillance, ADSB and WAM, our newer service-based technologies. Excuse me. The ADSB service is a cooperative surveillance service used by air traffic control to support the safe and efficient movement of aircraft in the NAS. This service, working in conjunction with the ADSB out avionics and ground-based broadcast services, provides air traffic control with aircraft position, identification, and other information for ADSB-equipped aircraft within the operational range of the system. Wide area multilateration, or WAM, is a new surveillance source which leverages the ADSB infrastructure to provide an additional layer of cooperative surveillance. WAM is distributed surveillance technology that works by deploying multiple sensors throughout an area to provide coverage of the desired airspace. WAM can be installed in areas of challenging terrain, which limits the use of secondary radar. It can also be used as a replacement for secondary radar or complementary surveillance to ADSB. The system has an operational range limited only by the extent of the ground station network comprising the system, and updates its surveillance data no slower than once every 3 seconds in terminal mode or 6 seconds for en-route use. I've got a representation there for the airspace coverage requirements for ADS-B, which was mandated as of 1 January 2020. This was a long time in coming. So, a great deal of thanks for all of the hard work to all of the folks that made it possible. Next slide, please. And this provides a little bit better or clearer representation graphically for those classes of airspace requiring the mandate for ADS-B equipage as you're transiting about the country. Next slide, please. Whoops, back up one, sorry. What I have there below is a link for a NASA storyboard. And I'd like to show this nicely choreographed video that assists in the visualization for the complexity of the WAM system operation capability. This video was produced by Harry Bilecki of ANG E5A group. And this team lead and other storyboard team members were instrumental in putting this together. If you would please play that video.
Welcome to the WAM Wide Area Multilateration Storyboard, describing WAM's future capabilities. The ADS-B out rule dictates that effective 2020, aircraft operating in specified airspace are required to have an ADS-B system that includes a certified position source. WAM will leverage the ADS-B out mandate to trust the identification and altitude information contained in the ADS-B transmissions. WAM will no longer need to interrogate the aircraft. WAM will become a simpler, passive system. WAM will provide terminal surveillance data to TRACONs for terminal airspace coverage of moderate density airports. In 2020, as a passive system, WAM will provide surveillance coverage of ADS-B equipped aircraft. The existing ADS-B infrastructure has 2 ADS-B radio sites near the airport and at least 2 additional radios covering the remaining terminal airspace. Inside the SBS control station, the ADS-B processor uses aircraft tracking validation techniques or other surveillance sources such as terminal or surface radars to validate the aircraft ADS-B position data. On average, 2 additional WAM radio stations can be strategically added to each terminal service volume to implement WAM service. Both the WAM and ADS-B radio stations receive the same ADS-B transmissions, each sending data independently to the SBS control station. Where the MLAT processor uses the data for triangulation to compute the aircraft position for the WAM service report. Both the WAM and ADS-B service reports, independent of one another, are sent to the TRACON through the SBS infrastructure, where they are presented to the controller on the STARS display. When an aircraft experiences interference to the GPS signals, WAM can seamlessly serve as a backup to ADS-B. GPS signal interference can severely degrade the accuracy of ADS-B reported position data, causing the ADS-B processor to fail the ADS-B position validation. As a result, the ADS-B service report will either not be sent or will be invalidated. Despite the inaccurate ADS-B reported position due to the GPS signal interference, that same ADS-B transmission still serves as valid data for triangulation. The SBS control station receives data for triangulation from all the radio towers. At which time, the MLAT processor triangulates position data, creating the WAM service report. In the case of GPS interference, only the WAM service reports are sent to the TRACON. Where they are presented to the controller on the STARS display. In the very near future, transponder-equipped aircraft will become ADS-B-equipped aircraft, and WAM will not need to interrogate the aircraft, which reduces signal interference to spinning radar systems and surface detection systems. And with minimal additions to the existing terminal ADS-B infrastructure, this all makes WAM easier and more cost-effective to deploy. Thank you for watching.
Okay, Noel, are we taking any questions here?
Yes, Don, we have one question that came in, and the question is, there's two questions actually. The first one is from Mitchell Lentini. Is MLAT through the ADS-B via STARS going to be the replacement for the remote units of the ASD?
Okay, this is where I'd need to reach out to the broader community there, but I could get back with the individual with an answer on that. There's many things that we are looking into and discussing as far as the determination on which direction we go. That's something that's a work in progress.
Do we have any, is there anybody else on the team that thinks that they can answer that question? Is MLAT through the ADS-B via STARS going to be a replacement for the remote units of the ASD? Okay, so we'll just work on an answer to that question, and if we can't answer it by this afternoon, we will follow up with answers to all of our questions. As a reminder to everyone, all of the resources, PowerPoint presentations, and videos will be made available after the symposium. However, we are not recording this session, so a recording will not be made available. We have a few more questions coming in, Don. The second question is from Omar. If ADS-B and WAM is already deployed, are ATSS going to be trained to maintain? Who is maintaining it?
Yes, these are service-based, services, right? So it's a third party that will actually be maintaining those equipments, but there will be lines drawn for where that line is delineated between what the contractor is going to maintain and what the FAA is going to maintain. But the future for services is going to be a growing portion of the services that we have, but by no means are we going to be losing our legacy platforms anytime soon. So we will still continue to have, our ASRs out there providing surveillance services, our secondary radar systems, beacons providing services, but they will be complemented where and when applicable with ADS-B and WAM-like technologies.
All right, we have another question from Alex. How does the information to a controller look different in STARS when the ADS-B/GPS signal fails and the WAM service report is the only information given?
Okay, in that I would have to get back with them, but what we have under Fusion is many layers that come to it, and oftentimes they'll get cues on the screen of the glass for what surveillance is lost. But I would really need an air traffic controller there to speak with that to that articulately. I could get back with that answer.
All right. Well, I know that we have some air traffic control representation on our panel. Does our air traffic control representative feel comfortable in answering that question, maybe? Since they're not chiming in, I guess that's a no. We'll go to the next question. It's from Bradley Crouch with AJW 134.
Okay.
Is it the goal to completely replace the beacon transponder? If so, how will emergency codes be handled?
No, we'll have beacon transponders out there. We've got the ADS-B transponders. Likewise, this will be a slow progression in any direction we go, but for the foreseeable future here, the transponder will be equipped in the aircraft and provide those services as a backbone. So.
Okay, thank you. The next question is from James Coots. Will ADS-B replace ground-based systems or run in parallel?
More so the latter. Again, what we're speaking about is evolutionary, not revolutionary, right? There's nothing that's going to happen in the near term that's going to get rid of our terrestrial-based, ASRs and ARSR systems. There may be fewer systems out there, but they're not going to be replaced anytime soon.
So run in parallel for
yes,
the foreseeable future.
Yes.
Another question. Oh, no, just a comment. Bradley Crouch, thanks, Don, just answered this. James Toomey, are there any security considerations with WAM and ADS-B?
Well, we have our AJWB group, our security folks over there. They review all of our NAS systems very rigorously. There are always security inspections for all of our, to basically identify any security issues that may be exploited. There's always threats out there. So where we are, we're comfortable with the technologies we employ in the NAS. And we've got a group that routinely surveys our systems to ensure that these security considerations are taken into account and resolved. So it's always ongoing. It's never done.
All right, the next question from Mike McDouglovich. Please talk about surveillance in the oceanic environment.
Okay, that's where it gets a little bit more difficult, trying to keep that. There's talk about, satellite-based surveillance, when it comes to give us that constant coverage when you're in the oceanic. Of course, we have, ATOP and things like that. But there are technologies that are being looked at and may in the foreseeable future become, realized. But for now, oceanic is a bit, difficult, absent like an ADS-B type technology or, satellite-based.
Right. Don, I do know that in the Gulf of Mexico, we place the ADS-B transmitters on oil rigs.
Yes.
And that we do have ADS-B out in the Gulf of Mexico.
Yes.
Next question, James Toomey, actively tracking airspace violations. I think that was going back to his other question. I'm sorry, I can't. He's talking about actively tracking airspace violations. I don't know. With respect to his, are there security considerations with WAM and ADS-B, for instance, actively tracking airspace violations?
Well, all of our surveilled data, can be used to identify, tracking, violations and such. So it's recorded. We can analyze it in a forensic manner or real time with the air traffic controller on the glass to provide that corrective instruction. And Noel, just as a time check there.
We're good.
Okay, all right.
Yeah, we got 8 more minutes at least.
Okay, no, that's fine.
We reach our break. The next question is, will the ADS-B transponder not be available for pilots to turn off even by accident?
Okay, this is where we go into those human factors, requirements for the equipage. I have to get back with them on a definitive answer for that. But again, there's a significant amount of considerations that we bring in to ensure that pilots are appropriately trained, that the equipment is as best as we may make it, foolproof, right? To avoid that, but there's always the appropriate training and procedures in operating any piece of equipment that needs to be followed. So.
All right, the next question is from Thomas Fizette. In response to the loss of a system on the STARS display, the controller will or should see a red system identifier on their screen when a system problem is encountered. So I guess that's
yeah.
That was someone's helping us out with one of the answers to the questions that we had earlier.
Much appreciated.
Yes, thank you very much, Thomas.
Thank you.
The next question is from Julian Pizarro. Will there be an upgrade to the ATC BI5 in the future? Something similar to the CTD for the ASR 8?
Yes. In this instance there, what we've got is a new program. It's called the Mode S Beacon Replacement System, MSBRS. We love our acronyms. Will be a newer beacon system that will come in, and it could actually replace, all of our current beacon systems. And it has several legs on it for procurement. They're targeting some 75 or so MSBRSs, initially. But it's going to be graduated. Now that number could go up, that number could go down under the actual acquisition, but that will be our new beacon replacement system. And again, it is capable of replacing the 5, the Mode S, as well as the ATC BI6 if we so chose.
Okay, so so just to clarify, there's not an upgrade to the BI5, it's a replacement for the BI5 in the future.
That's correct.
Right. Okay. The next question is from Raymond Wood. There has been talk about replacing the aging ARSR4, which has become difficult to get parts for over the years. Can you verify?
Well, there's this is where you start to get into the sensor, the spectrum efficient national radar system, or national surveillance radar sensor. Right now, we've going to take a little bit of a pause and reevaluate the program, but our management is committed to the sensor program, which will allow for the upgrade of our long-range radar platforms. Dominantly, probably the ARSA-4 is targeted, most certainly, which is located along the perimeter of the CONUS United States, as well as, a system out there in Guam and where is it? Puerto Rico also. But what the sensor holds in the future is something that's being evaluated, but we anticipate bringing in some 40 to 50 replacement radars under that program. And again, the ARSA-4 would be the prime candidate to receive those replacements.
Right, and when it comes to discussing the replacements of all of our systems, tomorrow on day 2, when we'll be covering a lot of that during the current state of surveillance, and then the major challenges facing the surveillance community, and then the future of surveillance. We will have the program office available at that time to discuss the replacements programs and what the schedules are for those types of things.
Yeah.
The next question comes to us from John Dolan. Via STARS, there is an ADS-B feed from the SBS. Does this include the WAM service, or is that an independent feed?
Okay, I'm going to need to take that question offline, and I could get back with them on that.
Okay, and it's a multiple question. So that was just the first one, and it was, and how will it be indicated on the STARS MCW when ADS-B fails and WAM is primary? We'll work on it. Additionally, as ADS-B increases in target validation, will WAM be included in this algorithm? I believe we'll just have to get back to on that question. Yeah. The next question comes to us from James Frierson. Is there talk about eventually going to a phased array radar system? That's a good question.
That's something that was brought up under, again, the sensor program. It's nothing that's being removed. A number of things are still on the table. So it's possible that, yes, an electronically steered phase radar could be possible. It's just not been determined to date.
Yeah, so phased array is under review, but determination hasn't been made with respect to the sensor program, right?
That's correct, yes.
Okay, the next question comes to us from Walter McCusker. On sites that have only 1 or 2 repeater sites for ADS-B that are not very reliable and are not being fixed because not enough service volume to justify any additional sites or improvements be resolved in the future of ADS-B WAM is the new approach? Sites. Okay, so do you understand that question? So on sites,
that's what I was trying to read it very quickly.
I think what he's trying to say is that if we have ADS-B sites that we have issues with, is WAM going to be the approach? Will RAM be the replacement for those?
I think you got to find the balance between that. WAM is a very expensive technology, very good, but very expensive. What we need to do is work very closely with our third-party vendors that are actually providing the maintenance and work that through. If there's issues with the ADS-B coverage, we need to work that through them to get the appropriate services that we're paying for without going in there and going with a new system, right? So I think that's something that it was more of a contractual issue, that we have mechanisms there to motivate those parties to improve their performance.
Yeah. So Don, Walter's saying that Burlington, Vermont has 2 sites. One of them has never worked. I guess that's one of the those are ADSP sites.
Okay, some of those real world problems. Okay.
Yeah. Well, so look at that, man. We had enough questions to take us up to our break time. It's 9:51 right now. We're going to go on break, and we will begin again at 11:05 a.m. See y'all at 5 past the hour, depending on which time zone you're in. Okay, welcome back to the Surveillance Symposium. I'd like to thank Don Taylor for covering the surveillance overview. In this next session, we're going to be talking about the FAA mission, well, the tech ops mission, and what surveillance means to the FAA mission. Technical operations ensures the safety and efficiency of the national airspace system by effectively managing air navigation services and infrastructure. In this session, we will have Kyle Evans, who will be covering operational risk management and significant event reporting. You know, that fits into the how do we, technical operations, effectively manage our air navigation services. We will also have Ken Harris and Mitch Hughes talk about the NAS Defense Program surveillance and how surveillance fits into the NAS Defense Program mission. We'll have Joe Dotter, who's with system operations, and he'll explain why surveillance is important to system operations. And right now, I will turn it over to Jeff Woods, and Jeff is with air traffic, and he'll explain why surveillance is important to the air traffic community. Over to you, Jeff.
Thank you. Good morning, everybody. So my name is Jeff Woods. I'm actually one of the NACA representatives based in DC. I actually attached to the program office. I've been working up in DC for about 8 years.
Jeff, we can't hear you right now. At least I can't. Can anybody else hear Jeff?
Yeah, I heard him. Okay,
everybody can hear me? Okay, everybody's saying, I'm getting notes saying they can. So
okay, go ahead.
Yeah, I'm based with the program office. I work with the directors and above on just a lot of the integration across programs. Over those efforts over the years of being involved in the PMO, I've developed a lot of relationships with some tech ops personnel on working. I'll give one example of SoCal TRACON. We've had some issues down there with some of the surveillance, short range surveillances down there. And we started a partnership, I guess is the best way to do it. A lot of the radar optimization that we've been doing, going back in, rebaselining some of the short range radars, and looking at other problems that we've been developing. And I got to tell you, this has been a great partnership that is proven to be fruitful across other things that we've been working on. So, from the air traffic perspective, it's always challenging getting people to understand exactly how controllers utilize some of the tools out there. Sometimes the requirements don't completely capture the way controllers use things, i.e. false weather, weather presentations on the glass, how do we deal with false weather, even some of the just how we use surveillances like long range versus short range, WAM versus, other sorts of, space-based ADS-B. Those things have been challenging. But what we've got to do is we've got to continue to work together, and NACA is fully on board with working together with both Tech Ops as well as AJT, as well as the PMO, as well as outside of the FAA on not only shoring up what we have in the operation today, but paving that way for the future. We got other big efforts like radar divestiture that we're heavily involved in, making sure that we're right-sizing the NAS on what sensors are available and where we need to downsize in other areas. So it's from the perspective of the controller. We just want to make sure that we're able to see things when we need to see them. The big thing is the presentations when it comes to weather and stuff like that. We're working tirelessly with a lot of our counterparts to ensure that the presentations we are getting are the best that we can possibly have out there. So from the NACA perspective, I even talked with some of my AJT counterparts, and they're aware I'm doing this as well. We value our relationship with Tech Ops. In fact, every day we want to try to increase our how we work together on making sure that we're all talking, making sure we're all communicating on paths forward for certain problems, because we know it's always challenging getting in there with the facilities and getting them to understand not just from a local perspective but from a national perspective which way the agency's going. And NAC is fully on board with working with AJW on how to accomplish that. So, Noel, that's all I pretty much had. Unless somebody's got some questions for me, I wanted to keep it short and quick and to the point.
All right, thank you, Jeff. Just as a reminder to everybody, we're trying to make this as interactive as possible. We will have question and answers after this session. Please submit your questions in Q&A, and we'll turn it over to Joe Dotter with System Operations at this point. Over to you, Joe.
Thank you. And just to introduce myself, my name is Joe Dotter. I'm a staff support manager at the Air Traffic Control System Command Center. I'm representing Jennifer Ross, who would have loved to have been here to do this presentation and talk about the command center and how we use surveillance here in system operations. Unfortunately, today is a monthly meeting with some of the directors, air traffic directors, and airline execs for traffic flow management. So she is in that meeting. So you got me. I was a radar controller in the terminal environment for over 25 years before moving over to system operations and working at the command center. The command center, system operations, deals in a lot of things. Air traffic, we have security, flight service, and traffic flow management. Here at the Air Traffic Control System Command Center, we're located in next to Potomac TRACON in Warrenton, Virginia. Next slide. Next slide, please. There we go. We manage and monitor the flow of air traffic throughout the nation and adjacent countries, producing the safe and orderly flow to minimize delays and maximize efficiency. That's a fancy way of saying our two primary goals are safety and efficiency. Next slide. Oh. And pardon that phone call. So the traffic flow management was started in spring of 1970. It was a Central Flow Control Facility, CFCF, established there at headquarters. In the 90s, the command center itself was created, and we were over in Herndon, Virginia, and moved over to Vent Hill and Warrenton, Virginia, March 2011. And again, we're co-located with Potomac TRACON. We have a nice relationship with Potomac right next door, and we share a lot of the facilities like the generators and other facilities they have here. Next slide. So traffic flow management, a little bit about that. So here at the command center, we don't talk to aircraft. We talk to the airline operation centers, the AOCs. We talk to facility traffic flow management units at all the en route facilities. We monitor the traffic in the entire national airspace system. We have a system called the TFMS, Traffic Flow Management System. It has its own program office, and that's where the surveillance systems come in. The surveillance feeds the traffic flow management system so that we can get a display of all the aircraft operating, not just in the US airspace, but for the most part out over the oceans. And we have data sharing agreements with Eurocontrol in Europe and out over the Pacific, several countries, Japan and other countries in the Far East. So we have quite a lot of coverage. Basically what we do is if you've ever gotten a delay, if you've ever been on a flight where you were flying to New York or Chicago, San Francisco, and you received, the pilot came on, or you're sitting in the departure gate and they say, ladies and gentlemen, sorry, but we have a 2-hour delay going to Chicago this morning. That was us. We put in the delays when the capacity of an airport falls below the demand. So if it's snowing at Chicago and they lose a runway, That drops their arrival capacity down from, let's say, to make it simple, 100 an hour down to 75 an hour. Trouble is, they still want to get as many aircraft in there as possible. So they have hours where they have 90 arrivals. So what the command center does is we put in a ground delay program that basically spreads those aircraft out using time. We are evolving to other forms of traffic management initiatives like TVO, where we can use time en route to space aircraft out. We also have mile and trail, which we use, and the ground stop. If, for example, Washington National Airport here in DC has 3 runways, they all cross. If an aircraft blows a tire on the main runway, that basically shuts down the airport for about an hour. The command center will be notified and we'll put out a ground stop to any aircraft going there. Next slide, please. This is a picture of the main tool that we use. It's called a TSD, or traffic situation display. Each one of those aircraft depicted on there is generated from a surveillance system throughout the country. The TFMS system takes all the data feeds from all the radar systems into a computer program that's located up in Atlantic City, New Jersey, and puts together a conglomerate. This is not actual radar. This is a depiction of the radar feeds that is being provided. You can go to the next slide. This is what it looks like. Right now on this picture, there's active 6,769 flights being depicted. Again, these update approximately every 30 seconds. So it takes the data feed from the surveillance systems, goes through this computer system and comes out and updates these about every 30 seconds. The next slide, please. This shows out over the ocean, over the Atlantic. So since there are no radar units out in the Atlantic, it's a little hard to see on this picture, but some of the flights out over the Atlantic are hollow. You can just see the outline of the aircraft and they're not filled in solid. That's because the system, the computer is estimating them. It's taking them from radar data that we receive from Eurocontrol when they take off, and using the speed, altitude, and the weather conditions, the computer system is estimating them as they come across the Atlantic. And then once we pick them up on our systems, the surveillance systems up in Nova Scotia and Massachusetts, Maine, they'll fill in an actual, they'll update the system so that we can get a true presentation of the position of the aircraft. This is what the system looks like when it's running, and we're receiving data from all the surveillance systems that we have available to us, both in the US, in Canada, Eurocontrol, and around the world. If you go to the next slide. This is also the weather depiction. We get the weather off the radar systems as well. It's gone through the same system up in Atlantic City and depicted on the TSD. Plus TSD has a lot of other information that goes into it, but our 2 primary is the surveillance. And this is the one I was gonna say, the previous slides look, that's what it looks like when everything is operating normally. This is what it looks like when we lose our data feeds. If we lose, this is one where we actually lost the system temporarily in Atlantic City, and it wasn't processing any of the surveillance feeds that come into Atlantic City. And this is what our displays look like here at the command center, and also at the facilities. The system is used in most all the facilities in the US and Canada as well. So we temporarily lost the system and this is what it looked like. But if we lose data feeds from certain parts of the country, like in Florida, we'll see a display like that pop up, or in just the Southeast US, possibly the one there in Georgia and the one in Northern Florida, and also down near Puerto Rico. So again, the surveillance feeds, very important to our system. Let us know where the aircraft are, what the volume is, where the volume is building, for what airports. And again, you know, surveillance is key to our entire system. So that's all I have. If there's any questions, Noel?
Thank you, Joe. Just as a reminder, if there are any questions, please submit them in Q&A, and at the end of the session, we will be having a Q&A session. Let me turn it over to Ken Harris and Mitch Hughes to talk about the NASA Defense Program.
Good morning, my name is Ken Harris. I'm the NASA Defense Programs Manager in Washington, D.C. Here to talk today briefly about the organization with NDP, and then I'll turn it over to Mitch to talk about our long-range radar our long-range radar program. Let me plug in my headset here. So, next slide. First, just briefly going through. Can you hear me? Next slide. Does anybody else see the next slide? Thanks, Mark. Thanks, Ryan. Okay, so briefly, I'm just going to whiz through some of the stuff, and I get to the long information that Mitch is going to present. But NDP, we provide the flight data, surveillance data, communication capabilities, and emerging services to hopefully eliminate vulnerabilities and that are exploited through crime and terrorism. Our strategy is to use external funding. We're an fully externally funded organization, and existing infrastructure, federal infrastructure, and human resources. So the technicians and the staffing out there in the field. Next slide. We do a lot of interface with the OCCs. We manage agreements all across the country and internationally. And a lot of that has to do with national security. The bottom bullet there, again, I'm just whizzing through some of this stuff. If you have other questions at the end, please let me know. But our order for NDP is 6,000.198. Next slide. We have 3 different groups in NDP. The first group is the Resource Services Group. Resource Services is business, finance, and infrastructure. So that's basically our admin section. And then if you need a road at the ARSR or an INDEG building fixed, a roof, the HVAC, something like that, our infrastructure group would handle that. Again, like I said, we're externally funded. Next slide. Externally funded. Annually, we get 35 different agencies that are providing funding for us throughout the next slide. Second group is the technical services, and what encompasses technical services is flight data, surveillance data, voice radio comm, and communication security. Next slide. Flight data, one of their premier products is the ADAPT, Automated Detection and Processing Terminal. And that is used to validate and identify threats and movements of aircraft. We provide that to FAA, DOD, DHS, and Eurocontrol. Next slide. surveillance data distribution. If you're working at a short-range radar, we've probably stopped by sometime during a presidential movement, Super Bowl activity, maybe a NASCAR where there's large volumes of people showing up to increase security for DoD and DHS. We have POTUS movements, shuttle launches, all that kind of stuff to give DoD and DHS some additional radar feeds from the short-range radars, and we call them SDRIs, short duration radar integration. Prior to 9/11, when we were stood up, the Air Force spent approximately $26 million launching AWACS aircraft to try to cover provide the additional surveillance for their missions. Next slide. We have, next slide. We have 22 NAV Canada terminal radars that we collect and feed those to the Air Marine Operations Center out of Riverside, California, DHS facility there. Next slide. Communication security is the mode 4 at the ARSA 4 sites. We're transitioning that to mode 5, and I'll talk about that a little bit later. But basically, if you're a ARSA 4 tech and you're a ComSec responsible officer, CRO, sorry, I forgot the term for a second there. A CRO at ARSA 4s, we've seen you a couple times a year, and we'll be transitioning that to mode 5, like I said. Next slide. We have an agreement with R2508. That's the DoD training operations out at R2508, Edwards Air Force Base, China Lake. Next slide. We also have an agreement with to collect all the data from the minimally attended radars, the MARS, all across Alaska, and feed that data into the FAA network through Anchorage ARTC. And those are FAA, it's a reverse reimbursable. So the FAA is paying for the Air Force radars there. And we use the FAA-owned satellite communication systems to transmit that data back and forth. Next slide. So this is where Mitch will start in. Mitch is the manager for AJW 142 and our en route engineering.
Hi, thank you, Ken. Welcome, everyone. My name is Mitch Hughes. I'm the manager over the Air Route Radar Systems Engineering team in Oklahoma City. Talk to you for a few slides here on what we do for the NASA defense programs. The ARSA operations and maintenance, that encompasses not only the second level engineering, which I'm the manager of, but it encompasses several elements there. It covers the first level maintenance, and that's the ATSS. That's mainly where the bulk of the attendees reside. Second level engineering support, the utilities, all the logistics. We pay for all the parts. The unstaffed infrastructure systems, those are the special projects that the DoD and the DHS fund. Facility support, if you have a roof leaking or something that needs to be fixed at the site, we typically handle that. And then, of course, training. We pay for all the training. Now, this is for all 120 radar sites. We have long-range radars in Hawaii, Guam, Guantanamo Bay, Puerto Rico, Alaska. So 120 total. The TARS and FPS 117s are shown in this depiction, but we're not responsible for those. Next slide. All right. right, so for the second level engineering, that's the long range radar engineering. Go back one slide, please, Ryan. So we have three teams. We have a hardware engineering team, a software engineering team, and we have a test and engineering support team. I'll cover those briefly. The hardware engineering team, we're responsible for all hardware modifications to the radar systems, and that's the full research and development from concept all the way through implementation. We have labs. We have a Carcer lab, and we share an ARCER-4 lab with the Academy. We have a full suite of support equipment, so we can duplicate any problem that's seen out in the field and see if that needs a modification or if there's something we can do with software. Our software engineering team handles the coding of both the Carcer and the ARCER-4. With our subsystems, we maintain over 2.5 million lines of code. That's a big lift for our coders. We do develop new software, and we provide upgrades on all of the code. The test engineering team, they're integral at each step of our project management. So from the unit test through the integration test, our test engineers are working with our hardware engineering team, our software engineering team, to ensure that what is put in the field has been fully tested. That does include regression tests so that what we put out has no problems. The direct engineering field support, that second level engineering support, it is there to maintain the highest system availability possible. We'll talk about that on the next slide. And then, of course, technical documentation. My office is the Office of Primary Responsibility for all of the long-range radar technical instruction books and the maintenance handbooks, orders, whatever technical documentation. Next slide. So the DoD and the DHS provide the 50-50 cost share to support the radar systems. And their expectation is that they have as close to 100% availability as possible. So we're working with the Joint Program Office and the LRR Joint Program Office almost daily, and they have their finger on the pulse of the data. So if something goes down, we're talking about it. We work hand in hand with the Air Force 84th Raids. That's the Radar Evaluation Squadron. And things that the engineering support team sees are fed back into the hardware software engineering teams to create modifications. That information is also given over to the logistics center so that changes can be made, maybe in areas where they are fixing parts. And so we work with logistics center almost daily as well. And then we provide quite a bit of information over to the Academy so that they can tailor their instruction appropriately. My team monitors radar performance. We use DRAMs, we use the RMLS interruption reports, we look at mass data, ERIT data, and then we look at logistics center parts usage. And this is something that we look at daily, multiple times a day. So one of the items we have up in our office is a radar or a panel that shows all of the radars and if they're up or down, and so we can respond immediately. So when we do respond, we're responding to a full outage or a loss of redundancy, reduced equipment, and that's dictated in 6000.198. We're looking for negative performance trends. We're looking for intermittent issues, and we're going to reach out to the ATSS. We're going to pick up the phone. We're going to call and discuss with them what we're seeing. and to offer any type of assistance that we can. A lot of the time, we can help fix it over the phone. FaceTime and other tools are in high use right now during COVID. So there has been much traveling for on-site support, but there has been some. If we feel the need or are requested to, we will go on site to help fix that and restore that system as quickly as possible. In the meantime, the escalation policy is in full effect, so the SSC manager pushes that up. So this is happening in conjunction with the escalation policy. Next slide. All right, Ken, I'm going to turn it back over to you.
All right, thanks, Mitch. So yeah, I want to talk a little bit, quick brief on mode 5. We're transitioning the ARSA forest from mode 4 secure link to mode 5. And there's 53 ATCBI 6Ms. 32 of them have current IFF mode 4, but we're going to be transitioning all of them to the mode 5. They'll have the equipment. They may or may not have the functionality. So that project should be done. Tony Whipple is leading it. It should be done April of 2021. Next slide. This slide is just a depiction, a little graphic of the different mode 4, ARSA 4 facilities out there. Next slide. And Mitch previously mentioned this about the restoration. Next slide, Ryan. Okay. Mitch previously mentioned this about restoration. So 6000.198B, no matter if it's a reduced service, a single channel, a standby equipment, anything like that, 6000.198 requires us to treat that as a full outage and a full service interruption. So there's a 4-hour response time. If there's as written in the third or fourth sentence there, if there's some inclement weather, if there's road conditions, or you're close to the fatigue policy hours, 14 hours of working, we understand. We don't expect you to go out in inclement weather and try to battle the storm to get to restore the radar, but we do expect a 4-hour response plan. So if it's 8 o'clock at night, there's just a lot of snow coming down, and it would put the technicians in harm's way. We would not expect anybody to go out to restore the radar, but we would expect the next morning after the snow clears and you're able to get to the site. Maybe in the mountaintops, you might even have to take the snowcat up there, but we would expect a plan how that radar is going to be restored within 4 hours. And then the bottom paragraph below the restoration response, table 1.4, below that, the underlined part, the facilities for NDP, primarily ARSERs and NDAGs, Nest Defense Air to Ground facilities, are the DoD and DHS and other agencies are paying for full mission capability. So this order authorizes P1 for all parts, priority 1 parts ordering. If there is if there's something else that some other reason that they cannot be ordered P1, then I'll approve that. If there's a need, I'll get into the discussions and I'll approve that if we can get a good justification for that. So Noel, that's it. Back to you.
All right. Thank you, Ken, and thank you, Mitch. Let's turn it over to Kyle Evans.
Thank you, Noel. Appreciate it. Kyle Evans, I'm the Eastern Service Area Technical Services Operations Group Manager, also known as TSOG. I'm going to talk briefly today about operational risk management and significant event upward reporting. first talk about ORM. So risk management, it does not matter your experience level or your role in the organization. We expect everybody to share their concerns, engage with others, because we're always more effective in the group format. The more people that talk about it, the better the plan's going to be. It's really important right now, as is evidenced by the pandemic situation, where we are not generally meeting in meeting rooms. We'd have a conference table. We'd all sit at the table and talk about the event that's gonna come up, maybe some kind of a modification or some kind of a replacement project. These days, we're doing a lot of virtual meetings. So it's especially critical now that we have those full out discussions and we talk about all the possibilities. The ORM principles are communicate, coordinate, and mitigate. And we'll talk about that in one moment. Next slide, please. So communicate. Let's make sure we talk about all the potential impacts. What's the worst case scenario? What could possibly go wrong in the worst case? Always take the opportunity to consider that, because things, as we all know, don't always go as planned. Coordination. Coordinate with the appropriate control center, but also have those informal conversations with local air traffic and others who are impacted by the event to make sure that we've talked about everybody's concerns and finally get that final coordination in with the control center so we can get it all documented and planned. And then finally, mitigate. You can mitigate some of these activities by scheduling for the least impactful times. Ensure you have the proper personnel available. Again, during these times, right now, we have limited staffing, not only on the tech ops side, where we're not all in the room together and we're staggering our work activities at the facilities, but also air traffic's doing the same. So they may not have the controllers on duty that could assume alternate procedures. So if something goes wrong, they may not be able to respond as quick either. So keep that in mind. Do we have the proper people available? Test all your backup systems. Make sure that offline channel is operational. Make sure that adjacent radar is good to go. Make sure your radios are tested, PAT 2000s. Have a good plan. If it's a complicated task, document your plan. Have good plans, some kind of a plan that you can go back to and review so people know what steps to take. If you have to backtrack to a different system configuration, make sure you know how to do that. Next slide, please. So just to wrap up on the ORM, it's everybody's responsibility. It's the detailed explanation of ORM is in 6015. So please take a moment to review that, keep yourself up to date. I'll talk a little bit more about upward reporting, and it's kind of interesting that we had air traffic, we had SysOps, and then National Defense Program talking to us about how important and critical the surveillance systems are out there in the NAS. It's so important that we maintain constant communication on what the status is of our facilities. So when we talk about becoming aware of an event, the SSC must provide notification to the appropriate control center immediately. You should do an initial assessment as well. An initial assessment could be looking at a control panel. It could be looking into mass or some other sort of interface device, or it could be that you have to go out to the facility and physically enter the building to see what's happening. Once you know more about what's happening, the SSC employee must call the appropriate control center and or SOC to provide a description of what has occurred and to the level of detail possible. Next slide, please. So here's some examples of what kind of events require reporting. So at any facility, no matter what facility it is, any full or partial evacuations bomb threats, elevator failures where employees are stuck, breach of physical security that affects the operation of the facility. And there are there's a total of 16 examples in Appendix B of 6030.41. I won't go over all those today. Next slide, please. Skip this slide, please. Next slide. These are the types of events that are at facilities that are listed in Appendix C, which I'll follow up on the next slide. But the types of events that require upper reporting: full reduced equipment and reduced service, unscheduled interruptions, any unscheduled event where there's a loss of critical or essential power components. And again, there are 16 more examples in Appendix B of 6030.41. Next slide, please. Here are the facilities that require notification. You'll notice on this list, there's some facilities that make sense. Our large TRACONs, our ARTSIs. There's also some additional facilities listed that are of special interest. For example, Joint Base Andrews for obvious reasons, and then the Tech Center, Aeronautical Center, the NEMC, and the Command Center. Next slide, please. Time guidelines. Here's what's really important. Initial notification. You must report within 5 minutes of becoming aware. How you became aware, there's multiple ways of becoming aware. You could have witnessed something yourself. You could have been sitting in an equipment room and heard an audible alarm and discovered something was out of service. It could be that air traffic has notified you, local air traffic has notified you, or quite possibly one of the SOCs or the OCC had made that notification. But at any rate, you've been made aware of it. You need to make sure that if it's not coming from the OCC or the SOC, that they're made aware of what's happening. Okay, then an update notification. This is very important as well. So hypothetically, if you were notified of a radar outage, for example, and you went to the control panel and you looked and you saw some indications that indicated to you this might be just simple as a channel change. It may be an overheat function, whatever you discover, within that 30-minute period, provide an update. That way, the OCC knows that you are making some sort of progress. You have a somewhat of indication of what it might be, whether it's catastrophic or just some small issue. But nevertheless, that 30-minute update is very critical. The 30-minute update may be that you just made it to the site and you've walked in the door and you notice it's very warm in the building. That's very important information for the control center, so they can upper report that as well. And the command center can start making some of those decisions about traffic, as indicated earlier by our sysops. And then if those events go on for longer durations, you don't fix it right away. It's not restored right away. Every 2 hours, you must give an update, whether there's a change in conditions or not. So every 2 hours, we expect an update. This is real important when you're talking about a facility at a core airport. For example, if we were to lose a runway, I believe we talked about at DCA, if something was to go wrong there and we lost all the runways, then certainly the command center needs to know that so they can start making those traffic decisions. Next slide, please. I'm going to wrap it up. Real-time notification of NAS events is essential for the safe and efficient movement of aircraft through the NAS. Traffic management decisions require the most complete and current information possible about the status of NAS systems and services. Our stakeholders rely on the information that the FAA provides to make those operational decisions. So once again, command center is talking to the airlines are making decisions that could save them money, get their passengers safely where they need to go. It's very important that we constantly maintain communication, even if we don't know what the problem is yet and we're not making progress. We'll talk about later this afternoon, I'll talk a little bit more about how you get help and if you're running into a problem that's giving you fits and you can't get past it. But with that, 6030.41J is the order. And I'm going to turn it back to you, Noel. Thank you.
Thank you, Kyle. Just as a reminder to everybody, hey, there is no local NAS, right? We must communicate, coordinate. If all of our panelists could turn their video back on, we do have a couple of questions in the queue. And just as a reminder to everybody, if you do have some questions, please submit them in the Q&A. So the first question is, are military aircraft required to utilize the ADS-B system?
This is Ken. I could answer that, but PMO has the responsibility to administer the MOU around that. There is a specific ADS-B out procedure, and Ms. Bristol asked me to work with the Pentagon on that one to renegotiate that. So there is a way, there is a process for aircraft on a certain military missions to disable their ADS-B transponder.
Okay. Thank you. The next question comes from Russell Jacques. Is there a schedule for the send/listen rollout for CSA WSA? If we had send/listen, we would not have to disconnect the 6250 network and go back to the 3600 modems. Mitch, is that you, Mitch? Or Ken?
Noel, that sounds like some automation in the center.
Okay, so we'll take an IOU on that one then. The next question is, it comes to us from Donnie. Who are the NDP liaisons for each of the service areas?
I'll take that one too. Eastern service area is Eric Neal. Central service area is Dan Bush. And Western service area is Scott Bevos. We also have an Alaska liaison, CJ Cohn.
Okay, thank you, Ken. Any other questions out there? We currently do not have questions in the Q&A. I'll give y'all a couple of seconds to type your questions up and put them in there for our panel.
Noel, I just got a text said if they're interested in learning more about that, talk to Claude Nunez out of Niceo for the what was that first question?
The one going back to the 3600 modems?
Yeah.
Yes.
Yep.
Okay.
Claude Nunez. Send him an email and we'll figure it out.
Yeah. So we'll make sure that we do that also. Okay. So there are no other questions in the Q&A. I'd like to thank our panel of experts. Thank you, Joe. Thank you, Mitch. Thank you, Kyle, Ken, and Jeff Woods. Thank you very much. Just a reminder, you can always be putting questions in the Q&A. We will have questions after each session, and we will have a question and answer session at the end of the day. We're going to go on break right now, and we will be coming back to you at, where is it? At 1 p.m. Eastern time. So we'll go on break right now, and we'll see you back at 1 p.m. Eastern time, where we will be going over all of the organizations within the surveillance community, and then we'll also be going over how to get help. Good afternoon and good morning, depending on which time zone you're in. Welcome back to the Surveillance Symposium. Again, my name is Noel Cavazos. I'm the OESG manager in the Central Service Area, and I will be your moderator this afternoon. We have two topics that we're going to be covering this afternoon. The first one is the surveillance community and all of the organizations that make up that surveillance community. After that, we'll get into how to get assistance. Just as a reminder, after each session, we will be having Q&A. Please submit your questions in Q&A, and at the end of the day, we will be bringing back all of our panelists for an end of day question and answer session. So let's go ahead and get started with this afternoon. I'll turn it over to our keynote speaker, Tom Rainey. Tom, over to you.
Thanks, Noel. Appreciate it. Hello, everyone. Welcome to the after lunch session. I hope you're not too full. My name is Tom Rainey. I'm the SSC manager in Louisville, one of them. I do have the surveillance specialist underneath me. My career in the FAA started about 18 years ago as a surveillance ATSS, so I'm well aware of what it's like, and we still worked on the ASR 9 back in those days too. I lead a talented group and a successful group of surveillance ATSSs whose efforts help to flying public and cargo travel safely and efficiently around the world. So remember that the technical operations mission statement drives us to ensure that safety and efficiency as we manage air navigation services and infrastructure, and that the eyes of the NAS are the surveillance systems and the air traffic controllers that use surveillance. Surveillance is the foundation for our success in meeting the goals of our mission. And you, the surveillance ATSS, are the foundation for maximum availability of surveillance systems and services. So let's talk briefly about your role as a surveillance ATSS. You've already heard and learned from air traffic why surveillance is important to them. And the surveillance ATSS is part of the air traffic team. You are the frontline support to ensure that these crucial tools are available for our air traffic partners and stakeholders. You perform critical preventive maintenance on a recurring schedule designed to prevent the surveillance systems from failing. You also perform risk management to determine the best time to schedule your maintenance so that you reduce the risk and impact to the operation. But when unscheduled events occur, and they will occur, you provide safe, timely response to diagnose and resolve surveillance issues, restoring critical air navigation. Your knowledge and efforts keep delays to a minimum. But it does take the entire surveillance community to accomplish our mission. From the program office to logistics support to first and second level engineering support, all of these functions are part of the support structure for you, the surveillance ATSS. And you'll hear more in this hour from these groups. But remember that these resources will be critical to your success at the service delivery point, and you will call on them regularly to keep your assigned facilities and services fully operational. Also, as part of the surveillance community, you might help out other adjacent SSCs by providing technical support, on-the-job training, and possibly performance examinations for their surveillance ATSSs too. So it truly is a community, and we do help each other. Now, as an SSC manager, how are you important to me and my organization? You know, I'm entrusted to manage specialists that keep the NAS equipment operational and available for use, and I take pride in leading the cadre of specialists that are part of an airport team that gets people and cargo safely to their destinations. You know, we are the service delivery point in the NAS, and the level of effort from the SSC surveillance ATSS can make or break the safety and the efficiency of the whole NAS, and not just at your airport or my airport. Without successful specialists, you know, we'd struggle to keep radars providing surveillance data. And this might create delays and risky flight operations. So when those unscheduled events that I spoke about a moment ago occur, you know, my surveillance technicians communicate their maintenance efforts to me regularly and timely. They keep me abreast of the situation. You've heard Kyle talk about the 530 and 2 upward reporting requirements. You know, and timely communication allows me as the SSC manager and liaison to stakeholders to communicate the status so that they can properly plan mitigation strategies to reduce the impact of any outages on their respective organizations. And it's these efforts by surveillance ATSSs
They help keep the relationships with our peers in air traffic and our external stakeholders positive, successful. And I, as a manager, am only successful when my specialists are successful. So to wrap it up, I want to, before I hand it off, to the next speaker, just a quick note to say that there's connectivity to the world beyond your SSC and your airport, and the surveillance system that you maintain and its data are disseminated to multiple other recipients. We got a really good briefing from the command center on TFMS, the traffic flow management system, and how they use that data to manage traffic flow in the whole of the NAS. There's also ASDI data that's disseminated via SWIM that goes to the airlines, and they use that data for their operations and dispatch centers for their own specific uses. And the last thing I'll mention are the pilots themselves. With the ADSB requirement that's also been mentioned previously, there's a ADSB-N function that allows pilots to have a situational display with them in the cockpit that gives them a picture presentation of what air traffic looks like in a short range around them. So your surveillance data from your radars are going to lots of places to make sure that we maintain a safe and efficient NAS. Thanks for hearing me out. And now let me welcome Mr. Ken Harris. He's going to give us a little brief about NASAO.
Hi, I'm part of the NASAO group. I'm one of the group managers for what we call AJWB 6, one of 5 organizations in NASAO. So since I had the NDP connection and I'll be on the call, our director Dave Musil asked me to speak to the how surveillance and the NASAO group, the group I work with, interact. So everybody knows, you got to call the OCC and get an outage, but there's a lot more to NASAO than just calling the OCC. So we have AJWB 100. That's the enterprise group. That's the NEMCs. So the TFMS, traffic flow management. We get all of the data from the field, goes through and is managed by the NEMCs through traffic flow management. Wide area augmentation system, Don mentioned that earlier, is part of B100 also. B200, we mentioned the modems, the 3600s, a little earlier after my briefing. And B200, Claude Nunez's group, the telco group, is responsible for all of the telecommunications. We're transitioning from FTI. We're putting on a new solicitation for replacement of the FTI network. That's called FENS, F-E-N-S. And so that's a big part. That's a big thing that the telco group in NASAO is doing. They're responsible for telco operations, east, west, central, telco service teams, and enterprise data services team. B300 is the OCCs, national OCCs. We've transitioned to the one OCC now. Now you know that there's everybody should be calling just one number. So that was a huge transition, and some awareness and some new ways of doing business there. The enterprise control centers with SWIM, voice datacom sub-teams, and surveillance nav sub-teams are also under B300 national operations group, and the cyber operations group. So if there's ever if you ever think that there's something going on, you can't understand why something's happening, and it could be cyber. 2 different groups in NASAO work on that. The National Cyber Operations Group out of the command center works on that. And then the next group that I'm going to talk about, B400, the NAS Information Security Group. B400 is more around policy and cyber risk management, the ATO technical cyber management of cyber across the ATO, and a lot of stuff to do with B4, the we call it NISG, NAS Information Security Group, is responsible for the ops integration, for the international engagement, planning exercises, so cyber exercises, system integration, outreach. If there's a new system, they go through the whole system and figure out if there's any security risks that could potentially come up in that system. So if you're going to plug something into the network on the admin side, that's the IT people. But if you're going to plug something into a NAS system, then we need to engage B400, NAS Information Security Group. B500 for NASAO is our operations group, and they're responsible for finances, resources, training, certification, that kind of stuff, and then tactical. The TOAR, every once in a while, if there's an aircraft accident, you'll have to call and interface with the TOAR, the Technical Operations Aircraft Accident Coordinator. Technical Operations Emergencies, the FIR team, the Field Incident Response Team, they're under that. Continuing operations, continuity of operations is under B600. A lot of the policy and procedures, all of that kind of stuff is under B600. And then maintenance of the RMLS and national node for the data repository is under B600. And then, of course, I presented B700, which is my group, the NAS Defense Programs Group. So that's it for NASAO. Again, back when I was a tech, all I knew about was, you call the OCC and coordinate the outage, report the outage, enter the LIR, that kind of stuff. But NASAO is a lot bigger than just the OCCs. That's what I have for that. Noel, back to you. Or am I handing it over to Rick? Maybe Rick's next. Is Rick Cecil next? Sorry about that.
Yeah, good. It's all right.
Hey guys, I believe I'm up. You can just go ahead and move it to the first slide, Marzan. Hey, good morning, everybody. My name's Travis Simmons, and I'm a NOM over at Southern California TRACON SOC, also known as the Service Operations Center out in San Diego. And what I'm going to do today is just kind of cover how a TRACON SOC helps to ensure the radar you certify for the NAS is able to be used with confidence by air traffic control. I'm going to start at the ground, and we'll go through the terminal airspace, and then I'll hand you off to my co-presenter, Richard Cecil from the Oakland Center SOC, and he'll take you up to a bird's eye view at 35,000 feet, and he'll give you an idea of what a center SOC does to ensure the same quality and monitoring for radars. Let's go to the next slide, please. Terminal radars cover about 60 nautical miles in the TRACON airspace, and we've got ASR 8s, 9s, and 11s. They're all co-located with a secondary sensor mode S or ATCBI. And the TRACONs also utilize long-range radars with ATCBI. We've got ADS-B data that we fuse into STARS. And we also get ASDI feeds that the traffic management unit uses for traffic management purposes. Next slide, please. Now let's talk about how crucial what you guys do in the field is for us at the TRACON. Starting over at the tower here, you can see the controllers are utilizing both STARS and the ASDI to ensure efficient and safe arrivals and departures in and out of their airspace. Once the aircraft gets handed off to the TRACON, your radar becomes the eyes for the controllers on position. Radar is crucial for any phase of flight, guys. It's important to remember that. Next slide, please. In fusion mode, which is the preferred mode for STARS operations, one sensor failure will have a limited effect on how air traffic directs the airspace. In the event of a sensor failure in fusion mode, targets are still available and considered valid as they can be correlated to the other sensors tracking that target. Loss of 2 or more sensors within the fusion mode can have an adverse effect on operations. Over at SoCal TradeCon, we try to only allow 1 scheduled outage at a time to mitigate this. And I know there's some other large TradeCons that also handle their outages similarly. We've also got an ADS-B feed that comes into SoCal TradeCon, as well as a WAM sensor. And we have those fused as well, just as a regular sensor. Air traffic really likes ADS-B because of the high scan rate and the quality of target data in areas with poor or unreliable legacy radar coverage. One of our areas, a really big concern is Palm Springs area. We don't have real good legacy radar there. And getting ADS-B in there has really helped out a lot. And as you can see from the slides here, all of these sensors and systems come together in one single service delivery point to paint the picture of the TRACON airspace for the controller on position. It's the SOC's job to monitor and control all of these feeds, as well as coordinate system outages with air traffic and other users, ensuring a reliable and quality product for the NAS. Next slide, please. Over at the TRACON SOC, we utilize a STARS maintenance display as the primary indicator of radar services. We can view exactly what a controller sees on their position if the need is required. It's also a really good troubleshooting tool to verify radar feeds entering the building. And here in this slide, you can see I've just got a picture up of what our maintenance display looks like. And that's exactly what the controllers are using on their position. So, you know, if we get a call that there's maybe some false targets or drop targets or a feed is not working at all, we can run over here and see it in live time. It's really handy to have, and we use it quite a bit. Next slide, please. All right, and here we have the MCW. And what we would do with this is we can look at the quality and validity of radar data through reports and STARS. This also allows for monitoring of the service delivery points that are coming in via FTI. And what we've got right here, that's exactly the MCW right there. That's the screen. We can pretty much do anything to STARS with this. Basically, we use it in the SOC to look at that small box you see right there, the sensor interface. And that gives us an idea of what our sensors are doing. So right now, if you look at that, you'll see the darker maroon box that says offline. That's indicating that that particular sensor is offline at the moment. So right there, QLA is offline. Everything else there you see is either, it's just an alert, maybe a status change, something else. Those are all online. So we can go over here and take a look real quick and see if we've lost a line from FTI. Next slide, please. On this one, we've got the ASRs are monitored remotely via MAS and the dresser. Mode-S is monitored via MAS and a remote monitor terminal, or RMT. All of these are at the SOC. TRACON SOCs are capable of controlling both the ASR and the Mode-S remotely. Mode-S functionality has automatic channel switching. So if we lose an online channel, the Mode-S is going to automatically switch over for us. It doesn't require any intervention on our part. Unfortunately, the ASR doesn't have that functionality. So if we lose an online channel on the ASR, we've got to go out and actually change the channel ourselves. So that could cause a problem. So we monitor the ASRs real close to make sure that we can mitigate that hazard. And the slides here, you can see the first picture on the left there, that's what the dresser is. And basically, for you techs out there, you should recognize this. This is exactly a picture of what you've got on your radar at the site. We can change channels, high voltage on off, turn the antenna on and off, same exact functionality you have. Up on the top right there, that's the MODES RMT, kind of similar to what you guys have in the field. And as far as functionality goes, really, we can just change channels, drop to IBI for you, that sort of thing. And it gives us an idea where we're at. If you look at that picture right there, there's a red box on one of the sensors, and that means that particular channel, the MODES mode is unavailable there. Everything in yellow means it's in standby and available. And then down at the bottom there, right-hand corner, that's just our mass display that we look at. It gives us state changes, alarms. We can monitor the radars there. We might see something pop up that gives us an idea that we need to walk and take a look at the dresser, see if our channel maybe has failed. Next slide, please. All right, then the TRACON SOCs are responsible for all coordination between air traffic, other government agencies, and various other users of terminal radar feeds. This can sometimes mean the SOC will have to make over 20 different phone calls to coordinate an outage request. So you guys out there, remember that when you call for a quick on-the-fly outage, it takes a little bit of time to get that done. So we don't like doing it unless we have to. Also, NOTAMs are required for any scheduled or unscheduled radar outage, and the SOC will issue those. And then what you see here, that's exactly what we see at the SOC. When we coordinate something, those names and numbers on the left-hand side there, that just gives you an idea of the different entities we have to call to get an outage. And, you know, sometimes they don't want to release the radar. That's not us doing that. You know, air traffic needs it and we can't release it to you. And then down there at the bottom, that's just what a NOTAM looks like. I know you guys don't get to see it out there in the field. So, you know, it's good for pilots. They'll know if maybe the airspace they're flying into doesn't have the radar coverage they're expecting. Air traffic takes a look at the NOTAMs as well to see what's coming up on the schedule. Now that I've given you a brief overview of how your radar is utilized and monitored at a TRACON SOC, I'm going to hand it off to Richard over at Oakland SOC, and he can give you an idea of the en route stuff. Take it away, Rich.
Thank you, Travis. Good morning, everybody. My name's Richard Cecil, and I want to thank Ken Harris for scaring me to death there a few minutes ago. I was out of sequence. I am a NOM at Oakland Center SOC, and as with the TRACON, coordination with adjacent facilities and external customers is a large part of the surveillance coverage, monitor, and control process. Much of what Travis has shown you is repeated here in the ARTC, so I'll try to avoid duplication. The big picture always controls the decisions that are made when taking surveillance sensors out of service. This includes adjacent radars, nav aids, and other facilities that can impact air traffic procedures. Many of the outages are low impact, particularly due to the large overlap that we maintain. Almost every surveillance outage results in a change to the procedures for the controllers and thus has an operational impact that we need to keep in mind. Once your aircraft climbs out and enters the ARTC control, it won't take long before your plane is off the TRACON scopes. The radars that feed an ARTC are 200-mile radius and rotate more slowly, around 12 seconds per revolution. They overlap each other to give full coverage of the ARTC airspace, and they overlay the TRACON radars underneath their airspace to be able to pick up the aircraft before it leaves TRACON airspace. They can also provide emergency radar data to the TRACON in the event of short-range radar failures. Next slide, please. This is a Google map image of the West Coast with Oakland Center ARTC airspace overlaid. ZOA ARTC uses inputs from 10 long-range radars and 1 ASR located down in Fresno, which is a gap filler for the Central Valley, particularly south of Fresno, where radar coverage by Sacramento and Paso Robles can be a little spotty. ZOA ARTC uses fewer long-range radars than most other centers because our domestic airspace runs up against the Pacific Ocean, where the ATOP oceanic system takes over. Next slide, please. This the same image with 4 of our radars shown, along with 200-mile radius circles to show their overlap. The ERAM system in the ARTC will prioritize the radar returns to provide the most reliable picture on the radar scope. ERAM uses sort boxes for this function, which identifies a specific location in the airspace on a grid and maintains a list of radars that can see a target at that location. Looking at the overlaps, it's easy to see that a target will be seen by several radars at any given location in the airspace. Through software adaptation, we can choose which radar will be first priority, second, third, and so on. If a radar fails, the adaptation will fall to the next highest priority sensor to keep the target on the display. Next slide, please. This one shows the overlap for all 11 radars that feed ZOA ARTSI. It should amplify the information on the previous slide and show the large amount of overlap in the airspace. Next slide, please. This is a snapshot of one of our M&C consoles at the SOC. It shows the icons that represent each radar feed we receive. It has drop-down menu selections for everything we need to use to control the radar information that's displayed on the scope. Making changes here does not affect the radar itself, only the information seen by controllers. We can disable search, beacon, or weather information independently, make changes to alert modes, and enable or disable functions that give alarms when the radar is taken out of service. We use MAS and legacy Mode S terminals to make changes to the radars themselves. Next slide, please. This is the close-up view of those radar icons. This picture shows that Paso Robles PRB radar has the search and weather disabled. You can see the little gray dashes there next to the green ones, while the green dashes indicate good status on each radar function, beacon, search, or weather. Off to the right are the test radars, QXX and QYY, that provide the simulation targets for certification. Next slide. This is a snapshot of the certification position located in the SOC, which is used to run our online certification scenarios. We inject test targets into the ERAM system and run them through conflict scenarios that we visually verify. This image shows the certification scenario in progress with several targets in different forms of conflict, crossing, head-on, overtaking, etc. Each of these conflicts represents a separate algorithm that must be visually verified daily by the NASNOM. ADSB is also included as one of the available sensor inputs to ERAM that we certify daily. Oakland Center has adapted its radar coverage over the years to provide pretty solid coverage, so the ADSB is very rarely used by controllers at ZOA. Next slide, please. This is a single site selected on the RAPI, which shows us the alarms, the site status, and performance. The RAPI provides us a look at the radar data as it arrives from the sites before it reaches any systems inside the ARTSI, which allows us to quickly discern internal or external problems. Next slide, please. The default view that we use on the RAPI is showing all 11 radars. This is the one we typically leave up so that we can see them all at a glance. And the next slide. This is a very high level overview intended to generate discussion or at least interest in a deeper dive. And at ZOA SOC, we've always tried to work with field radar techs in particular to give them as much of the big picture as possible so they can understand the decisions that are sometimes made. This understanding by field techs is invaluable to us when we're coordinating outages. I hope the audience can take some of this information and use it to better their own procedures and schedules. And I appreciate your time. Thanks for listening.
All right, thank you, Richard and Travis. I'll turn it over to Jeff Bogan. Turn it over to Jeff Bogan.
Good morning, everyone, or good afternoon. My name is Jeff Bogan. I'm the manager for WSA's Operations Engineering Support Group, known as OESG. It's really great to virtually reach out and connect with this team of specialists that supports your surveillance systems in the national airspace. Quickly, just to let you know, I also love radar surveillance systems. For over 17 years, I was a senior engineer at the National Center for Atmospheric Research, designing, testing, and deploying radar and weather systems all over the world. We actually developed in the 80s the prototype systems that are used today in the FAA, like the ASR9 and the WSP, our NEXRAD, the TDWR, and even that one-of-a-kind LiDAR system, which we use in Las Vegas to detect wind shear in dry climates. You know, a LiDAR system is technically a radar. It does range and Doppler processing, so it's a radar, and a really interesting one. I've been with the FAA now for over 20 years as a radar and scientific software engineer, then as a radar automation frontline manager, and now as WSA's Operations Engineering Support Manager. So I really feel connected and close to your day-to-day support work and all the challenges you have in the field. Taking care of some of the coolest, the most complex electronic systems we use in the NAS today. The specialists, radar specialists, have to have special knowledge. There are very few folks that really understand radar systems. You are in a very unique crowd, and you should be really honored to know about those systems. So over the next 2 days, I'm going to speak about a few of our most important surveillance community challenges and initiatives that are going on, and that you, the system specialist, the radar specialist, are a big part of. First, though, I'd like to tell you briefly what the Operations Engineering Support Group is all about, and we know it by the acronym as OESG. OESG is part of our service area's Technical Operations Organization. It's one of several groups in the Technical Services Organization, and each service area has one Technical Service Organization, and correspondingly, there are 3 OESG organizations, one in each service area, one in WSA, one in CSA, and one in ESA. And really, their mission and support is very much the same in each service area. So let's look at what we do. Next slide, please. So fundamentally, the OESG core mission is simply to provide first-level operations engineering support to the districts and out to the SSCs, with the focus on NAS restoration. I'd like to break OESG's overall support into 4 key areas. Most important, NAS restoration. Then we do engineering analysis, engineering consulting, and what we call is enhanced technical support. In our most important function, NAS restoration, we assist the district support specialists with the diagnosis, the mitigation, and the direct on-site support for difficult site restoration and corrective maintenance issues on automation, communications, surveillance, navigation, and VisAid systems. And in CSA, we also have some engineering support on our power systems as well. In the area of engineering analysis, we do system level analysis. We look at multiple systems and how they feed into the ARTCs, how they feed into the TRACONs, to understand that broader picture of services from the equipment out to what the air traffic controller sees. We also do line of sight and radar cross-sectioning modeling, signal and space engineering for radar, but also we do modeling for communications, for navigation coverage modeling, and overall service improvement initiatives in all of those areas. OESG is responsible for engineering assessments and contingent mitigation strategies for over 30,000 obstruction evaluations and non-rulemaking proposals each year. In fact, over the last several years, we're up to 60 to 80,000 cases per year. That's a really large and important workload for the OESG. And we could use some help. So if you are interested in doing a virtual detail with some of our teams, and you want to learn about obstruction evaluations and how we process and look at that data, then please give me a call, because we need your help. Later in the symposium, I will look a little closer at construction impacts and what we look for there. So you'll really go into detail with that. Next slide, please. In the area of engineering consulting, we publish technical policy for service area technical advisories, that's SATAs, for letters of authorization, LOAs, and for our national maintenance alerts. Another really important thing the OESG team does for the field is we are a strong service area field advocate on multiple national work groups to discuss changes on all the NAS surveillance equipment, on our associated FAA handbooks, on our directives, and future equipment and field service delivery developments and challenges that the PMO has and that all the platforms of surveillance has as well. And in the area of enhanced technical support, OESG provides for navigation, we execute the ILS continuity of service outage required for on-site support and tracking investigations. This is particularly important for the FAA navigation program, and it helps to ensure the availability and the reliability of our Category 2, our Category 3 ILS systems. And in fact, we're looking at the availability and reliability on Cat 1 systems as well. So that keeps the radar engineers pretty busy. We also provide training opportunities to enhance field technical proficiency and provide training in nav and comm and surveillance. We do surveillance improvement meetings. We do technical interchange meetings. We call those TIMs. And OESG also supports our core NAS principles training called CMPC. This is a big piece of what our organization, the Tech Services Organization, provides. You'll hear more about that from our TSOG organization. And I'm going to speak more about NAS surveillance training a little later in symposium, because we've got a whole host of training from RDAS to CMPC training that's specifically developed for the SSCs and districts. And finally, a very important subgroup in the OESG team is our National Airspace Technical Evaluation Program, known as NASTEP. It effectively executes our quality control function for the entire Tech Ops maintenance program. And I'm going to spend a little more time later in the symposium sessions to discuss NASTEP in much more detail. So that's OESG in a nutshell. In total, the 3 OESG teams, we have about 25 engineers in total, and you'll find an OESG trifold for each of the service areas with the names of the folks, their specialties, and their phone numbers in the artifact site that you can get off the website. So please get a copy of that, and you're certainly encouraged to give any of those engineers in any of our service areas a call if you need support, or if you just have a technical question you want more feedback on. So for right now, thanks very much for your participation. And now I'd like to hand it over to Kyle Evans, another important group in our technical service organization, the TSOG. Kyle, over to you.
Thank you, Jeff. Brian, if I could have the TSOG slides, please. That would be the TSOG slides. This slide's later today. Sorry about that. While Ryan's looking for the slide deck, I just want to mention that I too, like Jeff, have an extensive radar background. I was a radar specialist in the Navy, actually worked on the ASR-8 for the Navy. I worked as an ATSS for 8 years, both in terminal and en route surveillance maintenance. And then I was 8 years as a SSC manager for a radar automation system. And like OESG, there are 3 TSOGs, 1 in each service area. We complement the OESG. We work very closely together. Next, no, that's not going to be it either, Ryan. No, sir. They should be numbered right after Jeff's slides. I'm going to try sharing my screen. Let's hope this works.
Yeah, Kyle, would you like to work on that in the background, and we can move over to somebody else and then come back to you?
Absolutely, sir.
All right, so let's go over to Mark Michaud with second level engineering and AJW 14. Over to you, Mark.
Thanks, Noel. So I can share my screen if needed, but I sent it in. So Ryan, do you have them? There we go. Very good. Okay, so yeah, I'm Mark Michaud. I'm in Oklahoma City. I'm one of 4 second level engineering group managers. We have 2 in technical operations and 2 in the program management organization. So what the PMO focuses on is automation, and what we focus on in tech ops is the NAS systems and the enterprise support software tools. So for us in AJW 14, we have surveillance, navigation, and weather. And the next slide, I just highlighted what I felt would be important for the surveillance community. So our NAS responsibilities in second level engineering is really to drive the preventive maintenance strategy. And that really is over the life cycle of the equipment, how do we ensure we're going to have safe and reliable NAS services? We try to be data-driven and cost-effective with that. So that translates in the maintenance orders, the PMs. So those out in the field that perform those on a routine basis. Hopefully you understand, and it's obvious that there is some nexus to value, that we're asking you to do things that translate to safety and reliability. We do make sure personnel safety and operational risk management are factored into our procedures. So we're always open for feedback. If there's anything that you see that can be done better, please don't hesitate to contact us in second level engineering. We'll definitely gladly accept that feedback. The system modifications, the software modifications, that's one of our core competencies as well. We've got the proper test facilities and development facilities in Oklahoma City and Atlantic City to do the development and testing. And what we're trying to do there is, again, reliability, making sure that the system operates as designed. Maintainability. Sometimes we get feedback from the field that there's a better way from a maintainability standpoint. Performance. Sometimes we end up with there's new requirements, so we need to make a modification to provide different performance than it was originally designed. We work closely with other folks you'll hear at the Logistics Center and the OESG and TSOG folks, as well as the PMO, to gather all that feedback to make sure we do what's needed to take care of the NAS. Troubleshooting expertise, you heard Jeff talk about that. So Jeff's OESG, that's really first level engineering. Again, we're second level engineering. Kyle teased you with the escalation policy and what that looks like. The bottom line is we're all here to help. There's just a process on how to get different levels of help. But yeah, there is no third level. Second level engineering is the last line of defense for the FAA, but we're all on the same team. We're here to help any way we can, whether that's remote support over the phone, through the computer, or whether we need to travel on site and help. We're all here to help. System optimizations, the bottom line, some of the charts you saw earlier, we need to make sure we're providing the controllers the view they need to do their job. So we do have the tools and capabilities to help with what we call system optimization, to make sure these radars are providing the required coverage in the air and on the airport surfaces. And things change. Again, if air traffic has any issues, whether the system is meeting its intended coverage requirements, definitely give us a call. We're glad to help. I'll end how I started, data. So we try to be a data-driven organization. I think everybody hears that from the top. So a lot of that requires the folks in the field. Through RMLS and the other tools at your disposal, we ask and we require and we analyze what you're capturing out there. And that's what we're using to help make sure we're addressing supportability concerns, maintainability concerns, performance concerns. And then you'd be surprised, sometimes it's training, sometimes it's proficiency. So we generate videos to help to augment training. We work closely with the academy, so we're happy to funnel that over to them based on what we're seeing from engineering, that the field needs some added depth in the training course to cover certain things. So anyway, just want everybody to know we do take data seriously. Logging can be burdensome at times. All these metrics, chasing the right metrics, definitely feel your pain, but we definitely want to make that value added. So again, we welcome your feedback. If you feel you're being asked to do stuff that doesn't really seem to add value, we definitely want to hear it. If you've got ideas on other things we should be measuring that we maybe just aren't focused on, we want to hear that as well. So definitely let us know. And we do work close. We take pride in that. Surveillance, I think, is the closest community of all of them, between engineering, logistics, the field, and the program management office. So we're all on the same team. We're all here to help. And I appreciate the opportunity to speak with you today. Thank you.
Thank you, Mark. We do believe that Kyle is ready. So Kyle, we're going to cue you back up and go to you, sir.
Thank you very much. Ryan, if I could have the slides again, please, sir. There we go. Now we're in business. So Technical Support Organization, TSOG, part of technical services, as Jeff Bogan mentioned. We do a lot of things, and these are just some of the things that we do for the district, for the SSCs. We provide first analysis of UCRs. We administer performance exams and OJT. OJT is more of an exception, but performance exams, we're always willing to help out there. Provide subject matter expert support during a JAI. If you're performing a JAI on a system, it's always better to have TSOG on site to give you that extra set of eyes and some of the more experienced folks. Local RFI mitigation. Anytime we identify any possible RFI, please engage your tech support folks, and then we can work along with Spectrum and OESG to help resolve issues. Next slide, please. Support functions continued up as part of the continuity service. TSOG has a role in that. We're first on site before we engage with OESG. We should be there on the third interruption per the order. Also on the Cat 1s, as Jeff Bogan mentioned, seventh interruption or before, depending on the circumstances, but we certainly need to attend to those Cat 1s as well. Our NIM, our NASA Infrastructure Manager, or some call them NIPM, depending on which service area you're in, that support the projects in the district, working with your CWP input and prioritization, project scheduling, and getting you those funds for those small projects. And also those same TSOG engineers provide support with statements of work, independent government cost estimates, and engineering packages for local projects. Next slide, please. We also do first level performance analysis, troubleshooting, and restoration. We will escalate to OESG when appropriate. We also will engage engineering services when appropriate for infrastructure or complex engineering solutions to facility problems such as lighting, bonding, and grounding, major power, big HVAC problems. We may lean on engineering services. And one of the things we do internally is we share our best practices amongst all the technical support specialists out there. So they share ideas and findings with each other, and thereby enhancing their ability to respond. Next slide. That was it. As Mark pointed out, we will talk about escalation later today. I'll be talking about how you will and how you should and can engage all of these different organizations, get yourself the support you need. And with that, I'm turning it back to you, Noel. Thank you, Ryan, for the recovery. Appreciate it.
Over to you, Darren.
Yeah, thanks, Noel. Yeah, nice recovery, everyone there. So my name is Darren Jerome. I'm a group manager of the radar group in Oklahoma City in what's the logistics center. So some news about us. We reorganized and it was effective August 30th. So we are now part of Tech Ops and we're excited about that. We've been virtually realigned about 2 years, I believe. So we've been operating like we are part of Tech Ops for quite a while now. And I have to say, I really like being underneath the mission and answering to the folks that are in charge of the mission and providing our parts and services to the people that are in the mission as well in technical operations. So we used to be known as AML. So now our new routing symbol is AJW-L and the radar group is AJW-L 900. Next slide there. So we were formerly AML 2000 and now it's AJW-L 900. I don't know how I didn't wind up with 200. I guess it was taken by someone else, so we didn't get that. So what do we do at the logistics center? We are the main parts provider for all the techs in the field. So when you order a part, most of the time it comes from Oklahoma City. And it's our job to make sure that when you order a part, it's on the shelf and ready for you and it ships that day. So I asked my folks what part on a radar that when they order it, that the site tech doesn't care if they get it. And no one could answer that question. And that's because all parts are important and we strive to have parts on the shelf. So our inventory managers, they manage the commercial repair items and expendable inventory. They work with the vendors and keep the repairs going and keep the inventory in stock. And where we have problems with that is where there's obsolete items and things that are hard to obtain. And we work with Mark's group, second level engineering, to help mitigate some of those issues. The in-house repair items, so that's the things you order. You get that part, we call them LRUs, line replaceable units. So they're things like circuit cards, RF modules that you would plug and play in your system. We need that core back, so you need to send that back because we can repair. So we repair those and we keep those in stock for the next site to order. So there's always other radars out there needing those same parts that you're ordering. So it's important that the E in ENR stands for exchange. We get those core returns back timely. So all of the in-house repaired items are tested in a radar system that is identical to the one you have in the field. We have 8, 9. We have a TDWR we share with second level. We have all the secondary radars and we have ASDIs. So after we repair something, we will put it in the system and run it for at least 24 hours. So you know when you get that, it was ran in the system just like the one you have in the field. That's part of our quality control. The commercial repaired items, some of those we will test before we send to a vendor. So we're not paying vendors to repair things that aren't broken. So a lot of those are system tested as well. Direct ship items are things that we don't stock, but we ship it to you from that vendor. And a lot of things like that are like shelf life type items. Another thing I'd like to point out that we do from the logistics center, it's not in my group, but it's the antenna team. So they go on site and they do radome inspections, tower inspections, and maintenance. There's actually a program for that. And Don Taylor, who's right after me, he actually funds a lot of that. And NDP funds a lot of that from Ken Harris's group. They work on the antenna drive systems. They'll change out rotary couplers and they do all this on site. And also, if you need to, you can call this group and talk to one of the techs that install those parts, rotary couplers. They have years and years of experience. So if you're having an issue with a drive or a coupler, chances are they've seen it and they can tell you what that is. So that's all I have. Hopefully I got some time back there. And I'm going to turn it over to Don Taylor for in-service management.
Okay, Ryan, you pulling up the slides? All right, thank you. All right, first slide, please. All right, there we go. Excuse me. Good morning again, Don Taylor, AJW 135 Surveillance Weather Manager. I'll be presenting the in-service management portion of this briefing material. Now, the AJW 13 NAS Integration and Support Group, the NISG, provides for all disciplines of NAS service: automation, surveillance, weather, navigation, and communications. AJW 135, the surveillance weather, is relevant for this portion under the Surveillance Symposium. In-service managers, ISMs, are the headquarters national advocates tasked with ensuring that all tech ops responsibilities identified by the Acquisition Management System, AMS policy, are fulfilled. ISMs have responsibilities within each phase of the AMS lifecycle. These responsibilities are varied and can be categorized as follows: pre in-service decision and post in-service decision. And I will break these out a little bit. Pre in-service decision, ISMs support the identification, development, and verification of tech ops requirements for maintenance as new systems or services make their way through the early phases of the AMS lifecycle. Pre-in-service decision includes these early stages of planning, and this process begins with the service analysis and strategic planning and concept and requirements activities and artifacts, which are intended to achieve a joint resource council, JRC, investment analysis readiness decision, IARD. What follows is the initial and then the final investment analysis processes artifacts to include statement of work and supporting CIDRL DIDs. That's the contract data requirements list and data item description items. It's basically, this is what I want you to do and this is how I want you to do it. All contract language, which ultimately concludes in the final investment decision by the GRC. And if the FID is favorable, then the program proceeds with a contract award. Now, the established activities begin under the solution implementation processes, whereby development testing, operational testing, ensure the integrity of the intended system and or service meets the associated test and operational requirements. The SI process includes, concludes in an intended favorable in-service decision. Having achieved that in-service decision, we're going to move towards the post-in-service decision processes. And given the favorable ISD, the subject systems and services become an integral part of the NAS infrastructure under the in-service management portion of the lifecycle management process, where the system must be maintained for many, many years to come, which is what our ATSS professionals, along with TOS and OESG, have and will continue to do for many years into the future. During this period, ISMs provide maintenance management support for fielded NAS and or services equipment by monitoring in-service performance. We've got a quality assurance group that produces metrics under the NASPASS, the NAS Performance Analysis System, and coordinating an assessment of the accuracy of tech ops requirements and identifying operational needs. The next slide, please. And this is just the wheel, the FAA lifecycle management process. And I think it's a good representation. Many of you have probably seen this. Our NAS is always evolving. It's not static, right? So there is no beginning, there is no end. It's merely evolving towards that next stage, that technology that we will evaluate and apply within the NAS. That is it. Back to you, Noel.
All right, thank you, Don. I'd like to turn it over to Mitch Hughes and John Norris for the NAS Defense Program.
All right, thank you, Noel. Again, my name is Mitch Hughes. I'm the manager of the Air Route Radar Systems Engineering team in Oklahoma City. And John Norris is going to help me out on this. We wanted today to talk through how NDP helps the ATSS in site restoration. One of the things that you have to keep in mind is that the DoD DHS are customers as well as the FAA. So trying to maintain the systems and keep them online as close to 100% of the time as possible is our goal. So John, I'd like you to take us through an outage scenario and how AJW 142 and NDP helps out.
All right, thank you, Mitch. Good afternoon, everybody. I'm Jonathan Norris. I'm one of the managers for AJW 142, second level en route radar engineering. And specifically, my group, it deals with the testing of all of our modifications, the field support to the frontline ATSS, and then also the implementation of those modifications for the ARSR-4 and the CARSR system. So a few years back, the JPO, the Joint Program Office, the DoD DHS, who funds our specific branch 100%, asked us, what we were doing in regards to field support and maintaining the ARSR-4 and the CARSR systems. They knew all about the modifications, the optimizations, and those things that we were participating in, but how exactly was our branch involved with field support? And we took that question and started thinking about it, and we came to the decision that we need active out there with you all in the front line. And so we started a more of a proactive approach with how we go about our field support efforts. And so as many as you know, we are based in Oklahoma City. All of our engineering and technicians are housed there at the MMAC. But what you may not know is that we also have strategically placed 4 remote personnel out there within the NAS. We have Patrick Taylor, who is in Nevada, David Denman, who's in Houston, Texas, James Calder in Tampa, Florida, and then also Byron Goodrich in Columbia, South Carolina. And again, these individuals were placed in those locations to better assist more efficiently, more effectively with any sort of outages, REs, FLs, and even informationals when it comes to our ARSR-4s and CARSR systems. So for an example, how we handle our field support efforts is every morning we get together as a team, both the remote personnel and our personnel that are in OKC, for a morning stand-up. And during that morning stand-up, we review all LIR and RMLS entries, the code 80s and code 50s, to include reduced equipment, full outages, and informationals. We'll assign somebody to those entries to investigate them. We also take in input from our external customers, the Western Air Defense, the Eastern Air Defense, the AMOC, the Air Marine Operation Control Center, and also the 84th Raids on if they're seeing anything from their end from a performance aspect or an equipment aspect. So we'll review all of those inputs into our team. We'll assign an individual to that, and then that individual will start an investigation. They'll start reading over those logs. They'll read over the emails we get from either the E's or the WADs or the raids, and then they'll start pulling data. They'll start using tools such as the RS4, pulling in data from the Terra server to look at historical performance. And if they can see something remotely that may give them some insight on what's going on with that radar system. They'll also use DRAMs for some more performance and trending analysis. They'll also look to MAS and Peabody, download that historical data and pull it into or import it into some Excel macros that we have written. One specific program that we use is the ARSR-4 dashboard. I know there are some of you out there have used this program. It's a very well written, very useful program. And looking at the ARSR-4 from a historical equipment standpoint, and then also from a current standpoint based on MAS and Peabody data, it can give us insight onto what alarms we're seeing, and we can trend alarms. We can see what the configuration's like on the ARSR-4, whether or not we're having so many map sync card swaps and such like that. So when the personnel on our team has, say, an ARSR-4 reduced equipment or outage that they're looking at investigating, this gives them that insight remotely before they make contact with a site technician. Once that personnel has a comfortability level on what they believe may or may not be the issue, they will then reach out to the site. And the goal really here is to make contact with the site, let them know that we're aware of the issue, that we've looked into it a little bit. Here's kind of what we're seeing. What are you seeing at the site? And start to open up that communications pipeline, because that's what we want to do, is really strengthen the network of the long range community between our office and second level and you all on the front lines. What this will do is our individual will help formulate a game plan, discuss with you what you're seeing, what parts may need to be swapped, if it's a spare, if it's something we got to order from AML. So that way we can effectively and efficiently restore that system to its operational parameters. That individual will stay with that entry until it's resolved. Another bonus of opening up this communication is that it allows for not only the experience and the expertise on our team to funnel out to the sites, but it also allows for that expertise and experience you all are seeing out on the sites to funnel into AJW 142. And where that's important is if you all are seeing some systemic issues out there, it gets it back into our office, and then our team who interfaces with the engineers on our team can start to formulate some modifications that we could potentially resolve those systemic issues, either be it a Carcer software build or be it a hard modification to the Archer 4. That input we get from y'all is invaluable when it comes to deciding on what modifications we need to pursue in the future. Another bonus of being having communication is the fact that you can think of the individuals in Oklahoma City as your long range liaisons. So we have test beds for the Carcer and the Archer 4. We interface daily with AML. So if you're seeing an issue at your site, we can replicate it here in Oklahoma City, and using visual tools, be it Zoom, FaceTime, we can show and visualize, hey, this is what we're seeing at our test bed. Is that what you're seeing out in the field? And help better troubleshoot those issues more effectively and more efficiently. We can also interface with AML on any parts orders to ensure that they are ordered in a priority one status, like the 6000.198 Bravo states, and get those parts out to you all quickly, and knowing that they're going to help fix and remedy the issues you're seeing out there. But in the end, again, the whole goal of opening up that communication is to strengthen that network between our office and you all out in the field. If you have any questions, reach out to those remote individuals, reach out to the OKC personnel, and even reach out to me. Again, we are trying to learn from each other, and we want to be able to support our external and internal customers as best we can and continue with the availability and the reliability of the systems that everybody has grown accustomed to expecting from us. All right, Mitch, that's it. Thank you.
All right, thank you, John and Mitch. We got one more presenter, Sean Mock. We're going to go to Sean Mock. As soon as Sean is done, then we'll go to break, and then we'll come back to Q&A. Over to you, Sean.
All right, can you guys hear me?
Loud and clear, sir.
Okay, so I did have a handout that I shared, or I can share my screen if it cannot be found. I'll go ahead and share my screen. All right, I was asked to discuss the surveillance leadership team. So we've recently created a two-page handout on this, which I'm going to share with you. But first, I want to let you know that, so like I said, my name is Sean Mock. I'm the team manager of the Airport Surveillance Radar Systems team in Oklahoma City, second level engineering. I've been in the FAA for 21 years. The majority of my time has been in the Tech Ops second level engineering surveillance. I have spent 2 years in the program management office. And I'll tell you, I've been very fortunate enough to work with hundreds of systems specialists over my career. You guys have taught me a lot. I'm still learning all the time. I'm really grateful for those relationships. And I reach out to people all the time still just to teach me more and give me better perspective on things from the field point of view. So those of you out there that help me with that all the time, thank you very much. And can you still hear me? I'm having a little bit of difficulties with my system.
You're coming in loud and clear, Sean.
Okay, good. So what I wanted to share with you, so the surveillance leadership team, it's really comprised of a lot of the people who have spoken so far today. The responsibility of meeting the ATO surveillance needs is really divided among several organizations. And it's really easy for those organizations to really focus on their individual missions and make decisions that best align with their specific piece of the pie. The idea behind the SLT, we started in 2016. The PMO actually started this to get these different groups together and start meeting and talking about our shared challenges so that we could improve collaboration and start aligning the way we were tackling these challenges together. So this graphic right here, if you can see, this is the member organizations. You have the PMO, you have AJW1, which includes in-service management and second level engineering of tech ops. You have the OESGs, who have been speaking. You have NAS defense programs, you have logistics center. So we've been meeting, like I said, for 4 years, and we developed a mission statement that's here up top. And so something about the SLT is we do not determine the ATO surveillance needs. There's groups that do that involve air traffic. Really what we focus on is how do we best sustain these services? And we know that there's future needs coming down the road. And so we also want to align with those future needs as we do our best to sustain the current services. We also don't establish policy. However, we want to make sure that the people who do establish policy are informed with the most accurate and comprehensive information. So that's really a lot of what we work on. And how do we operate? So what we've done is we've actually started setting annual focus areas and goals to look at these areas, and we create action items. We hold bi-weekly meetings and we meet quarterly. And we've even started creating sub-work groups. When we said there's such a problem that we all need to work on together to tackle that problem, let's all commit resources. Let's create a sub-work group and let's see how much progress we can make, right? It's one thing to get together in a room and say, yeah, we all agree we have a problem. But what we've really been focused on is, can we make progress on these problems, and can we track the progress and actually overcome them? So what have we accomplished recently? So recently, one of the things we've put a lot of focus on is this area called supply support data. So really, supply support data is really, how do we prevent the thing that Darren talked about earlier, a situation where you need to order a part and it's not available due to obsolescence. Obsolescence is not an issue that any one organization can really easily tackle on their own. It's a lot more complicated than it sounds. When a part can no longer be repaired or it can no longer be ordered and the supply chain gets slow, that's a bad situation that causes all of us to kind of go into a critical posture, diverting resources to make sure that we can find a way to get the parts available. So the focus of this group is, how can we become proactive? How can we predict in advance that these, if possible, that these kind of problems are going to occur, start planning, start requesting funding, start working on solutions, and actually have something ideally implemented and prevent the situation, from ever occurring in the first place. So this last year, we actually did a lot of auditing, and we found that we could actually take our internal business practices and tweak them to support a shared process where we're working together continually out throughout the year and looking for these issues so that they can be, like I said, so that we can start taking action now for something that might occur in 2023. We become aware of it now, and by the time the part's an issue, we've already solved it. And like I said, no one ever notices that it's avoided. So we also have new initiatives in 2021. You can see on this slide, and this handout will be available in the materials. So in 2021, we're really working on things such as skill sets in the surveillance community. That'll be a topic later in the agenda. What can we do to help make sure that the skills are available to actually do work on older systems like the BI5? There's do-ins, that's something that will be on the agenda later. Also under the COVID environment, we have the virtual site visits that we're working on so that we can try to make progress on a lot of our big initiatives. And, we realize that site visits can be really disruptive to the site. So we're surveying all the different projects and initiatives and saying, why not, if we're going to do a site visit, why not collect all the information one time instead of having 5 different projects make 5 different visits and be that much disruption? So we have a lot, like I said, we have a lot of different initiatives we're looking at. And ultimately, our goal is to do what we can to help you guys at the front lines have all the tools you need to do your jobs and make sure it's all available to you. And I'll go ahead and pass it back to Noel.
All righty. Thank you, Sean. I'd like to apologize. We went over time just by a little bit. We do have some questions waiting for us in Q&A. We're going to come back to those questions right after we go to break. If you do have additional questions, please submit those in Q&A. We will start our break, our 10-minute break right now. Please return in 10 minutes. Thank you. Welcome back to the Surveillance Symposium. Once again, apologies for running over a little on that last session. Our last session was basically about the surveillance community. And at this point, I'd like all of the panel members to please turn on your cameras. We do have quite a bit of questions. I got a total of 12 questions here. So let's go over the questions. The first question is from James Frierson. Throughout my career as a radar tech in the FAA, I've worked on ARSA 1s and 2s, CD1, CD2, ARSA 4, ASR 11. My question is about analysis tools and training. Some of the tools I have used is RS3, RS4, CDMON, WinPlot, RBAT, RDAS, RTADS. I always thought it would be nice if we could just pick one tool and train the field techs on that analysis tool. Can we do that? I'll turn it over to Jeff Bogan.
Well, that's a really great question. Certainly, having a single RDAS tool to use throughout our organization would really be beneficial. Not so easy to do. The challenge is that with the legacy systems and the newer systems that come out, each system does require some different level of analysis. For instance, the radar toolbox tool, which is an ASR 11 tool, very specific for looking at clutter processing. But here's some good news. It has been difficult to get radar data analysis training to the surveillance specialists. We are going to be coming out in the first quarter of this year with RDAS training. It'll have an ELMS course associated with it. And because of COVID, we're going to try to do this virtually. Normally, our RDAS classes are very small, 20 folks at a time, and we have not been able to easily train our workforce on all the various tools, RS3, RS4, WinPlot, all of the tools that are the bread and butter of RDAS really are quite difficult to learn and become an expert in without some training. So we are going to roll out that training, and we're going to try to roll it out for all the service areas, and we'll do that first quarter. And you'll see training by the 84th Raids on the RS4 tool. You'll see training on WinPlot, RDAS, RBAT, and all of the tools that are available. I'm going to talk about this more in the symposium, so that's coming. But your question as to a single tool, there is some initiative by our second level support teams to start working on a highly integrated radar analysis tool. It takes a long time to develop a new radar analysis tool, and I don't know how far along they are. I'll throw it out to AJW 14 team if they have some more feedback about that. But I think we're still quite a ways away from a single tool, but I can tell you that new training that should be coming out, and hopefully we can mold that into an academy class as well, is coming. So that is good news for the surveillance specialists that like to learn how to use those tools better.
Mark Michaud and or Sean Mock or Mitch Hughes, anybody from second level engineering like to add on to that?
I don't have anything to add.
Okay. All righty. Thank you very much. The next question.
Noel,
yes, sir.
Noel, one thing on that. I can't speak to the development of a package that could be useful, but for long-range radar, we do use some tools that are difficult to learn to use. The RS4 is one, DRAMS is another one, and if people would like OJT, we don't mind doing that, and it would be good to get more people involved in, and we've done that before. Put on a one-day course on usage of those tools. So just reach out to me, and we can help set that up.
Okay, so what I think I heard Jeff saying is that we, the OESG managers, will be reaching out to you and coordinating when we can do some virtual training on those tools. All righty. The next question. For LCSS, I tried to order an MTI feed assembly. I was told that I cannot order that part, even though it was on the LCSS site and I was able to complete an order. Instead, I have to buy an entire MTI system for $1,800 plus, instead of the $4,000 for just the one part. Darren.
Yes. So unfortunately, this is one of those obsolescence issues that Sean was talking about. And that's probably the reason why this is happening. MTIs have been supported since way back with ASR 7. I mean, that's when I came into the agency. So maybe even before that. And you could buy the parts and repair them on site. These newest we have are from a company called PSI. And they have an old and a new style, and they may be on to another revision beyond that. But the latest issue was they're only producing the new parts for the new ones, and that's it. So you can't get that part. You may have been able to place an order, so that may have been an error. We'll get and check on that. But long story short, it's too late for that, but contact Otis Brown, and he can look up and get you the exact details on that. So. But I think I gave you the correct information on the why, but how to proceed. Otis Brown can help you with that.
All right, thank you, Darren. And I think the next question is for you too. It comes from Mike M. Are there any plans to update the LRU repair disposition tracking system to provide visibility into systemic issues? This would allow TSOG and OESG engineers the ability to see either problematic LRUs or subsystems.
So I think you're talking about, and correct me if I'm wrong, or shoot me an email, Darren K. Jerome at FAA.gov, and I'll look into it more. But I think you're talking about LCSS. That's our system of record and how you order things. And it does track by serial number the parts we ship. So we know what exact part we shipped where and what was done to it when it was in our repair facility. We know what components within. Everything that's down to the indirect parts, the really cheap parts, we don't track those, but we are working on fixing that and tracking everything. But I hope that answers your question. So LCSS is a very powerful tool. We'll be able to do searches, kind of relational database type searches, where we could search for serial number part, for types of parts, and see where they're all going. Is it a site problem? Is it an LRU problem? Is it a component problem on a specific LRU? So it's a very powerful system, and we are still working on building reports to search out things like this. So I think the answer is, another long story short, yes.
All right. Thank you, Darren. The next question comes to us from John Dolan. Is there a replacement program for legacy ASR8 systems outside of SLEP, which is a SLEP standing for Service Life Improvement Program, extension program? How do we identify specific sites on the waterfall replacement timeline? So I'm thinking okay, Sean Mock, I see you raising your hand. Yes, sir, go ahead.
Right, so for all the ASRs, ASR 8, 9, and 11, the FAA has requested to start a new program called the ASR Replacement Program, ASRR. That program will be starting in FY22, and the goal of the program is to look at the existing ASR requirements and to do an alternative analysis of the different systems and technologies that could be used to replace that service. So from a waterfall standpoint, we're real too early at that point. We're actually still making sure that the concept of operations and that the requirements are getting established. And like I said, we're probably looking, and this will actually be covered in tomorrow's Future of Surveillance presentation. So feel free to ask that question again whenever the PMO is on. And they should be able to provide some timelines on when we should expect the replacement programs to begin deployment.
Ryan, open mic.
You're on there, Ryan.
All right, thank you, Sean.
All right.
Just a little technical difficulty that we all come to expect with these Zoom meetings, huh? All right, thank you, Ryan. The next question comes to us from Zane. Are all members of the surveillance leadership team managers? If so, is there a plan to incorporate non-management, SMEs or the like, to this team to allay management bias?
So it is primarily led by managers, but the managers have invited non-manager SMEs to discuss topics and bring up issues. And then each member of the surveillance leadership team is to go back and brief their teams on the discussions and to actually solicit items from their teams on topics for discussion at the SLT. So the answer is yes.
That is correct. All members are managers. And one of the things that we need to do, OESG managers, myself, Jeff Bogan, and Stephen Schmidt, we do need to continually reach out to the service areas for any surveillance issues that y'all would like to, for us to bring up on your behalf as a surveillance leadership team. All right, the next question comes to us from Vern E. Davis. Due to Hurricane Laura and Delta, do we have remote surveillance for our backup power generators for our radars, to include the generator fuel tank level remotely as well, monitoring the temperatures, pressures, levels of fluids, oil, antifreeze, etc.? And I believe Travis Simmons, you said you'd like to answer this question.
Yeah, I can handle that one. So yeah, the SOCs do have the capability to monitor the engine generators at the ASR sites, and we do keep track of the fuel levels. Unfortunately, we're only as good as the telephone lines that bring us over. So in the event of a hurricane or a natural disaster, we may not have the FTI lines working that we need, and then we will lose the capability to see what we've got with the engine generator. But as far as being able to monitor it, as long as the phone lines are good, we're keeping track of that stuff for sure.
All righty. Thank you, Travis. The next question comes to us from Lorenzo Parks. I would like to know the process to request NASTEP assistance with a JAI. I'll turn that over to Jeff and or Stephen Smith, or do y'all want me to take it as an OESG manager?
I'll take it.
Go ahead.
Just quickly, certainly NASTEP can help out on a certain set of JI exceptions that you find. I mean, there are perhaps other organizations that have responsibility there, but the NASTEP team is always available to do that. They have some very good folks on their teams that know the equipment quite well. So just ask your OESG manager to touch base. What service area is this?
It doesn't state the service area.
So just go ahead and reach out to your OESG manager, and they will connect you up to the NASTEP team, and they can start talking about what needs to be done, and reach out and get the right folks to help out.
Yes, and Jeff Bogan is the WSA OESG manager. I am the CSA OESG manager, and Stephen Schmidt is the Eastern Service Area Acting OESG manager. I got a shout out from Randy. Really enjoyed the format presentation. Thank you. Keep these going. All right. Next question, Mark S. Johnson. Due to local terrain features, low altitude coverage to the west is poor on our STAR system when the local ASR Mode S feed is OTS. What is the process to get an ADSB ground station added to an ADSS service volume to improve coverage? Don is as a in-service, would that be, would you be best capable?
Yeah, I could speak to it a bit there. We would have to get through the JRC process to put a business case together. We check your performance out there, what's going on, to try to justify the cost of adding additional sensors out there. Many of the sensors that we've already got out in their field are obviously spoken for. This would be an additional requirement, or if you're somehow have a shortfall that needs to be covered, that's what we could use as a basis to build a business case to analyze towards that resolution.
Okay, so the best way to bring this up is to contact your local technical support center. Each technical support center should have a NAS plan program manager or a NIM that works with projects, and they work with requirements. Work with that subject matter expert on your technical support staff to define the requirement and get it into the corporate work plan. And at that point, Don Taylor can help us out with that. Alrighty, let's go to the next question from John Woodell. I am on the team working on the Advanced Radar Concepts course. This is one thing we are asking. We are going to include training in some of these analysis tools. Oh, fantastic. So I guess Jeff and Mitch, we probably need to hook up with John Woodell on the analysis tools for that. Okay. All right, next question from Mitchell Lentini. Having been in a reduced maintenance stance under COVID, what have we learned? The good, the bad? How will we take what we have learned and turn it into practice? I'm thinking, okay, Darren, I see your hand up.
Yeah, real quick, something I can say to that. So there is an innovation team that is looking at several things that we're doing because of COVID, and Mr. Planny has got that team going, and there's a lot of things that the team's looking at, and Noel, you're involved in that too, virtual site visits and a lot of things like that. So that's one effort that's ongoing about that. And I'm sure someone else has something to chime in.
Go ahead, Jeff Bogan, you'd like to add?
Yeah, so let me just tell you the good about reduced PMs. We've gone into, with COVID, sadly, we've gone into a very heavily reduced, almost eliminated all PMs. And what we noticed in the data is a very clear drop in unexpected outages. That's exactly what we needed to do. It's just like a moratorium. There's very good data, anecdotal data, and actual data now, again, because of COVID, that shows that unanticipated outages go dramatically down when we don't touch the equipment. That kept our people safe. That kept our people from having to go out and travel into the field. It gave us time to come up with a concept of maintenance that would allow us to understand what all the issues were. And it was an environment of reduced maintenance. And that worked for a very short period of time. We saw unexpected outages go down dramatically. As we renewed and increased the number of critical maintenance activities, what we found was unanticipated outages are coming back up again, but also because you can't just let the equipment stay there. Oil needs to be checked, levels need to be checked, antenna systems need to be inspected, things start falling apart. So this is only a short-term solution. And the long-term solution is a balance between no maintenance or very reduced maintenance and and where we are in the critical maintenance right now, and the national folks, along with the CONOP strategic mapping teams, many of the folks here on this group are on that team, I'm on that team, and we're looking at every PM to understand where the best balance is between heavily reduced maintenance and the maintenance required to keep the NAS extremely reliable. So we can do it short term, we don't touch a thing, and that works. Of course, that simply can't run for a very long period of time before you have some very serious unanticipated outages that are both expensive and difficult to repair and take a lot of resources. Again, so there's good and bad, but I think that COVID has allowed us to find the bottom. We've discovered, again, sadly, the bottom of what it looks like to go into a very reduced maintenance posture. It reduces outages dramatically, and then those outages start creeping up. And I think the data shows that in all of the analysis we've done so far. So look to see a much more reduced maintenance oversight. There are lots and lots of people looking at reducing the intervals and reducing outages where it makes sense and where it's going to work. And so we'll see that. So that's kind of good that we've been able to find the bottom balance, because we would have never been able to explore how low we could go in maintenance without, again, sadly, because of COVID. But I think we found the bottom, and we know that's not where we need to be. And we're now looking at a more realistic reduced maintenance, and you'll see that reflected in the orders here as we're moving forward.
All right, thank you, Jeff. So I heard that we have a team looking at that as far as what we have learned, turning that into practice. And we need your feedback, the ATSS out in the field. We need your feedback with respect to, hey, how are things working? What are you seeing, et cetera, et cetera. The next question comes to us from JD Handel. What is being done or can be done to track electrostatic discharge damaged LRUs? LRUs that fail imminently and test okay at the depot and are sent out again to create another set of clustered outages. ESD is typically caused by lightning or poor handling of LRUs. Darren.
Yeah, so I want to start out by saying that all of our repair stations in the logistics center are, well, not all, but the ones that work on circuit cards and anything that may have an ESD part in it are certified ESD repair stations. They're grounded, they have mats, and our technicians wear the ESD straps, and they are connected to constant monitoring systems, and they are logged. So, and we are audited on our ESD practices. So I just want to start off by saying we take it seriously at the logistics center. To talk about it, how we would track something that is ESD damaged. So I don't know that you can tell that that would be the cause of an intermittent failure, but if there is an intermittent, if you have a failure of a part in the field, you need to log a CSA on that item. Say, I got it and it didn't work, and state what happened. And we get that back, and that note gets attached to that serial number. So if we check it out and it works fine in our system and it goes to another site, it's that site and it happens again, it's the responsibility of the next site to log that too. So those two logged issues would get tagged on that serial number part. And then we would know, hey, there is something weird going on with that. And our quality group monitors for that type of thing. And they would issue what's called a corrective action request on my division and say, this part you have has a problem. You need to do a investigation into that to determine what the root cause is. And we're held accountable to that. We have so many days to do the research and figure out and provide a response and have a corrective action plan. So I know that doesn't really answer your question about how we track them, but that's how you mitigate that issue. I hope that was helpful.
Okay, thank you, Darren. And thank you to all of the panel for your presentation and for your answering of these questions. We still have a couple of questions in the queues, but we're going to put them on hold and we'll come back to them at the end of the day. I'd like to remind everybody, please keep submitting your questions in Q&A. And at the end of the day, we will have a Q&A answering session for all of the questions that we haven't answered. So at this point, I would like to get into our next topic, which is how to get assistance. And I'll turn it over to Kyle Evans.
Good afternoon, everybody. Again, we're going to talk about escalation or how to get help. Next slide, please. So today, the last session before the break, you were introduced to multiple organizations out there that support the surveillance community, that support the SSCs and the maintenance of those facilities out there. Now we're going to talk a little bit more about how do I get that help? And this policy applies to all technical operations organizations. When I call it a policy, it's actually a memorandum. It was issued in 2013. It was signed off by the 3 field directors. It's called Escalation Policy for System Service Restoration. And it is addressed to all the district offices and the technical services groups. We will share that as an artifact that'll be part of the package available to you to download. So the nature of the outage is what dictates the speed of escalation. How quickly do you need to get help out there? So the SSC and district management and the tech services, which is typically going to be your technical support center manager or the local TSOG team, will collaborate to determine the effective course of action. And of course, risk management and impact to NAS operations are critical to the decision on how quickly we escalate. Next slide, please. So the way it starts for a complex or highly visible type outage is obviously the SSC would be the first on site to take a look at the problem and see if they can resolve it themselves. All the while keeping local tech support advised. These are for highly complex or highly visible, high impact type outages. Let your local TSOG folks know what you're doing out there, what you've discovered. If you run into a wall, if you need further troubleshooting, you can engage your local TSOG folks either on telephone and, if appropriate, possibly on site as required as soon as practical. So if TSOG's been on site for a little while and we haven't made any progress, we're continuing to run into roadblocks, then TSOG will engage OESG. OESG could do the same. They could provide some technical support via phone, FaceTime, video conference, and if necessary, come on site. Next slide. At the same time, OESG will now engage with second level engineering to let them know what's happening and what their efforts are. And if we haven't been able to restore it with local SSC, TSOG, and OESG on site, then we can decide, do we require on site from second level? So we'll get some telephone support and we'll make that decision. Throughout this process, the SSC will ensure that all escalation requests are documented in RMLS and justified. So in other words, keep a good running log of the activities of who's been engaged, what they've done, and as we escalate these issues. Once support has been escalated, the SSC is, no matter what, is always expected to remain engaged in the restoration effort. Basically what that means is that SSC should be on site for whenever TSOG, OESG, second level, or any other outside external organizations are at your facilities. Next slide, please. So how do you get second level on site beyond OESG and TSOG? Well, the only way that should happen is if the OESG managers, the K-band manager, or one of the 2 frontline managers in OESG, or the TSOG manager, the K-band manager, or the TS manager, the L-band manager can request on-site assistance from support organizations outside of the service area. You can always get telephone assistance. We're not telling you can't talk to folks, but what we're talking about here is ensuring that we are getting that on-site support and we're doing it efficiently and effectively. As you can imagine, as you go up in the organization, the higher the level of expertise, the fewer people there are. So if the 1 or 2 or 3 ASR9 experts are already dispatched out in the field somewhere and on the West Coast, let's say, and something catastrophic happens on the East Coast, then they're obviously not available to go over there. So what we try to do is prioritize and ensure that everybody's doing what they can to address the situation. It's really important to always go to your local TSC first. There's a lot of good reasons for that. First of all, we may be able to help you. We may surprise you. We may have the expertise in the local TSOG folks. If we don't, we have a vast number of, for example, in surveillance, we may have 15 to 20 surveillance specialists just in TSOG available to help. And then also, we also learn while you learn. So if the SSCs encounter something they've never seen before, perhaps TSOG would learn something by that as well. And if we identify a problem at ASR XYZ, we may discover, wow, we had the same problem over at ABC, and we know how to fix that. Or we can learn and maintain our proficiency as well. So the key to the escalation policy, if you can't remember anything else, contact your local TSC first for any external support on site. If you are talking to outside entities, let us know, just so we know you're talking to them, because we don't want to be surprised. And we want to keep part of the upward reporting and awareness of what's happening in the service areas. It's critical that technical services has an understanding of your current status. And with that, Noel, I'm done with escalation. I'm going to turn it back to you.
All right, thank you, Kyle. Checking Q&A. We don't have any questions on this particular session. So what we'll do right now is go back to all the questions that we haven't answered. So I'd like all of our panelists to put your video on, and then we'll go back and start answering as many questions as we can, going through the list. And if any of you out there have additional questions, you can always add additional questions in Q&A. So first question, explain the importance of radar panoramic photographs in constructing radar line of sight diagrams at both terminal and en route radar facilities. Also, there exists no standardized equipment nor software to perform any 360-degree bullseye analysis. Analysis along the vertical axis requires accuracy of plus or minus less than 1/10 of a degree. Jeff Bogan.
Sure, that's an interesting question. The use of panoramics, 360-degree panoramics, in years past has been very important to both new radar sightings when we install a new radar system and when we are moving a radar system, or we're trying to troubleshoot complicated coverage issues that are showing some problems due to perhaps some blockage. Today, well, let me tell you two things. Number one, there is a gadget that WSA has developed that allows us to spin a camera, a high resolution camera with a gradical that is calibrated to 0 degrees, and it spins around with a motor remotely. We put that up on a portable extended tower, and we can rotate that around and we can get very good panoramics. And we've used that before in years past to do a pretty good job of panoramics. That is custom made. It's a one-of-a-kind gadget. What we're finding today, though, is that even for new radar sightings, the need to do panoramics is not as necessary. And that is because we have cultural radar database available to us that shows all the buildings, all the trees, and gives us very good line of sight visual graphics that we can calibrate very precisely, better than 1/10 of a degree accuracy, so that we really know 360 degrees around from any location within the cultural database that's available to us. And we have those cultural databases for many of our cities. And that gives us some very good line of sight tools. It's a very standardized set of tools, and it can be used. And when we do new radar sightings, we typically include in part of that contract to do some kind of a panoramic. Sometimes it's just digital if we have really great panoramics, and we usually buy that from another vendor who has great panoramics, and that provides us very good line of sight analysis, the kind of things I think you're looking for. There's also, today we've also taken a camera and going up to a particular location and just rotated around. There is camera with your Apple phone that will then align precisely to 0 degrees and give you a pretty good set of panoramics that we've used to actually determine problems where we don't have good cultural database. And the cultural database, again, is a picture of all the buildings, all the trees, all the ground coverage. So we get very precise information off of that. So hopefully that answers most of that question. But again, today, not so necessary to do visual panoramics anymore, except maybe for new radar sightings, just to validate that we really have a good line of sight selection or a set of selections that we use to determine what the best site for radar would be.
All right, thank you, Jeff. The next question comes to us from William P. Wilson. What are the chances of getting some training classes in order to get certified? Who would like to answer the training issues and where we are with training on that?
Hey, Noel, I can actually speak up to that. I haven't spoken today. I'm actually on the agenda tomorrow. My name is Micah Campbell. I'm the group manager for technical training out of AJI. We are working on getting certification classes ramped back up at the Academy. We do have some social distancing capacity considerations, which you're starting to see more classes roll out, but they're at a reduced scale in terms of the number of students. And we're also really working hard on some virtual offerings that I'm going to be talking about tomorrow, which should help lead us to certification. We're also really looking forward to phase 2 in terms of the agency's posture so that we can start revising and creating more of those OJT and PE packages that we know need to be done out there in the field. So there is a lot of work around training going on, especially national training leading to certification. But I will be talking a little bit more about that tomorrow with respect to surveillance courses.
Okay. Fantastic. Thank you, Micah. The next question is also for you, Micah. It's ELMS. Comes to us from Glenn. He says that he dislikes ELMS for equipment courses, but would like to see courses written for the use of test equipment in ELMS, such as network analyzers, spectrum analyzers, newer communications test equipment, field foxes, etc. After equipment courses, he feels that it would help the ATSS to better understand these complicated and very useful pieces of test equipment.
Well, I think that that's a really great point, and it's definitely something that we've been engaged in conversations with for several years. Anybody who's been around the agency a long time knows that we used to have courses, specifically distance learning courses on test equipment, and they were sunset and they haven't been brought back in a very long time. The question becomes, can you create an entire course that encapsulates what the current test equipment is? And I know test equipment itself is run out of AJW. And so that's been a question for us. I know that we've been able to do some partnerships on things like Field Fox Analyzer, on some of the equipment that is out there specific to an actual site or a NAS piece of equipment like the SR9. That's where we've kind of been able to cross the boundary and say this is specific enough and it becomes pervasive enough of an issue that we need to provide that sort of training. We struggle with providing national training on all of those different types of equipment in one course, because as one becomes obsolete or we go to network analyzers or all-in-one type of equipment, those pieces of the course become obsolete and it becomes very hard to keep it up to date. That being said, what we are working towards is out-of-agency training, where if there's companies that are providing specific training, especially virtual or online training for their pieces of test equipment, that's something that we're exploring. If we could get more contracts with those companies to provide that training to people, it would keep us from having to update them and keep them current. But those are all things that are in the work. Those are the ways that we're starting to pivot and trying to evolve to meet the needs of the NAS, including the ATSSs who really need to know this test equipment and how to use it appropriately. So it's a little bit more complex than it seems on its face, but it is something that's being discussed on a regular basis.
Thank you, Micah. So we have no more questions in Q&A. We do have some questions that are leftover, rollover questions, and I'm going to have to be looking at this other document over here to see those. One of the questions from this morning's session was, how does the information to a controller look different in STARS when the ADS-B GPS signal fails and the WAM service report is the only information given? The answer that's been written down here is, at a TRACON, it will be transparent if in fused mode. Single sensor will result in no data. I hope that answers that question, because that's all I have here. The next question is, and there is a written answer for it on this form, will the ADS-B transponder not be available for pilots to turn off, even if by accident? And the answer is, ADS-B transponders do not have an on-off and are hard-coded for aircraft ID. All right. Here's another question from this morning. Via STARS, there is an ADS-B feed from the SBS. Does this include the WAM service, or is that an independent feed? And how will it be indicated on the STARS MCW and ADS-B fails and WAM is primary? Additionally, as ADS-B increases in target validation, will WAM be included in this algorithm? And the answer is, WAM is a separate sensor from ADS-B. It is treated as a secondary radar in STARS. In single sensor mode, it shows up as a traditional blue block. In fusion mode, it is fused with other sensors and appears as a blue filled-in circle. WAM is used for target validation, as with any sensor in STARS. Travis, is there anything else that you'd like to add to that?
No, that pretty much covers it. As far as WAM and ADS-B go for us at the TRACON, they're really two different things. WAM is just kind of coverage for a certain area using MLAT, and it really does show up on our display as the traditional blue top hat, just like a secondary radar. Whereas ADS-B is completely different, and it's given, if we just had ADS-B on the glass, there would be a totally different indication for the controller. It would be a lot different. So yeah, when we're in fused mode, if WAM fails, it's going to be transparent. We're not going to see really anything. It's going to continue on as normal. Unless you're in single sensor mode, if you're using WAM as a single sensor and WAM fails, it's going to be just like any other legacy radar. You're going to lose data.
All right, fantastic. Here's a question from this morning. Why is WAM in Juneau, Alaska and Rifle, Colorado maintained by FAA employees, but other newer systems like the ones in CLT and LAX are contractor maintained? Who would like to take that one?
So my team is supporting those FAA WAMs, and those were part of the development of the technology, and they will be converted over to WAM services, and they will be decommissioned when the new services are available.
Okay. Thank you, Sean. Is ADS-B equipment required on other countries' planes? Sean.
If you fly through the airspace with the ADS-B mandate, you must be equipped. It doesn't matter what country you're from.
One of the questions we have is, will there be a plan for a communication symposium? And as you heard Jeff Planty state this morning, that the Surveillance Symposium is the first of other symposiums that will be coming out. We haven't determined the order in which they will be, but yes, the plans are for a communication symposium, NavAids symposiums, environmental, et cetera, et cetera. We'll just line them up and knock them down. Let's see. Okay, hold on. Okay, we had a couple of questions come in. Well, one of them's a shout out to everybody. So I'm going to go, hey, we got a shout out. Okay. Great first day. Thank you to all the panel members for taking the time to put this together and spending your day on Zoom, sharing your knowledge on the field. So, hey, thank you for the feedback. It's good to hear that. The next question comes to us from Lorenzo Parks. He says, I am in the ESA. Is there a plan to address the shortage of ASD, SMR3, traveling wave tubes, and the modular power supply maybe you have on hand at the site? Darren.
Yeah, unfortunately, that's me. And I plan to address it about every day when my director asks me where we're at on these things. So this is a supply and demand and lead time issue, and COVID has not helped with this company. Teradyne is the company that, or is it? It's Teledyne that repairs these tubes, and we have plenty of tubes there, and they're in the process. As soon as we get one in, we check it in our system and it goes to the next site. We keep one in stock at all times in case there's a site that loses 2 channels. We'll ship it immediately. So if we've got one, we're hanging on to that until there's a true need for that. We're filling in order priority, and after priority, we're filling by order of the date when it was ordered. I have been checking in with the technical managers occasionally. Hey, I've got these 2 sites. Do you want to prioritize one over the other? And they have changed the order a few times. I don't see it getting better anytime soon until Teledyne can speed up their repair process. I can send them all the tubes in the world, but they can't process them fast enough. So we've complained, we've talked to them, we have weekly telecoms with them. And the PSM is in the same situation from Free State that supplies the power to that tube. Same sort of issue. So it's an ongoing issue, and we're working as close as we can with the vendor, and we're doing the best we can. And I'm sorry I don't have a better answer for you on that.
Thank you, Darren. The next, it's running out of question. It's just a comment from John Grodefend. ADSB cannot be hardwired to the power bus. It must have a circuit breaker available to the flight crew for safety and fire control in the event of failure. So it can be disabled. Thank you, John, for correcting us on that. Next question's from Raul Soltero. Is there a system that we can access for trends regarding parts failures, or is the item manager for the particular system the only way to get this information? Darren.
Well, yes, there is a system, and it's LCSS. And LCSS, we have it set where it will lay out a file of data for us, and we use Tableau to build reports. And we have all kinds of reports built. So, Raul, I don't know where you work, if you're in second level engineering or.
He's at the DFW Technical Support Center. He's a TSOG radar TID.
So if you would let me know the type of report you're trying to see, we probably already have one built. And I bet you the second level engineering folks are tapped into that, and they're looking at the same thing. We work closely together. And that's also some of the things we talk about on the strategic leadership, the surveillance leadership team, about what's data we need to see to make good decision making, right? And I try and facilitate building those reports and getting them where they need to be and getting folks access to that data. So email me and I can see if I can help you out.
Thank you, Darren. The next question comes to us from Danielle Drusina. Do we have a main KSA site where we house all this wonderful information? Danielle, while this symposium is not being recorded, we are going to be providing all of the PowerPoint information and all of the resources that we put together. So yes, we will be providing that link. Thank you for that. The next question comes to us from Mike Hatton. In reference to the radar divestiture program, have all the affected radar sites been identified? In the interest of time, I'm going to go ahead and answer this question, and the answer is yes. And tune in tomorrow when Devlin Maxwell will cover the radar divestiture program. Next question comes to us from Julian Pizarro. How is priority for an equipment training slot determined? We have 2 out of 10 tech certified for TWR, and due to COVID pandemic, we lost 3 slots to attend the course this year. Thanks. Micah.
I am so sorry. Can you repeat the core of that question?
How is priority for an equipment training slot determined?
Oh, that's a great question. We have a quota management process that evaluates both the need of the individual site, if it's something like a waterfall schedule where it falls on that. It's evaluated against categories such as new equipment training, new hire training, attrition training, meaning you're hired somebody to replace an older person that has left. All of those things are weighed together. And then at the point that we're in right now, where we have essentially limited number of seats, and even if we only took our highest priorities, we still wouldn't meet throughput because of our constraints. That's where we're collaborating directly with AJW leadership. They've assigned an executive representative for training, Sheila Griffith, and also a training liaison, Jim Woodruff. And so at that point, when we still can't meet the highest priority needs from an agency perspective, we basically go to them and say, here's what we can do. Tell us where you want to point our limited resources. And so at this point right now, especially with equipment training, that's how we're prioritizing. We're taking that list, narrowing it down, and then basically going to AJW and saying, here's what we can do. Tell us what your number one priority is. Where's your biggest pain point? And the way that Jim is actually collecting a lot of that information is directly from the district managers and their support staff, primarily the PSSs and TPMOs. And so they're basing it off of their watch standing schedule, their ability to staff appropriately for that. So it's, again, there's a lot of information going into it, but it's not a haphazard process. If you have not gotten your particular class that you're interested in, that's something that does need to be elevated through your district in order to make sure that it's prioritized correctly by AJW. And then as that passes over to AJI and the Academy, we're able to make sure that we're doing the most appropriate training at the right time.
All right, thank you, Micah. Next question is kind of a follow-on, Darren, from Raul Soltero. What about expendable parts? Do you want him just to send you an email and you can help him with those reports?
Yeah, so expendables aren't tracked by serial number because we never get them back. They're not repaired. It's just a throwaway thing. So what we would see there is like demand trends spiking, right? But you can do a CSA on an expendable part. We may not want the part back, but we want to know, hey, I got this thing and it was junk from this vendor, right?
Very good. Thank you, Darren. The next is a comment and a question from Danielle. She's saying, thank you for the symposium. She used to work for Raytheon and they would hold symposiums every 3 to 5 years. Is this symposium format going to continue into the future? And the answer is yes. We have not determined the periodicity for the surveillance symposium, but thank you for that feedback. The next question comes from Thomas Mugford. Is there any plans for DRAMS-like product for the terminal radar world? Who would like to take that? DRAMS-like product for the terminal radar world. Go ahead, Jeff.
Yeah, So that is being explored. Obviously, Tom may appreciate that DRAMS is a very powerful and useful statistical tool that can provide a very good summary, statistical summary of radar performance. We use it a lot in WSA on a site-by-site basis, but there are some recording capabilities limitations that have not been resolved yet to make DRAMS available widely. I don't know of another tool that does things exactly like DRAMS, but some of the radar analysis tools that we are running real time and live that we deployed in Southern California TRACON, for instance, those are DRAMS-like and provide very good statistical data analysis capability like DRAMS. So work is being done to do something like that. So work continues on that. It's not so easy, but actually DRAMS itself can be used with terminal radars and is very powerful. And I do think that you'll see that product or something very similar will eventually be fielded, and that folks that have a need to look at that data will have access to that data.
Thank you, Jeff. The next question comes from Edward Mino. When can asterisk format replace CD2 format in the FAA so that many radar improvements can be seen on the glass? Also, better compatibility to Europe and the Caribbean in radar sharing. The asterisk data format has much more information that is needed for analysis of problems and automation improvements. Who would like to take that one?
So
go ahead, Mitch.
Okay.
Well, Sean and I can share this one, I think. So one of the modifications to the long-range radar systems is a correlator, and the first stage of that is to put correlated data out as CD2 messages. The second stage of that is working with the TDM-IP program office to provide asterisks over IP. So we're going into a test phase at Tinker long-range radar right now to make sure that that is displayed on the glass appropriately. There are some ERAM modifications that are being developed right now to ingest that data. So we're looking at asterisk over IP, hopefully starting to roll that out from long-range radars in FY21. But that's still up in the air depending on testing. Sean, do you want to fill in?
Right. So also that's dependent upon, right, STARS and ERAM's ability to take that asterisk data in. And on a radar by radar basis, we're looking at the IP projects as an opportunity to provide SIM compliant, Eurocontrol compliant asterisk data. So, and that's probably going to be a topic also tomorrow of the future of surveillance section. So we can always ask that question again tomorrow.
Fantastic. Thank you, Mitch and Sean. Next question comes to us from Tom Moore. Is any plan being developed to provide a video of seldom done maintenance so that is done uniformly throughout the FAA correctly, or all maintenance activities, perhaps not on YouTube, but maybe on the TechOps tool link? So at this point, I'd like to tout that there is a TechOps video library, tvl.faa.gov. That is tvl.faa.gov. And there are quite a large number of videos there for maintenance tasks. I know that this is a continuing issue. Creating those types of videos is not an easy thing. We do have a video group out of Oklahoma City that is helping with those types of activities, but it's not as easy as YouTube. We need to make sure that everything is accurate and correct on those videos. So would anybody else like to add onto that? I don't know, second level, if y'all have a schedule of maintenance activities that y'all have lined up or anything like that.
I know, this is Mark. So yeah, I know in Power, we did a lot of those, and those were well received by the field. And I just got back to surveillance here, so I'll have to check to see what we've done over the years or what we have planned. But yeah, that doesn't surprise me. That's something we definitely have worked closely with Micah's group on, you know, for proficiency, rather than burden the bottleneck of the academy more. What can we do to be a little more innovative and creative to get, you know, knowledge in the hands of the field? So I'm all in on video. So I just don't know, you know, Sean, Mitch, if we've done much work on that.
Yes, so for my team, Long Range Radar, if you go on our website, you can see a video that we made on the carcer shutdown. And we're planning to do more of those types. We want to keep them highly professional, and also work with the union to make sure that we're touching all the right points.
Jeff, I saw that you had your hand up.
Yeah, and tomorrow I'll show you what is available on the TechNet video library specific to surveillance. There aren't very many videos there. The ones that are there are very good, and I'll discuss that a little bit more tomorrow. You can see what's there, but the challenge is making those videos, as Noel said, is not easy. They need to be done accurately and correctly. And certainly during COVID, we have a really big challenge. We just can't get those executed. But that's the direction we're moving, getting more of that material onto video. And the right place probably for that is on the TechNet video library. And I'll talk a little bit about that tomorrow.
Thank you for that, Jeff. And one of the things that I'd like to tell all of the organizations that are on here, if you do have videos on your website, that's okay. But please try to get them incorporated into the TechNet video library. We're trying to make the tvl.faa.gov the one-stop shop for all tech ops videos. So like that, our ATSSs can go to one place, have all that information there. Next question comes from James Zorn. Micah, in terms of training, has there been any discussions about having instructors dispatched to on-site facilities to accomplish much needed training, or is this even possible?
It is possible. Thank you for the question, James. It's absolutely possible. One of the considerations that has to be made is the course material is often, I know this is going to come in a shock, but a lot of times the field sites are not exactly configured like the academy sites. I know that's probably shocking to hear. But one of the things that we have to consider is the actual curriculum itself. Is it suitable for being taught at the field location? And then also, we try not to teach on operational facilities simply because you have the potential of creating an outage, and that's not typically acceptable. However, in these times that we have right now, we know there's a lot of facilities that have excess capacity and the ability to provide equipment. So we've been working with AJW on potential locations to teach at, where we could use either equipment that's not in use or is under maintenance. Good examples of that are field conducted classes for Mark 20, Mark 1 DEF, ETVS is one. Those are all courses that we are currently teaching out in the field, working with AJW and detailed instructors from AJW to do that. I think AJW 1 actually did a presentation on their field conducted classes at their all hands a couple weeks ago. So those actually absolutely can be done. The ones that are priorities for us right now aren't in the surveillance area. Things like MEARTS is a really big one. It's been under development for quite a while, but those are all located at remote facilities like Puerto Rico, Hawaii, Alaska. It's hard to get folks from those locations into Oklahoma. So it might make more sense to send a couple of instructors to those locations if we have a number of students. Surveillance could be the same way, but none of those particular courses that relate to national training for surveillance has risen to the level of importance that some of our other throughput requirements have, such as the ILS courses and now automation. So it is possible. Again, if we start hearing that as where we should be directing our priorities from our liaison and our executive rep, that will be something we'll turn our attention to and really try to make it happen. As of right now, surveillance hasn't been considered for field conducted locations at the moment, which isn't probably the nicest thing to say on a surveillance symposium, but hey, that's where we're at. So.
All right. Thank you, Micah. And last but not least, we're going to end on a kudos from Rafael Colon Alma. He says, kudos. Thank you to all the presenters for taking the time to put this valuable information together. Not only great info for the seasoned professional, but also great insight for our newer employees who in many cases have not been able to get training or come out to the field this year due to the pandemic posture. Thank you for providing the big picture and breaking it down for all to grasp. So thank you to all our panel members, keynote members. Thank you to all of you out there who took the time out of your day to attend this. I look forward to seeing y'all tomorrow during the second day of the Surveillance Symposium. Thank you. Have a great FAA day. Goodbye.
Hey, Jeff, you still there?
Yes.
Hey, fine job, by the way. I appreciate that. Made it sound so good.
We'll see how tomorrow goes.
I hear you. Well, I have a talking point tomorrow too. So, hey, so I got a lot of requests to get at that video library. I know it's on TechNet. Do we have a link?
Yes, but all you just go to TechNet, and I think it's the left-hand side drop-down menu, and just go in and grab it. I mean, if you just really need to go to TechNet, and then the video library is right there on references in the far left drop-down.
Is reference?
Yeah, it's easy to find on TechNet. It's not so hard. I can try to get you the. I can get the.
Yeah, I'm looking now, and Jeff, it's not so easy, man.
Actually, I didn't find it too hard. Let me just see if. Let me hold on a second.
I guess you have to have been there before.
Yeah. Give me a second, and I'll try to see.
Yes, sir. I'm looking as you're looking here.
I got to get back onto FRAC. Let's see here. Stand by. I thought it was a drop-down list under references. It just seems like it wasn't that hard. Fine. TVL, it's called.
Gentlemen, just a FYI, we do have about 90 participants that are still in queue.
Then they'll get to watch us
Perfect.
go to the TechNet video library for those that are interested, and watch us finding it.
I think I found it. I
You
started TVL. Yes.
Yes, and then you can search on a particular category of videos. So for instance, I searched on surveillance, and you'll see there's a number of them. I have a slide for that for tomorrow's presentation, but there are not many.
Outstanding. Yeah, Olga's telling me we have a hot mic, and that's okay because, hey, this is good stuff.
Yeah.
Thanks, Olga. Jeff, thank you, sir. I appreciate it.
You bet. Have a great afternoon. Olga, are we going to stay on to talk, or we'll just reconvene tomorrow morning? So,
Olga, you still there?
I think Olga's not here. I think the intention was to have a roundup meeting. I'm not sure what the invitation link is for that meeting.
Today?
That's what we discussed yesterday, but I'm not sure if that's still in the works.
Hold on, Olga's texting me.
Yeah, there it is. Separate meeting. She's going to send one out.
Oh, very good. All right, signing off.
All right, closing down the webinar. Thank you for participation.
A community is almost like a village.
It takes more than one person to provide that feed to make that radar work.
The amount of data that we pull together and we fuse together to provide a value to air traffic where they can have confidence in what they see, and then they start making a decision based off of that.
No matter how good you are and everything that you might know, there's always going to be something that just has escaped you.
You can reach out to somebody else in that community, kind of give you a heads up or a determination of what are you actually looking at.
it makes life a lot easier when you have that community out there to give you their experiences to augment your own.
I think community is part of the bigger teams. I think we all play a role. All of us together get the job done.
Part of my job is to provide training and mentorship, and that feels really good too when you see someone really, starting to develop their skills and gain confidence.
Everyone does their part, everyone has their input, everyone has a value that they add.
It's more than just an airplane moving from point to point. We help doctors and lawyers. We bring soldiers back. That gives me a real deep sense of purpose in the job that I do.
I want to be able to go to sleep at night and know that I can get in that aircraft and be okay with air traffic controlling the plane.
Thank you for standing by. In a moment, I'll be handing over to Deputy Vice President of Technical Operations, Jeff McCoy. As a reminder, all participants have their video and audio disabled by default. Jeff, the floor is yours when you're ready.
Thank you. I am ready. I for those that know me, I do like to talk, but I apologize. I'm not going to take up a lot of your time. Welcome back to day 2. I was really encouraged. I actually saw notes. I actually dialed in for a couple minutes of yesterday's one thing that was really encouraging was the level of engagement. First of all, just the number of participants, it was well over 500. I actually think that speaks to the criticality of what it is that this discussion is, what we're trying to do. I know there was some questions on here. We've done this. Are we going to do a similar one for communications and stuff? And I think the answer is yes. I think this is a pilot. But I think the level of engagement, both the number of people that dialed in and the questions that you asked, it actually shows that this type of symposium, this type of engagement activity, this type of opportunity is really well received. But it's only going to be a success if everybody continues that engagement throughout the rest of the day. I think what was interesting to me, the takeaways that I took away from what I heard yesterday, some of the notes that I saw, was the focus. It seems that everybody is getting that surveillance is changing. It's no longer an ASR 9, it's no longer an ASR 8, it's no longer an ASD 3, and so on. It is surveillance as a service. And I think this symposium kind of pushes that boundary. That surveillance is not a system, surveillance is a service. Yes, there are systems in the background, but we really need to approach this as a service. And kind of the big point that I want to push on here before I turn it back over to the facilitator on here, or kind of turn over to is ORM. You knew you weren't getting out of this without me talking about ORM. But I think when you're talking about ORM and service, that's exactly what we wanted to push when we were talking about operational risk management. When you're working on a channel, you really do have to understand the impact, the potential impact of what it is that your activities could cause. And understanding that surveillance is a service and not just the system that you're currently working on is key to that, is key to managing that risk. I will share for you one of the things that has concerned me, that has kind of concerned me the last couple of years, with all the integration that we're doing between the different surveillance platforms on the automation, is don't worry about it because we've got alternative sensors. And I know, for me, that's always been kind of a myth. We did not put in additional sensors. We did not put in additional services as just backup. We put them in there for a reason. We did not put an additional ASR 9 in O'Hare as a backup, the O'Hare ASR 9. We put it in there because there were limitations in coverage. We put it in there because there were limitations on what one sensor could do. Those limitations are still there when we lose a sensor. So as you go on, I want people to start thinking about, just because we have additional products coming in, just because we have additional sensors coming in, that should not say, okay, so risk management is not that big of a deal because we automatically have an alternative or an alternate sensor. That is not necessarily the case. So as we're going through that, I don't want to take up too much time. I hope that the level of engagement that you had yesterday is the level of engagement that you have today, because I've been getting a lot of good feedback. So certainly with that, Noel, I will certainly turn it back over to you.
All right. Thank you, Mr. McCoy. Smiles, everyone smiles. Welcome to the Surveillance Symposium to day 2. Today, we are going to be covering the current state of surveillance. Our second session is the major challenges facing the surveillance community, and then the future of surveillance. As a reminder, this session is not being recorded. However, PowerPoints, websites, links to KSNs, all of those types of information will be shared with you after the symposium. We encourage you to submit questions in Q&A. We will have questions after each session, and we will have an end of day Q&A. So remember, get your radar ears on, increase your receiver sensitivity, listen, lean in, and learn. With that, let's get started, and I'll turn it over to Sean Mock on the current state of surveillance.
Thank you for that, Noel. Good morning. I'm Sean Mock, and I'm the team manager of Airport Surveillance Radar Systems, AJW 147 in second level engineering. So when they asked me to speak about the current state of surveillance, the first thing that always pops in my mind is really how did we get to the current state? Now, yesterday, Don Taylor gave a really great presentation in the morning about the entire surveillance overview. He covered all the systems in our inventory and their uses. So I just kind of wanted to start with a quick refresh. Here's a one-page slide that I really like a lot because I feel like it captures the context of everything we have going on within our surveillance portfolio. You know, we have our non-cooperative systems and how we use them. We have our cooperative surveillance and how we use those functionalities. And then below that, you see the counts of all the different systems we have and the services they provide. So like I said, this is really just a real quick refresher, pointing back to the great material that Don Taylor presented yesterday, just reminding everyone that this is the number of systems that we have in our inventory providing the services that Jeff was just talking about. So like I said, my goal wasn't really to go into depth on this slide. I just wanted to refresh everyone with Don's materials he presented yesterday. So now in my materials, so what we have is Don also talked about SBS and WAM, which are in this slide on the right-hand side. And those are services. So what I'm really going to focus on is more of what we call the legacy surveillance, the surveillance systems that we maintain ourselves and that we do the maintenance on. So even though SBS and WAM are important parts of our portfolio, I'm really not going to cover much of the history of those. I'm really going to cover the history of the other type of services we use. So next slide, please. Okay, so the first ASR-1 went into operation in 1952 at Washington National Airport. What the FAA did, back then it was the Civil Aviation Authority. After World War II, we looked at a lot of the radar technology developed during the war, and we worked with air traffic, and we went to multiple airports, mainly in the East Coast, Northeast United States. And we spent 5 years of doing modifications to those systems, looking to see if that technology could really be used in civil aviation. Prior to having this information, air traffic often received vital information late or not at all from the voice communication. Voice communication with the pilot was the only thing they had. Once they got this technology, this new technology provided 30-mile coverage up to 10,000 feet from the airport. And this allowed air traffic to actually see and monitor the separation between the aircraft for the first time. they referred to this service when it first came out as ground control approach or ground approach control. And the air traffic was able to provide the pilots with instructions for an optimal approach to the glide slope. And what I found really interesting is that pilots were actually resistant to this technology when it first came out. A lot of the sentiment was, you know, I control my airplane. I'm letting air traffic put their hands, you know, on my control stick. Or there was a lot of sentiment that, hey, they're spying on me. They're spying on me on my airplane. So that was really the sentiment when this technology was first deployed, which I found really interesting. And another point is, after this was put into use, controllers at LaGuardia, you know, they were like, hey, this thing really helped us triple our landing rate to 15 airplanes per hour, which means before that, it was only 5 aircraft per hour, which I found it really interesting that an airport as busy as LaGuardia, that their peak rate would be 5 per hour. So that was some things I found really interesting about how introducing the ASR into civil aviation had such an immediate and profound impact. All right, next slide. So what you have here on the right-hand side is a picture of an ASR-1 antenna. It was actually rescued from a junkyard in order to be put into the Smithsonian Institute. So this is what that first version and radar looked like. And then on the left, you actually have a real picture from Washington Center of a controller looking at the radar screen. And I believe that was circa 1955. Okay, next slide. Okay, so when it came to air route control centers before surveillance, early controllers actually had to use maps and blackboards and do a lot of mental calculations to ensure aircraft operations were safe. These are actual pictures of route controllers trying to do their job. They actually used boat-shaped weights called shrimp boats, and every 15 minutes, they move those little boats across the map. And if they actually detected what they thought was a conflict, they didn't have direct communication with the pilots. They actually had to get on the phone, get on the radio, and start talking to airline dispatchers, controllers at airports, airway radio operators, and they really had to figure out how to communicate to the pilots that a potential conflict was upcoming. So it's, you know, I think to myself today, would I want to get on an aircraft and fly cross country knowing that those controllers had no communication access to the pilot? That's a very different world that they were living in back in the 50s compared to what we take for granted today. And not long, so something that a lot of people, especially if you've been around the FAA very long, know is that that 2 aircraft actually collided over the Grand Canyon in 1956, killing all 128 people on board both aircraft. After this, Congress quickly appropriated $250 million for major upgrades to the nation's airway systems, and a lot of that included advancements in radar surveillance. Next slide. So 1958, the first ARSR-1 went into operational use. The ARSR-1 had a max range of 200 miles, and it allowed the Air Force and FAA to actually control the airspace within and around the borders of the United States. The ARSR-2 was developed in the 1960s, but the ARSR-2 was really focused on improving the reliability of the service. So the ARSR-2 had the exact same specifications as the ARSR-1. The goal was really to design components that were more reliable and would last longer. And so after the ARSR-2 was developed, they went back and they retrofitted the ARSR-1s with the new ARSR-2 components. And that's where we got the ARSR-1-2 system. So the ARSR-1-2 was really the original ARSR-1 with just a 1960s upgrade. And ARSR-1-2 remained in service in operation all the way till 2015, when the last ARSR 1.2 was replaced by the CARSR. So that technology, we depended on it for a very long time. So technology developed in the 50s, we were still using it in 2015 to provide this service. All right, next slide. Actually, go back one slide, sorry. I just wanted to speak about that picture there on the right. So that was actually a display that actually had video and showed the raw video from the ARSR. And they went from moving the little boats on the maps to moving the shrimp boats on top of the display. They would actually write a little tag of the aircraft identification and put it on the shrimp boat and put it on that video display. And as the video moved, they would take the shrimp boat and move it to the new place of the video. So quite a step up, unbelievable technology at the time, I'm sure. So, all right, next slide. So this is not an FAA radar, but I couldn't help but share it. To me, this picture really captures the amount of energy and resources in the 50s that was being placed into radar technology around the world. After World War II, every country in the world was really trying to take this new surveillance capabilities and push them to the maximum. So here you have a picture of a UHF radar. Due to its low frequency, it had a requirement of a very large antenna. This thing is 120 feet wide and 30 feet high, and it rotated on a single bearing that was 13.5 feet big. So to me, this is just an amazing picture. I just can't imagine being the people who say, I work in that 7-story concrete building below that big antenna. So this, like I said, this just really captures the time to me, and it's really just amazing photo that people were willing to build this kind of stuff, and really they powered this thing up in 1958 and operated it for the first time. So, all right, next slide. Okay, friend or foe, secondary surveillance. So secondary surveillance is another wartime technology. The military needed the ability to identify friendly aircraft from unknown targets. So we equipped our aircraft with transponders that could reply to coded interrogations. The civil aviation took this technology and built upon it. And in 1959, we began deploying beacon radar systems in the New York area to help us tell aircraft apart. By May of 1960, there were 20 beacon interrogators in operations across 16 centers. And then by the end of the 60s, there were over 200 ground-based interrogators. So in an 11-year time frame, civil aviation went from having no interrogators to having a nationwide network of interrogators. So there was rapidly evolving how air traffic was being performed. And I wanted to point out that there's a lot of different terms for this technology. Sometimes people talk about ATCRAB, sometimes people talk about ATCBI, and all of these technologies, they fall under the subset of cooperative surveillance, which cooperative means that you rely on the cooperation of onboard avionics to perform the surveillance. All right, next slide. All right, so here's some key takeaways. As I looked through the history and evolution of these legacy radar systems, something that really stood out to me was that safety, security, and reliability, those were always the driving forces behind our surveillance acquisitions. Many of the original performance requirements have remained unchanged. Now, there have been performance improvements. We have better accuracy, especially than we used to, but I always found it interesting how much of those original requirements were never really updated. It was really, can we be more safe? Can we be more secure? And those were the things that drove these acquisitions. Also, if you look at the age of our current inventory, our systems, starting from the first date that system was operational in the NAS, the age of our systems range from 10 years to 45 years old. And I have them listed below. And so the maintenance of these legacy surveillance radars and their replacement systems, they're not going away. They're actually, we have plans to replace them, which will be covered under future surveillance later this afternoon. Providing maintenance of those systems is going to be critical to achieving the FAA's mission for many decades to come. So just because we've introduced SBS and WAM doesn't mean that these legacy systems are no longer a very critical part of our surveillance inventory. All right, I will turn things back over to Noel. Thank you, guys.
All right, thank you, Sean. And Jacqueline Wise, I'll turn it over to you.
Okay, all right, thanks, Noel. My name is Jacqueline Weiss. I'm one of the team managers for the Surface Surveillance Systems team, or AJW 148 in second level engineering. Go ahead to the next slide. So, okay, I have quite a lot of stuff to cover over the evolution of the ASDI and some other things that I feel like are important to mention. So I'll do my best to get through it pretty quickly, but if you have any questions, make sure that you go ahead and send those in. So air traffic is responsible for managing the flow of airport traffic. They do this through visual surveillance and direct radio communication with pilots and vehicle operators. So from this picture here, you can kind of see that during periods of limited visibility, such as nighttime or inclement weather, this can make their job pretty difficult. So the 4 red circles here on this picture actually circle aircraft that are moving around on the movement area. So with a surface surveillance system such as the ASDI, that helps air traffic in monitoring the location of all the traffic that's moving around out there. Okay, next slide. Okay, so this is a very high level timeline of the ASDI evolution. So in the 1960s, we had the FAA's first surface surveillance system, which was the ASDI-2. It was followed by the ASDI-3, which was developed in the 1980s. In the early 1990s, there were 4 fatal runway collisions that happened. And so as a result, in 1995, the Runway Incursion Action Plan called for the ASDI-3 to be enhanced with a collision warning functionality. The ASDI-3 was followed by the ASDI-X in the 2000s. So it still used the surface movement radar, but it was enhanced with another sensor multilateration. And then the ASSC followed that. So originally the ASSC was supposed to have been deployed without a radar sensor. But because there was no way to track the non-cooperative targets moving around on the surface, they went ahead and added the ASR and the ASDI-3 back in. Okay, next slide. Okay, so this just kind of talks a little bit more about the ASDI-2. In 1960, the FAA awarded a contract to AIL. This was for 10 ASDI-2s to be deployed at 10 ASDI-2s to be deployed at major airports across the US. So all of these ASDI-2s were deployed in the year 1965. It had an inflatable radome. And I actually found an article that was written by the original program manager for AIL for the ASDI-2, a gentleman by the name of Howard Ingleson. And he talked about delivering this radome in the trunk of his car to the first system, which was deployed at New York International, which is now JFK. So the ASDI-2 had a lot of maintenance issues and performance issues. So it had a vacuum tube design And data showed that on average, they had an unscheduled outage, which required maintenance every 4 days. So the performance issues that it had, it operated at a high frequency, so it was unable to penetrate heavy rain. So the background clutter was also pretty pervasive across the display. They were unable to remove it. And it also had issues showing the different aircraft out there along with the size. So they had trouble telling if it was an aircraft or if it was a vehicle. Also, it had one display that was up in the cab, black and white. So a hood had to be brought in because of brightness issues. They were unable to adjust the brightness of this display. So that drastically reduced the use by air traffic. In fact, it was so bad that they typically only used it when visibility was so poor that it was the only choice. Okay, next slide. All right, so the ASD3 came along in the 1980s. It was developed by Norden. It had some major advantages over the ASD2. So it had a clutter-free display, even during times of limited airport visibility. It was also considered modern digital technology. I have that in quotes because I know we still have a couple of these out there. And if you looked at the display today, you wouldn't think modern digital technology, but at the time it was. So the ASD3 also had multiple displays used in the cab. And each one of these displays were able to have different airport map overlays and operator selectable windows or insets that could be rotated and magnified, which allowed air traffic to focus in on critical areas, which significantly helped their situational awareness. It also operated at a lower frequency, which provided much better performance during time of rainfall, and an improved design of the antenna and radome assembly, which reduced the weighting and the wind loading. So once again, without the ASD, air traffic is in constant communication with pilots and vehicle operators. With the ASD, they're still in communication, but the ASD does also allow them to monitor the movement and location of the targets that are moving around the airfield. Okay, next slide. All right, so as I mentioned earlier, in the early 1990s, there were 4 fatal runway collisions. The first 2, one at Atlanta and one at Detroit, there were no ASDs installed there at the time. The third one, LAX, they actually had an ASD2, but it was down due to a parts shortage. And the fourth one at St. Louis, they had one of the new ASD3s at the time. However, it had recently suffered a hard drive crash and was offline. So the runway incursion plan of 1995 called for the ASD3 to be enhanced with this collision warning functionality, which ultimately was called AMAS. And the AMAS was an enhancement and an add-on to the original ASD3. It was first deployed in the early 2000s, and I believe that San Francisco was the first site to get that new enhancement. Next slide. Okay, this is an extremely high-level view of the ASD3 architecture. So you have the ASD3 antenna, feeds the radar data out to the displays that air traffic uses. It also provides a feed to the AMAS, which also takes a feed from terminal automation and the terminal radar. So the AMAS takes this data and it processes it through a safety logic algorithm, and it uses the position of the targets, the velocity, the acceleration rate to determine if a collision situation exists. That information gets passed back up to the ASD3 displays used by air traffic, along with tag information for arriving aircraft only. So no tag information for departures with the ASD3. Okay, next slide. All right, so likewise, this is a high-level view of the ASDX and ASSC architecture. These two systems still use the original sensors that the ASD3 uses. So you have a surface movement radar. And next slide, I'll get into the different types used on these two systems. It also still takes the feed from terminal automation and terminal radar, but it has an additional sensor, multilateration, that provides information on transponder equipped vehicles and aircraft on approach and on the surface. So it also takes a feed, an ADS-B feed that's provided by SBS. So that came along a little bit later, but it's on both systems now. So all of these different sensors feed this information into what's called the multi-sensor data processor, or MSDP. So the MSDP takes all of this information and it fuses it into one target that's then passed through another safety logic algorithm. And that information is shared with air traffic on these enhanced displays that are up in the cab. So the ASDX and ASSC data is also passed out via data distribution to multiple end users, such as runway status lights, studs, which shares information with both NAS and non-NAS users, such as TFDM, Falcon, and airlines. At Detroit, we also provide this, or ASDX information, back to STARS for the PRMA. And also data gets fed back to SBS for the generation of TSB messages. Okay, next slide. All right, this just kind of shows the different SMR subsystems that's used by the ASDX and ASSC. So ASSC only uses one SMR subsystem right now. That's the SMR3, still fed by the ASD3 antenna. The program office has recently kicked off a new acquisition to replace the ASD3. It's going to take a little bit of time, but we are working on that. Of course, those have been around since the 1980s. So the ASDX uses the SMR3 subsystem, but it also uses two other ones. The SMR-R, or Raytheon, that's fed by an ESAT antenna. That subsystem is obsolete and no longer supportable. So here in second level, we do have a project currently where we're working on replacing the SMR-Rs with the SMR-Is. We've successfully done that at both Atlanta and Providence. And we have plans to replace the remaining SMR-Rs out in the NAS. So the third and final subsystem is the SMR-I. It's the most recent SMR subsystem that we have. Okay. All right, so this is just kind of depiction of the evolution from air traffic's point of view. So you have this first picture here that actually shows a view out of the cab onto the airfield. So the second picture is the original ASD3 display used. Note that it only has tag information for aircraft that have come in and landed. So, and then the third picture is the enhanced display used by the ASDX and ASSC. So you can see that for the aircraft, they have little aircraft icons, and there's also tag information for both arriving aircraft and targets moving around on the ground. Okay, next slide. All right. So this slide here just kind of mentions a few of the major enhancements that have been deployed on the ASDX and ASSC. So the first one, the remote site gateway boxes that we use, or the RSGs, allow second level engineering remote access into all of the ASDX and ASSC systems. So this has been extremely beneficial. It allows us to constantly stream data back to Oklahoma City. So if we need to take a look at something that's generated an alert or some false targets or something, we have that data here on hand and we're able to do that quickly. It also allows us to push out software updates and site-specific adaptation updates to all of our systems. So we no longer have to send out some type of media for ATSS to install. The second one on here, this inhibit area, is only used on the ASDX currently. So prior to this mod, every time construction activities were occurring on site, we had to release multiple construction adaptations to help block out areas. This mod here reduced our construction-related adaptations by about 90%, which also reduced outages for ATSS to load these construction-related adaptations. So what it does is it allows air traffic the ability to create these inhibit areas on the display. So these inhibit areas map out and inhibit the display of SMR only targets. So if you have an equipped vehicle that's within that area also, it will not be eligible for generating alerts. However, if you do have like an aircraft in that area, it will generate an alert. So it does not suppress alerts on aircraft. And then the third and final bullet on here is a mod that we're currently deploying on ASDX. It's coming on ASSC early 2021. We plan on starting to enable it at ASSC sites. So, and it's the taxiway arrival prediction mod. I'm sure people have probably heard a lot about this, but wrong surface landings are an ATO top 5 safety issue and have been for multiple years. So I put a couple of examples on here. So Atlanta, back in Atlanta 2009, we had a 767 that came in and landed on a parallel taxiway. So NTSB came in and investigated and recommended to the FAA that we evaluate the possibility of enhancing the ASDX to provide taxiway arrival prediction logic. At the time, with the current design, we were unable to do so. It would have generated multiple false alerts. So then in Seattle, we had another one of these instances. So we had a 737 that came in and landed on a parallel taxiway. Air traffic reached out to us again. What changed from 2009? So at the time when this event happened at Seattle, we were already working on an enhancement to the current prediction logic. So this enhancement allowed us to add in that prediction logic for taxiways. And we were able to go operational with this new taxiway arrival prediction logic at Seattle in May of 2018. Next slide. All right, so this shows an event that happened in San Francisco a few years ago. So it kind of highlights the need for this new taxiway arrival logic. So what happened here was you had this arrival coming in at midnight, VFR. So he was cleared to land on 28 right, 28 left was under construction. The pilot got confused and lined up to land on the parallel taxiway, which had 4 aircraft lined up waiting for departure at the time. So the aircraft on the parallel taxiway actually noticed the arrival coming in headed straight towards them and was able to notify air traffic. I think analysis showed that this arrival, when he went around, missed one of the aircraft by about 50 feet. So it could have been a pretty significant event. All right, next slide. Okay, this just gives, excuse me, an example of what air traffic sees up in the cab when they receive one of these taxiway arrival alerts. So it's similar to what you see with a closed runway alert. The arriving aircraft that's predicted to the taxiway is highlighted, and a voiced alert also happens up in the cab. All right, next slide. Okay, so this just shows the 18 ASDX facilities that we've enabled this new alert at and the dates that it was enabled. Next slide. And here are the 17 facilities that are remaining. We've completed the optimization for most of these sites. COVID kind of put a halt to it because of training for air traffic, but discussions have recently resumed, and I think training is underway for air traffic. So Denver, we're gonna turn it on there next month, and I anticipate multiple other sites will follow soon. Next slide. Okay, last one. So this kind of highlights some projects that we're currently working on with the program office to sustain the ASDX and ASSC systems over the next 10 years. So I've only highlighted a few of them to talk about here. If you have any questions, make sure you send those in on the others. So the first one here is MLAT divestiture. The RU5s used by the ASDX and ASSC are obsolete and will no longer be supportable by the end of next year. So we're currently working with the program office on an analysis effort to see if it's possible for us to divest the MLAT. We do have ADSB coverage via SBS that provides the same information that the MLAT does. So it would still enable us to provide tag information for arriving aircraft and targets on the surface, along with tracking, transponder equipped aircraft and vehicles on the surface also. So down there in the middle, the SMR replacement with SMRI, I spoke about that earlier. So we are replacing those SMRRs. And the ASD3 SMR replacement, I spoke about that one a little bit earlier too. The ASD3 has been around, of course, since the 1980s. So there is a new acquisition moving forward to try to replace that radar soon. And then the SLEP, the one highlighted above it, is just to sustain that ASD3 out there until we can get a replacement. So it's still going to have to remain in the NAS for, at least another 10 years at some places. And then the one there on the bottom, the SMR infrastructure SLEP. This is another one. Program Office has recently started site surveys, and it's for the remote towers that the ASD3 are on. So we're going out to see what needs to happen to refurbish some of these remote towers. I know some of them are in pretty bad shape and the elevators don't work. So this project is supposed to cover refurbishment of all of that. It's also supposed to repair, refurbish, and clean the ASD3 rotodomes until we can get that replacement in there. So, okay, that's it. I know I covered it pretty quickly. So if you have any questions, make sure you send them in, and I'll go ahead and hand this off to Don Taylor. Thanks.
Okay, thank you, Jacqueline. Let's see if I can share my screen here real quick. Okay, I'm hoping you can all see it. And we'll get started. As Jacqueline had spoken to the ASD program, I'll just jump right into the terminal surveillance. There's a lot of legacy platform we have out there, the AS8 being our oldest terminal surveillance system. Again, it was the analog precursor to the ASR9. But what we have today to bring it to a digital format so that it can play with our digitized automation platforms, which was a requirement, we contracted with Telephonics to bring in the common terminal digitizer, which is basically a back-end processor. As you can see in the slide there, what's highlighted in red right next to the legacy form of the ASR8 is that common terminal digitizer, which was designed to extend the service life, of multiple types of, PSR and SSR systems. The application we have it for is the ASR8. Of course, they advertise it as a back-end processor. It could go on an ASR9, which is what they were probing, but we're not taking them up on it, even an ARSR. So, again, that technology is something that's out there. It's viable, but the applications we haven't applied it for immediately is the ASR8. Having tested, optimized that CTD, the results are very good. It's on par with, anything else we've got out there as far as the ASR9 or ASR 11 capabilities. The performance has significantly been improved. Weather presentation is markedly improved. The MTI, excuse me, what they had before is now MTD type technologies. So there's a lot of capabilities that were brought in with this SLEP, Service Life Extension Program, actually a tech refresh for the ASR8. We've got up there also the antenna. I'd just like to take your focus there. The RSI Vertex antenna, the 5-foot OPA, open planar array, was a 21 dBi reflector. It was in its legacy configuration. It was having issues with parts. The PMOs come in there and actually basically had those dipole columns reverse engineered and produced. Before, we had to cannibalize for parts, which is not the posture you want to be in when you've got decades old parts and you're trying to cull through that to find parts that will pass tests to make these repairable items serviceable. So the PMO has basically gone out there, reproduced those dipole columns, and produced enough dipole columns to affect the repair of 20 complete RSI and Vertex 5-foot OPAs. We've also got the 6-foot OPA that we're looking at for the ASR 11, which I'll get back to a little bit later. But again, we've got to look at the equipments down below as far as, DMS type issues, diminishing manufacturer sources, material shortages. We're always wrestling with our legacy platforms. Go to the next slide here. Moving on to the ASR 9, again, ASR 9's been out there for quite some time, and it's got its own set of issues there that we're working with the PMO to address. And again, tech refresh or SLEP type activities apply to the ASR 9. And what we've got here pictured is one of the recent modifications that AJW 147, Paul Backus, mechanical engineer working for that group, had come up with. In this area where we're fusing many of the sensors, we didn't realize that the registration issues that we were suffering with as single sensors weren't really obvious until you started fusing multiple sensors into one. And then there's issues with the ACPs from the single sensors, which this DPS plate, this drive plate system here, and the constant velocity link to the right, when those are applied, they actually greatly reduce that eccentricity that we would collect, azimuth change pulse. Sometimes you would have above the requirement for within less than 2 ACPs, it would be several ACPs, 4 or 5 ACPs. But when we applied this DPS and the constant velocity link, we routinely bring it back to around 1 ACP or even less. So it was a great benefit, especially on the automation side when you're trying to optimize a system of systems, trying to get this registration correctly with multiple sensors. So what we have is multiple modifications that are going to be applied to the ASR 9 to keep it viable, to keep it in this system again of optimized system of systems world that we're in. We've got the ASR 11. Again, same thing, where we are suffering from DMSMS on all of these programs. And many of them are being managed at the portfolio level. So when we do come up with many of the components that are part and party to each one of these line replaceable units, we have to discern whether we can reverse engineer that LRU or find an alternative source for some of these pieces, parts. We've got a program, a smart tool that will help us identify those particular parts and the vendors that may be able to supply those parts. But we suffer greatly from, again, DMS-MS issues across many of our platforms. And working together with the PMO, we are trying to resolve those issues, which is why we manage it at the portfolio level, where we can have a bit more flexibility on how it is we move those dollars around from one platform to another. So, it might be we have to concentrate on the ASR 8 as opposed to the 9, the 11 as opposed to the 8. But again, working with the PMO, we can make those decisions when we look and see how the shortfalls or the performance issues may be adversely affected. Moving on to the sensor. The Spectrum Efficient National Surveillance Radar is a program here that our management continues to be committed to, but it is under a 6-month feasibility review to determine the path forward for the program. Again, it's a multi-agency endeavor that we're in. We've got the DoD, we've got DHS, many organizations, many stakeholders here that will have a part of this. We are trying to collect the lower end of that L-band spectrum there, some 30 megahertz spectrum or so, and put that out to auction. During the 6-month period, we're going to be reviewing for what it is that this path forward. So it's still a viable program. So you'll be hearing a number of things during this period, but again, our management is not going to depart from this, but going to use this period here to just determine amongst all of the stakeholders what is the best path forward. Moving on to the cooperative. Again, we've got the ATCBI-5, our oldest surveillance, cooperative surveillance platform, which uses a sliding window detector here. Between divestiture program and the new program, the MSBRS, which is going to be coming in the next few years, will hopefully reduce, maybe even possibly have the opportunity to eliminate the ATCBI-5 platform. The Mode S, again, as and I'll be speaking to that on the next slide, the MSBRS would be the Mode S beacon replacement, uses the monopulse technology, and the capabilities that the Mode S would have over the ATCBI-5 is the dynamic reflectors. So there's a great deal of capability that was brought into the Mode Select that can use to learn its environment and actually determine where those reflections may be. We had upgrades over the years from the 68020 microprocessors to the 68040 microprocessors. So sometimes we can't evolve to that next level of software unless we put in some kind of tech refresh to upgrade. So processing power becomes a significant issue. Ergo, we move into, and you can see from the Mode S to the MSBRS here, that we're shrinking that package. So as our point-to-point wiring system, backplane wirings, and microprocessors, get more densely compacted into fewer LRUs, and we move from this, hardware and component, environment to a more abstract firmware software environment, our packages will become smaller and smaller and more IT type oriented, ergo like a computer for the backend processor. So we will put more of the algorithm in together as opposed to all of these single board computers, and slots. So you can see it's a very small but very compact package on the MSBRS. But this is the future. We've got the first few systems going out there towards Phoenix and Tonopah to test, and I believe that's going to be in 2022 that we will have that. So, and just one more. The MSBRS, for instance, we asked them about test equipment, and they haven't come back and says, well, there's not really much test equipment. So again, when you move towards these newer technologies, a lot of the bit fit that we would have is largely incorporated in the system, which is something that's interesting. But again, we are going to be working with them to make sure that certifying parameters are sufficient, such that it would be acceptable for us, which leads us into test equipment. We've got a lot of obsolete test equipments, and what I show here is the Field Fox as an example. So what we have here is a software-based tool that pulls multiple functions, and what I have here is the Mode S suite of test equipments down below that actually can be subsumed into one 6-pound box. The Field Fox here, the model 9913A, and provide all of the functionality for all of these other obsolete pieces of equipment that now, form the suite of the MODES test equipments. It could also be adapted to the ILS and other pieces of equipment. So it becomes quite the boon to, calibrate and maintain one piece of equipment as it is to maintain all of these obsolete single function pieces of equipment that we can no longer maintain. So there's quite a bit of capability that the future holds and opportunity to save lots of dollars and greatly improve the performance for these pieces of test equipment. And that is it for me. Back to you, Noel.
All right. Thank you, Don, for that. So if Don, Jackie, Jacqueline, and Sean, if you could turn your video on, we do have quite a few questions and a couple of kudos. First one comes from Neil Angelotti. A great surveillance history lesson. Thank you, Sean. From Larry Perkins, we got a good background for Air Traffic 101 and incorporation of surveillance into our system. Jacqueline and Neil Angelotti is asking, would all ASDX remote units be removed with the MLAT divestiture?
Yes, still a lot of work to do on that project, but yes, I believe the current plan would be to remove all of the MRUs.
All right, thank you. The next one I think is for you too, Jackie. It comes to us from Thomas Fizette. Will the SMRI antennas become the normal operational antenna of the future?
So on ASDX, we use multiple SMR types. So you have the SMRI and there's also the SMR3, which, like I said, there's an acquisition project in place to replace that. So I believe for the ASDX, we would still continue to use the SMRI and whatever new SMR type that comes out. And for the ASSC, the new SMR type would replace all of the ASD3s.
All right, thank you, Jackie. The next question comes to us from Philip Sandoval. The ASR8 and ASR9 are to be extended to 2035 by a SLEP program. But what has been done to obtain klystrons for the systems? The klystrons the system uses is old technology. Who still manufactures them? The newer L-6068 with an improved cathode has performed excellently, but the Varian VA-87, which is being rebuilt, has performance issues.
I can take that, Noel.
Okay, thank you, Darren.
Yeah, so so these klystrons, it's old technology, but the people are still around. Well, not the original people, but there are people and companies that do actually refurbish these. And L3 is the one that is the darker colored klystron. Some people refer to that as the ASR8 klystron. It's really, these two klystrons are the same spec and they are interchangeable, but because the 9s mostly had the Varian, which is now CPI, they always order that same one. We separated them out a few years back because they won't repair each other's. And now we have 2 contracts, one with each company. So the contracts folks allowed us to segregate it out instead of having one company do all of them all the time, which was a good benefit. You mentioned a quality issue on the Varian, which is CPI. They moved their manufacturing plant a while back, and they said it wouldn't affect quality or their timing, and they were wrong on both counts. And they're way behind, and they still have not caught up. And because of that, we put some L3s into the ASR9s. We offered them up, and the site took it, they installed it, and they're working good. So they are both the same specification klystron and are interchangeable, but that's probably not really common knowledge. And those 2 companies are still around and operating.
Fantastic. Thank you, Darren. The next question comes to us from Neil Angelotti. What is the time frame for MLAT divestiture?
Okay, so we're currently performing analysis right now to prove that we can operate both systems without the MLAT sensor. So I believe we have SRM panels planned for early next year. So we will have to get approval to operate without it. We have had a couple of ASSC sites where we had to convert over to the FTI COM. And during those timeframes, we were able to keep those systems operational without the MLAT sensor in there. So we believe it's not going to be an issue there. But definitely, we are hoping to have a software build that will allow us to operate without the MLAT by the end of next year.
All right. Thank you, Jacqueline. The next question comes to us from John Pizzicara. When are we going to catch up with the rest of the civilized world and progress to phased array radar? Don?
That's, we may get there someday, just not anytime soon. Again, that's what we were looking at towards the sensor. It's not necessarily off the table. Again, we are looking at it as a feasibility during this 6-month period, but the ASR portion of it had come off. The phase array may get in there in some manner or form for the long range radar, but we do have an ASR-R program, replacement that we're looking at for the ASRs off into the future. That'll be some years down the road. We'll see what happens.
Yeah, thank you, Don. And John, later on, we're going to be having a couple of presentations, and they're going to be talking about the number of radar systems that we have. It is no easy task. Think about the complexity of our surveillance system and the complexity of the NAS that we have. It is extremely difficult to change out a radar system. And then when you have the numbers that we have in the United States, that makes it a longer proposition and a very difficult proposition. But yes, something that it does, unfortunately, because we're so large and we're so complex, it does take us longer to get there.
Right, and the cost of the technology and the benefit has to make a good business case, right? So like Noel says, if you're looking at one site, the cost benefit for a small country might be different than a large country like the United States. So if other technologies can provide us a benefit at much cheaper, then it may be more difficult for a phased array to get incorporated in. But we're continually looking at it, and the cost does continue to come down.
All right, thank you. The next question comes to us from Philip Sandoval. Will there be any improved training in the FAA on installing and maintaining klystrons? Many techs have never installed, replaced, or aligned a klystron tube, which can cause problems soon after the tube is put into operation.
Yeah, let me just speak to that real quick. That there are videos that are being put forth, and we will be, and Micah is out there, he might want to jump in. We did have a video, say, for the ASR 11 rotary joint replacement that was put together. There are other videos that will be put together, and it may be made, part of the curriculum in the future. But it does take a good bit of time, in their curriculum that they would put together to allow for anybody to potentially, affect that as far as a lab or such. So, but videos will be made available and brought to like a YouTube format or such like this for folks to reference.
Yeah, Don, I would add to that and say, the end goal, of course, is to provide some sense of recurrent training so that what you learn in initial qualification training isn't all you get. And I realize right now we're filling that gap with a lot of wonderful work out in the field with TIDs and with T-staff that are coming out and basically sharing their knowledge and even performing some ad hoc training sessions. We recognize that that's not really a formal solution. It's something that we've been working on for a while now to try to institute some form of recurrent training. One thing that I would remind the audience of is just simply the fact that, our initial training is not designed or intended to be a catch-all for an experienced or a senior level technician, because the assumption is that you're becoming certified in order to maintain that equipment, not that you're going to be installing a new piece of like a new klystron every single time that you go out there. So there are some gaps in what you receive in training and what might be required for an advanced maintenance procedure, such as replacing a klystron. And those are the things that we would try to bridge the gap with videos and other recurrent types of training in the future. It's a process, though, and Don's right, it takes time. But that is absolutely on our mind. It's something that we want to fix. So hopefully that helps.
Yes, and remember, a klystron is one of those complex corrective maintenance actions. And that is the purpose for our TIDs in the Technical Support Center, and for our engineers in OESG and our second level engineering support. Technical services, TIDs, engineers are there to help with those types of change outs. So if you're out in the field and you need some help with the klystron, pick up the phone, call your local technical support center first, and let's work it out that way for now. Okay, the next question comes to us from Tim Ferriss. Will pilots have the option to receive wrong surface landing warnings in the cockpit from surface-based equipment?
I'm not sure what options they have for what they can receive, but I do know that we do pass that information out along through data distribution. So I guess the information from the ASD is there.
Okay. Thank you, Jackie. The next question comes to us from Philip Sandoval. The FAA does not educate their techs on the operation of the rotary joint, which has caused many problems. They know the inputs and outputs, but don't have the knowledge of how the rotary joint is built and what is happening within the unit, alignments of cavities. So they can check it out after shipment and before installation if they have the time. Darren, would you like to?
Yeah, I can talk a little bit about it. So I know the Eastern Service Area has a test procedure for checking them out. However, there were some technical issues with that, and I think they got them corrected. So there were some units depicted on the wrong, I'm not sure what it was, but there was a tech out in the field that was confused and said this rotary coupler is bad. And we got it all worked out. But Eastern Service Area, in particular, Frank Staler is the guy that wrote that, I believe. And so there is a procedure to run through that. So all you need is a network analyzer and check your inputs, outputs, rotate it, check your wow. It's really not that difficult. It's just the experience to learn how to do it, and it's pretty easy.
Don Taylor, would you like to add anything?
Yeah, Don.
Yeah, and again, this is what was spoken, and Darren's right. There was a lot of miscommunications going out there where, again, because of this, eccentricity issues and such like this, they were saying that they were bad rotary joints. A lot of these were not bad rotary joints. And just having the appropriate analysis for these. And again, I go back to those DPS plates that were put on there, has greatly reduced the number of rotary joint orders as a result of that, where they were saying it was an encoder issue or a rotary joint has largely been minimized to a great deal with the introduction of this new modification.
Hey, Don, Philip does bring up a good point about how the rotary joint works and the inner workings of the rotary joint. Earlier, yes, you talked about a video and videos being put together. Are we working on something like that for rotary joints? Just information on how it works, not necessarily how to change it out, but the inner workings of a rotary joint?
We would welcome that, and again, maybe Michael would kind of pull the thread on what I have. But yes, we are going to be heavily invested in videos, and maybe work that into the curriculum, which is where I throw Micah to kind of finish up. Michael, please.
Yeah, you're absolutely right. But for instance, I know that one of the conversations and activities that's been happening now is filming of using different rotary joints on adjoining radars. For instance, the ASR 9 rotary joint on the ASR 11. Within those videos, however, there is some discussion on installation procedures as well as the functionality and the purpose of different components within the rotary joint. Again, it's not something that's included typically in depth in your initial qualification training, simply because it's not considered to be a normal maintenance procedure. It is an advanced maintenance procedure. It's an advanced action that typically requires advanced knowledge, which is where you get into your TIDs. And also, I know the Logistics Center has an installation team as well. So there's some considerations that go with that. However, as we get these videos on board, we want to make them available resources, and our intention is to make them both embedded into the curriculum, but also available with the video repository that I know they're building up with TechNet and used to be called TVL. So a lot of those resources, we're trying to make them available inside and outside of curriculum. So they won't just live in an ELMS course or at the academy. They'll be in accessible places to be reused. And so that is a goal of ours. It's something that we're working towards, and we are doing recording activities right now.
All right. Thank you, Darren, Don, and Micah for helping answer that. Later on today, Stephen Schmidt is going to be covering the maintaining corporate knowledge, and rotary joint changeouts is one of those difficulties about maintaining corporate knowledge and losing corporate knowledge. So remember, on rotary joints, again, it's not a typical corrective maintenance activity. We do have TIDs, OESG, and engineers from the antenna team that are ready, willing, and able to help out with that. Okay, next question comes from Sandra Wright. Is the MLAT divesting a definite? When would it start? Could you repeat what the replacement system is?
All right, so no, it's not a definite yet. Like I said, we're currently performing analysis to prove that we'll be able to operate as good as or better without the MLAT sensor. So I guess you could say, I don't know if it's a replacement, but ADSB provided by SBS provides the same information that the MLAT sensor does. When would it start? So it would start, if we are allowed to move forward with MLAT divestiture, it will start probably by the end of next year. Don't have a good time frame for it yet. And I think the replacement system, yeah, I got it.
All right, thank you, Jackie. Wow,
Can I point out something?
Yes, sir.
Yeah.
So not to interfere with Jacqueline here, she's our expert, but I do happen to know that the alternative to divesting the MLAT is like spending over $100 million to redesign and redeploy the obsolete current MLAT system we have. So if SBS is able to provide all the information with just as much or more accuracy, then it makes sense to the FAA to not to take that $100 million and spend it somewhere elsewhere in surveillance where we have a greater need. So just wanted to share that part of the message.
Yeah, you're correct, Sean. That's a good point to bring up. So to replace the MLAT, the cost is pretty high. And so that $100 million estimate is just for the hardware, not installation or software updates or documentation or training updates. So.
All right. Thank you, Jackie. Thank you, Sean. So thank you to Don, Sean, Jackie. We still have like 15 more questions, but we're out of time right now. We need to try to get back on schedule. We're over about 5 minutes right now. We do have a Q&A at the end of the day. We will be saving all of those questions. We still have 16 questions now, and we will come back and try to answer as many of these questions as we have within the time allotted. A reminder, this is not being recorded. This symposium is not being recorded. Yes, all of the questions, all of the PowerPoint presentations, websites, KSN links, we will be providing that information after the symposium. So we're going to go ahead and save all of these questions that we have right now. We're going to take a 10-minute break, and we will come back with and address major challenges facing the surveillance community. Thank you. All right, welcome back. Again, my name is Noel Cavazos. I'm the OESG manager in the Central Service Area, and I am the moderator for today. Just a reminder, please submit your questions in Q&A. We will answer questions at the end of each session, and we do have a longer Q&A session around 3 p.m. Eastern time. At this point, our next topic is major challenges facing the surveillance community, and I'd like to turn it over to Darren Jerome.
Hi, thanks, Noel. Yeah, so I'm going to talk to you about challenges we face at the logistics center filling parts orders. So from the earlier presentations, you probably saw, so some of our oldest systems are the Beacon 5 and ASR 8 that were developed back in the 70s. So we have a lot of challenges with those. You can go to the next slide. We have a lot of challenges with those, finding those old parts, the old TTL microcircuits, tubes, meters are analog meters are one of the hardest things to get, those that are on the front panel of the Beacon 5, and there's some on the ASR 8 as well. So let me talk about how we go through, and so when the supply chain breaks down and we can't get the part for you. So we can have the best supply chain in the world. All of our algorithms are working good. We're dropping orders and we're filling our inventory, and we're sending stuff to vendors. We're repairing things in the shop. It's just working like clockwork, but there's always something you can't get. And that's always the thing that's needed at, the busiest airports in the world. And when you order that part, kid and want it, right? And it kills us because we wear our mission on our sleeve to get you that part. So we painfully go through and review these items that have obsolescence issues. We're working with second level engineering and service management and the PMO to get solutions to these. So at the lowest level, if it's like a microcircuit or a capacitor in the logistics center, our technical folks can find what we call form, fit, function replacements to take care of that and find those discrete components. At the LRU level, it gets more complex, and we start working with second level engineering to approve something, because it may take a slight software change to accept a new single board computer or something like that. So we work closely with those. So the solutions from our stakeholders are, we do it internally in the logistics center at the little form, fit, function level at the component. Second level engineering will help us, and they can fund a form, fit, function replacement at an LRU level. And sometimes in-service management helps fund that too, Don Taylor's group. And if it's bigger than all of that, and it requires a tech refresh, we get the PMO involved. And this is where our surveillance leadership team works well together, talking about these issues and determining where these solutions might fall and who might fund them, and how would that funding get appropriated and trickle down into the right area to take care of it. COTS items, commercial off the shelf. So a lot of the newer systems have their own unique difficulties because they have a lot of parts in them that are off the shelf. Anyone could go buy a single board computer and have that do just about anything in any electronic system out there. These companies do the same thing. Raytheon has them in all of their systems. So over time, those become obsolete and you can't get another one, but yet they'll have another revision. And we have to check those revisions out, test them. They may require new software. And the same thing goes with all the newer technology, routers. There's always newer models. And the thing about COTS, it goes obsolete so fast. It might be good for 2 or 3 years. Kind of like when you buy a new home computer, it's good for 2 or 3 years. And then you want the newer model there in the future. Same way with these parts, and they're hard to keep up with. So we do get a lot of parts, from secondary sources on these COTS things. We'll go out and try and find them, and just to keep things going along. LRU shortages. a lot of times I won't have a part to repair because they're all doing from the facilities. So it's very important when you guys get an E&R part out there to return that core as fast as you can, because I need to get that core off to a vendor to repair, or it needs to get into my shops to repair, because there's many more ASRs out there that are wanting that same part at some time. So I need to keep my shelves stocked, and I can't stock them if I don't have anything to turn and repair. So that's very important on those E&R parts. And real quick, the cost of obsolescence. So to do all of this is very expensive. The tech refreshes are millions and millions of dollars to take care of one part. They may look at all the parts in a cabinet versus just one. So we're talking a lot of money, and that's why I bring it up, because return those E&R cores to us, and we don't have to go buy more parts, do reverse engineering, non-recurred engineering, and all the labor it takes associated with managing diminishing sources and manufacturers. And that's all I have. And I'm going to turn it over to Steve Schmidt to talk about maintaining the corporate knowledge. Thank you all.
You're muted, Steve.
I'm going to try this again. Good morning, everyone, and thank you, Darren. I am Stephen Schmidt, and I am the Eastern Service Area Operations Engineer Support Group Manager. And this morning, I'm going to be talking about maintaining corporate knowledge of our technical workforce. For our new folks out there, corporate knowledge is not a one-time event where you go to Oklahoma City, come back knowing everything you need to know. It'll take time to fully understand the relationships between the theory aspects and that practical hands-on experience. And chances are, I hope, you'll never stop learning. There will always be something that will lead you to make a deeper connection. And if you only perform preventive maintenance tasks and miss corrective maintenance opportunities, over time, maintain that corporate knowledge gets even harder. I do say corrective maintenance is an opportunity. This is a time where you apply your knowledge and skills and learn the most you ever will. So how do we share knowledge and develop our folks at all skill levels? One approach is collaborative cross-training. I encourage you to work as a team out there. We are a diverse workforce that we can learn from, such as troubleshooting techniques. We can get this from any discipline. Point being, we can reach out from the surveillance discipline and build the corporate knowledge. Hey, take opportunities during NASDAQ. Our tech inspectors have a great corporate view of all systems. They have been out to several SSEs and know where the issues are. OESG and TSOG visits will be some of the best experience you ever gain. These ATSs and engineers are exceptional folks and are always willing to assist and share the knowledge. I encourage you to learn the most from those. Engineering services site visits are great for getting an understanding of the construction and the installation side of the FAA. Partner with these folks and you can pick up valuable skills. In fact, I remember learning some phasing techniques from ES years ago that I got nowhere else. Rotating workforce is another opportunity. If we ever have an opportunity, we never want to limit our exposure to learn opportunities. Look for opportunities to expand your horizon and increase knowledge. You may consider asking to work at adjacent facilities to improve skills and abilities. Get involved with modification teams that might come to your site. And most importantly, network with folks outside your SSCs. The big one for you is informal OJT. I encourage you to find opportunities to pair up with your fellow HSSs and look for opportunities to learn. You may have an opportunity to help perform a PM or corrective maintenance on something you have lived experience on or in. This is a great learning opportunity. Currently, we have a significant number of retiring and retirement eligible folks with expertise that will never get back once they leave a workforce. If you fit this category, we need your help to pass on your knowledge. Bottom line, our make or break success depends on experienced radar techs like you transferring expertise and knowledge to new hires as well as everyone else. Another way we try to share knowledge is through workshops and seminars. These are conducted periodically by technical services, ATSSs, and engineers. And we are constantly looking and working to build skill sets at all levels of expertise. We have developed technical and documentation workshops and seminars. Just to make examples here. The Fundamentals of Documentation course, also known as the FunDoc, is a workshop that provides training for first and second year technical ops personnel on maintenance procedures and documentation requirements. Subject areas include maintenance procedures, simplified automated logging, coordination, metric tools, and other technical documentation. This course provides new employees with an understanding of their roles and responsibilities as defined in FAA orders. The Coordinates Policy course, known as CMPC, provides training for all technical operations personnel on FAA Order 6015, which is our general maintenance handbook for NAS facility compliance and compliance. As you know, localized face-to-face training is on hold, but currently we have some virtual stuff available. Some examples are NASDEP op briefs. That's taken place that face-to-face, and we got some good stuff out there. And through these, we've kind of customized the CMPC and the FunDoc course specific to the SSCs. Yes, we actually saw the weaknesses after the NASDEP, and we fine-tuned the courses to fit those. And as we talked about, I know both Don and Noel and Jeff had talked about the videos that are available to you, as well as surveillance workshops. We're constantly looking for your input to improve all of these, so please keep it coming. As you can tell, we have a multitude of opportunities, not only to maintain our corporate knowledge, but to go build that corporate knowledge, and I encourage you to do so. Hey, thanks for your participation, and thanks for your time, and I'm gonna turn this over to Jeff Bogan. Jeff, you there?
I am. All right. Good morning, everyone. Welcome back. My name is Jeff Bogan. I'm the manager for the WSA's Operations Engineering Support Group, known as OESG. Again, it's really great to virtually reach out and connect with the team that supports all of our surveillance systems in the national airspace. You are a very cool bunch, and this is very specialized group that has specialized training on some really cool stuff. So as we mentioned before, as our field specialists, you are one of the most important resources that ensure that our radar and other surveillance systems are operating properly, reliably, and accurately. As you heard, there are a lot of FAA groups and training opportunities that are here to help you. But ultimately, you are the ones that directly interface, that take care of, and that maintain these surveillance facilities. How you accomplish these tasks is something we measure on a routine basis to assure things that are working well. The National Airspace Technical Evaluation Program, that's our NASTEP program. It's the primary way we review and accomplish quality control for our TechOps maintenance program. One area I'd like to highlight today are some of the top NASTEP findings we find specifically with our surveillance facilities. Now, generally, as with most of our facilities, the overall logging, the lack of coordination, and missing preventive maintenance issues, they continue to be our top NASTEP findings. Let's look at the next slide. All right, for reference, I put up a simple bar graph that shows the last 3 full years of NASTEP finding issues we find at our surveillance facilities. See, on the vertical, on the left vertical axis of the graph are the average number of NASTEP findings per evaluation. And on the horizontal axis, I'm showing NASTEP evaluation findings by category and with specific surveillance platforms. Like if you look closely, it's the ASR, we got CPMEs up there. We've got AtCrab and MODES. You know, I know the graph's a little hard to read in Zoom, so I apologize for that. But on the slide, we see the 4 NASTEP areas where we have on average over 20 findings in the categories of preventive maintenance, ETPRs, that's electronic technical performance records, modifications, and FTAs. Now, of the majority, they're generally occurring at ASRs and at our radar beacon parrots and at our Mode S facilities. Those are where we find the highest numbers. So this is something for you as our surveillance specialist to be really keenly aware of. You really got to pay attention to that. So why is logging so important? First, following our orders and directives with proper annotation, it's a liability and it is a legal issue. If there's an aircraft incident, proper documentation, if it's not completed accurately, it can result in FAA contingent liability consequences. And this has unfortunately happened before. In addition, and just as important, the proper logging documentation helps us to prevent unexpected outages and ensure that our control facilities are aware of your actions at the site. It's key. It's key in ORM. And there is another important reason logging is so important. So many of our other FAA organizations, they count on accurate data from the logs. Logistics uses the logs to support organizational supply and support operations. It's very important. They are used for local and national staffing analysis. That's how we look at staffing resources. They're also used to evaluate FAA surveillance budgets. That's how we determine how expensive it is to maintain, take care of our equipment. They look at all of that data and that drives the engine to determine surveillance budget. So that's why logging is so important. So it's really important to get it correctly done, and you are the key to making that happen. So another area that the NASTEP finds as a challenge are missing or incorrect ETPR records. We find a lot of these. And if you've had a recent NASTEP, you know that that's always popping up. And that's a challenge for us to get you the right level of training and understanding about why that and how that happens so often. So for surveillance, what we find are incorrect or missing site-specific parameters. And into surveillance, really, we're looking at the things that don't seem to be there are power, VSWAR, MDS, and STC. And specifically, the power and the VSWAR calibration and the associated readout parameters you see, the entries, they've not been correctly established in the TPR. Now, most of the time, these parameter changes, they're generally related to past radar optimizations. It might have been right when we commissioned the site, but after we do an optimization, they're not being properly recorded from there and into the right documentation. This is where new performance parameter data were established and they've not been documented. And another surprising NASTEP finding are incorrect or missing key performance parameters. Now, these key performance parameters, they're not always tied to a particular PM, or sometimes it's listed as needed. So then when our NASTEP evaluators go out and look at these, they're often incorrect or they're out of tolerance because you haven't looked at them in a while. So later in the symposium, I'm going to speak more about ETPR and FRD training that's available to help you with all of this. But I wanted to let you know that there's a new TS initiative that we'll be rolling out in the first quarter of this year that's going to really help with the training on ETPRs and EFRDFs. There's a lot of nuances in the notation and how you record the data and when you record it that you really need to get good training on, unless you've done it a lot. But sometimes when you do it too often, you can forget it. So it's always good to do a refresher. So we'll roll that training out to you, and it should be really good. So another area that NASTEP finds a high number of surveillance issues with are missing PMs in the PM scheduler. It is extremely rare to have a NASTEP evaluation not find at least some, if not quite a few, that are missing from the PM scheduler. And unfortunately, this happens far too often. And we get a and until we really get an automated process for doing this, which you really think would be obvious, but it's not so easy to implement. And when we get that process for populating the schedule with the latest qualified and required PMs, this all needs to be manually adapted and all reviewed by the surveillance specialist and your manager on a regular basis. Some of the areas we see surveillance scheduling emissions is with missing antenna maintenance and battery maintenance. So you really got to look at those. They pop up often in NASDEP findings. And if you've been out there during NASDEP, I think you've probably been familiar with some of those. So take a look at those. Compare what's in the PM and then in the latest FAA order. Look what is actually adapted in the scheduler. And these need to match up exactly. And just one other thing to notice as you look at NASDEP surveillance finding issue graph. One of the most common findings is the lack of facility transmitting authorizations, FTAs. We see this particularly at our radar beacon parrot and at our CPME sites. So please take a close look at those, see if your facilities have the proper FTAs established for your parrots. And don't just do it right before the NASDEP team comes out. You need to take care of that, make sure you know where they are, make sure it's in the right location, and ensure that they're up to date. And because we tend to move our beacon parrots and our CPME sites sometimes, the FTA is not updated properly, and that needs to be taken care of. So as a surveillance specialist, logging is a very important part of your site support responsibilities. You're not just there to fix the equipment, but you're also there to log those activities. Again, it's important for ORM, and it's important for all those reasons I talked about before. So the next time you're out at your facility, take a careful look at some of those logging problems that we commonly find with our NASDEP evaluators. And if you need help, well, just call any of our NASDEP evaluators and we'll get you the right training and support to help you on any of those issues. All right, let's look at the next slide. Okay, so now I'm going to switch topics quite a bit from logging to another very challenging issue we have in the radar community today. And it is about building and construction impacts on our NAS surveillance systems. Impacts that affect our terminal, that affect our en route, and affect our weather radars. Now, if you're like me, this is a very cool and interesting set of problems. It's technical, it's difficult, and it's really challenging. And while we don't have quite enough time to dig deeply into this, I do want to share some of the difficult problems with obstructions to our radar target and our weather detection. And as important, what you can do to help out with some of this stuff. All right, so next slide, please. So let's look at the two biggest categories of radar obstructions being built that we see in the NAS today. The first category is related to airport expansion projects, such as we have air traffic control towers, we have concourse expansions, hangars, and near large, we have really large hotels being built, and they're getting more popular all the time, and they're building them right at the airports. And there doesn't seem to be any stopping airport expansion at many of these locations. There seems to be no stopping of any of those activities. And it's really odd that it's all around those airports, but they're doing a lot of building. So the FAA faces really big challenges to mitigate the impacts of this type of construction. And the second category really are near and off airport obstructions, like the Amazon facilities. Maybe some of you have seen those. Some of these are huge. New football stadiums are going up. That seems to be very popular, and they are bigger and better. Now, I like going to football games, but when you're a radar person, I look at those and I say, uh-oh. And we have got large solar farms being built. Those are really expanding. And we have wind turbines. Some of our biggest challenges are right there. So large buildings can block our radar line of sight. They're easy to understand and analyze, but where line of sight is really critical to the air traffic coverage, this problem is not easily mitigated unless we have a well-performing and we have overlapping sensor coverage of some sort. On an airport, we can usually prevent this type of construction or have them lower or move the building to a different or less critical area, but not always. And solutions to raise the tower and add other radar sensors are considered in these cases. but that's really difficult, really expensive. And sometimes these buildings are so large, like a football stadium, that the only solutions involve additional radar detection equipment like wide area multilateration systems, or even new gap filling radar sites. Again, really expensive, really difficult to do, very challenging. Usually all this is so expensive, the FAA can't afford it, but the proponent generally pays all or part of most of this. At least there's some solutions we can consider. All right, let's look at the next slide. So right here, I've included a picture of the new LAX stadium. Now, I don't know if any of you've seen it yet. It's just about complete. And take a look at how large it is. It's over 180 feet tall. It's over a half a mile wide, nearly a mile long. And it's only 4 miles from the LAX radar. The stadium's directly in line of sight of the final approach there. And it's not just a line of sight issue. Such a large structure has a really significant impact to our LAX radars in terms of false targets and related beam scattering and sintering effects that could produce that really produce anomalous tracking problems on the LAX radar, TRACON, and STAR systems there. The beam actually can hit the top of that, breaks off into literally pieces, and we have multiple interrogations, code garbling, all sorts of problems with a radar that is in direct line of sight with that stadium. Now, the good news is we've installed a WAM system around LAX to mitigate this problem. And that stadium's just about complete. And I'm going to tell you, the WAM system works really well there, but it's a really large WAM system, and the proponent certainly has supported helping us pay for that mitigation. But these buildings and the associated potential static line of sight blockages, they're not really the most technically challenging. It's the wind turbines that can affect the detection of both our terminal and our en route search, our ASR, our RSRs, and weather radars. Let me put a picture up again. Let's look at the next slide. Take a look at these slides showing 2 pictures of wind turbines. They're huge. The picture on the right shows a 15 megawatt turbine, 400 feet tall. The spanning of the blades is over 700 feet long. These turbines have a very large radar cross section. And the picture on the left, now that's typical of a large wind farm. It consists of hundreds of turbines over tens of square miles. Certainly, it's really great for power, and it puts out almost a couple terawatts of power, but very difficult for our search radars to deal with. Wind turbines also have a serious impact to our weather radars, including the NEXRADs. Now, here's the problem, and it's very difficult to solve. It's not just like a typical radar ground clutter problem. The problem is that the wind turbine blades cause Doppler artifacts, and that resolves into targets that have radar cross sections and velocities just like aircraft targets. For many of our radar systems, we got good radar and clutter suppression software algorithms. And target detection in clutter is some of the most cool stuff we have going on our radar systems today. And if you're like me again, you just eat this stuff up. And there are tens of thousands of line of codes that are used to identify and eliminate fixed and moving clutter in our radars. The whole idea is to pull the target out of the clutter. But for the most part, our ASR 8s, our ASR 9s, our ASR 11s, well, they all see these turbines literally, and they look like moving aircraft, and they are not easily eliminated. Please, let's look at the next slide. So I just wanted to give you a taste of just how difficult and tricky this situation is. This is a picture of turbine clutter at our Palm Springs ASR radar site. There are hundreds of wind turbines surrounding the site, and this shows a very significant loss of search radar detection. So just look at the slide for a minute. In the blue, that looks like lines going from south to north, that is the wind turbines. They are lighting up in blue, primary radar only, and you can see there are lines of wind turbines, hundreds of them, all in a single line. In the red, now let me go to in the green are good targets. They're radar beacon reinforced targets. Those all look great. And if you look carefully at all the red, those are primary radar targets. And if you look really closely, you'll see that, the red are beacon only targets, and they're missing the primary radar target. And that's the point. I've been looking at this so long, I'm getting confused myself. But you'll see that underneath the blue, where you see the red, that is missing primary radar. And we are missing primary radar over tens of square miles. And it's the clutter artifacts that are caused by the wind turbines are preventing the search radar from being detected in that area. And so we literally have no primary radar coverage in that area at all. So it's a really serious problem, and it's very difficult. So the best we can do is typically just raise those clutter thresholds, which are in most cases it just simply blanks out the search radar detection over the entire area of the turbines. And this unfortunately results in the loss of search target detection in those areas. Some of the potential turbine elimination good news may be possible with the ASR8 and the new common digitizer, which they could use dual beam processing and some fancy IQ channel turbine phase signature comparisons to get rid of some of that clutter, the wind turbine clutter. But we haven't thoroughly tested this, or we haven't implemented it yet. Now, the same idea could be done with the ASR9, but the point is that there's a politically and economically no stopping wind turbine construction. It's in our collective national energy policy to deploy these. So this is going to be a continuing challenge for the primary search radar community to manage. And if air traffic or other users really need search radar, then technological solutions will be needed. And simple adaptive search blanking, either at the radar site or in the automation, it's just not sufficient. So let me change subjects just a little bit. The OESG organization, we execute what we call the FAA Tech Ops Obstruction Evaluation Program. We call it OEAAA. So when a proponent, an airport, or the FAA builds something, they should, in most cases, file a case file so that we can analyze the construction data and provide a mitigation solution where it's possible. But if you see something out there, if you're looking out there and you're concerned, let us know. And we will go and take a look at this. Let your manager know. They'll contact the OESG teams. We'll ensure that a 7460, if it hasn't been filed, does get filed. So take a look out there. For the most case, when we're building, the FAA is building projects, we're filing what we call 7460s. And most folks know, and most construction folks know, that you need to file 7460s. But if you see something, please let us know, and we'll ensure that it gets reviewed. So what can you do to help? Well, you can do a lot. Radar detection is not exact, and that's why we call its detection capability a probability of detection. The best thing you, as a radar specialist, can do to ensure that the radar system is meeting all its standards and tolerances. So keep an eye on your PMs and watch and maintain all those performance parameters to establish tolerances. And that's certainly going to help with target detection in clutter and help to eliminate the existing construction effects in the best way possible. You make a really big difference here. So we've been going out and we've been optimizing radars for best performance, but you need to maintain that performance to those new optimization levels. So it's all about you ensuring that that's done. That's our best chance to get rid of clutter artifacts that we see from construction and from other types of buildings that we see out there. So please take a close look at your PMs, try to maintain the best as possible, and the OE folks will help ensure that we don't build anything that we can't maintain or mitigate. So construction issues are also a concern. We need to move a radar or Parrot or CPME. Many of you have done that before. This is also a problem where construction-related activities require an RU to be moved, like an ASDX, an ADS-B, or even one of our wide area multilateration systems, WAM. As many of you are aware, the Parrot and the CPME, it's the heart of the radar system, and it's critical for the ASDX. So when you need to move these systems, please be aware that this now requires a precision survey and an associated adaptation. Now, in the past, the SSC was very proactive and helped us move this to a new location on their own. But today, we really need this to be done in a formal way. And you all should engage with your OESG and TSOG organization to help with the survey and the radar automation coordination. In some cases, and in particular in WSA, we use an NCP process to ensure that everything is completely covered. Again, please call your OESG and TSOG team for help with this. They're there to help analyze this, and if necessary, they'll help to relocate the impacted Parrots, the CPMEs, and the ASDRUs. So you can see we have some really big construction challenges, and you're a big part of making the solution to that. Thanks so much. Let's go back to the moderator, Noel.
All right, thank you, Jeff. Yes, I believe all of the service areas now require an NCP whenever a CPME or a Parrot is moved. In addition, to tag on to the construction piece, we in OESG, we need you, the ATSS out there. If a construction company has not filed a 7460 and you alert us to it, we get with real estate and we get with legal, and we can go so far as to have attorneys force that company to file a 7460 so that we can do the obstruction evaluation. I'd like for all of the other panelists to please join us. Stephen and Darren, we have a couple of questions. First one's more of a statement, Darren. One thing that would be very helpful in having accurate is having accurate photos and descriptions on LCSS, perhaps also a section that specifies which systems the part is being stocked for to enable faster searching.
Yeah, so if you ever find a picture that doesn't match what you're ordering, that's an issue. The people that match the pictures to the part, they're not technical. They don't know what that is. They're just taking pictures and putting them in there. So if you find one that's an error, contact Customer Care Center. And in our trifold that's in the artifacts of this meeting, it's in the quality division, and they'll get that information to them, and they can fix that. Every part has what's called a product family, and that may not be visible on the customer portal. I don't know, but I'll check into that and pass that information on.
All right. Thank you, Darren, and thank you, Christopher Pear, for that statement. The next question comes to us from Thomas Fizette. It's for Steve Schmidt. Hey, will Steve Schmidt's notes on the corporate knowledge topic be posted along with other symposium information from the last couple of days?
This is an easy one. I like this. Yes.
All right.
Thank you, Noel.
Thank you, sir. Next question or comment is from Dave Boring. I've been a radar installer with engineering services for 26 years. I always try and get the local techs to jump in and help and learn on the system as I'm installing it. They can get some real good experience without the worry of working on a live system. Has worked very well over the years. Yes, I grew up in engineering services also, and when I was installing radar systems, I always welcomed the help or trying to teach ATSSs out there. So yes, when an engineering service project comes along, volunteer, get out there, help when you can. The next question comes from Timothy M. Ferris. Do you have a list of these training resources you just mentioned, Steve?
I do not, but I can definitely get something put together, and I'll have that put in that stuff.
Yeah, I think you mentioned the Fund Doc, the CNPC,
yes, sir.
And other stuff like that.
We'll definitely do that, Noel.
All right. This next question comes to us from James Hall. You mentioned that key performance parameters are being found out of tolerance because there is no PMs associated with it. I don't know if I missed it, but is there work being done to assure that there is a PM correlated with every key performance parameter? Jeff.
So second level is trying to put together the systems that would allow us to automate that. So we are not done with that yet. So I think the question is asking, is there a way to do this in to ensure that the PMs in the scheduler match up with what's in your order? And I don't believe there's an automated way to do that yet. So when those new orders come out, you need to ensure that those get properly into the PM scheduler. And while they try to do that, we don't have a perfect way to automate that yet. So you need to continue to manually make sure that what gets changed is changed accurately and you have the latest information.
Right, and just to remind everybody, yes, second level engineering is responsible for all of the technical documentation for all of our systems out there. But everybody else, all of us that work on systems, we have the responsibility to check those. And if we see a discrepancy, to actually get that back to second level engineering so that they can do that. You know, it takes the entire community in order for everything to be working properly. So please help out with that. The next question comes to us from Bradley Crouch from AJW 134. Reference the NASTEP write-ups. Have there been any discussions on mitigating the impacts of PRIBS 21 and 23? Did in all but eliminating our mentoring program by removing time and grade requirements for promotion. It used to take at least 2 years to become a journeyman depending on the grade you hired in. During this time, you were assigned to an experienced tech for OJT on how to log, etc. Now, if a new hire gets the right schools, I've seen them turn loose after just 6 months. Oh, who is anybody familiar with PRIBS 21 and 23? I'm going to go ahead and take a rain check on that one. We'll answer that at either later on this afternoon or when we put out all of the artifacts associated with this one. The next question comes to us from Sean Cooper. Does the FAA have an encroachment management program to minimize local impacts to obstructions for our SSCs? The AF does this to minimize constructions of buildings, wind turbines, et cetera, in and around, Air Force bases and Air Force mission locations.
I can answer that or try to answer that if you'd like.
Yeah, and I can help if you need
well, so the control of construction around airports on airport property is, while it's controlled, the airport really is responsible for reviewing those projects with a number of folks, including the FAA, and every single construction change is generally done with an airport layout diagram, and they generally are very well organized in planning construction. So even before they start building, they're talking to us, the FAA, about future construction and asking us what the potential impacts are. So on airport, we have a pretty good controlled system, although the airport is under a lot of, well, it's in their interest to expand capabilities. And to the extent they can push that, they do. And they like to build new hangars, new buildings, and provide everything they can for their users of that airport facility. And so it's pretty well controlled on airport. But when you say formally controlled, only to the extent that the FAA is engaged with them in all construction around airports. And there are other impacts to other systems besides radar, on navigation, communication, that's all impacted. So we're generally at the table for almost all construction impacts on airport. So we do have some control over that. Off airport, we have very little control over general building outside of the airport area. And we rely on the 7460 process, which is a law and which they are required to file when they do any construction that is tall. And so that is controlled to that extent. And that's about the best we can do in that environment.
Right. And the catch-all phrase in that law is at the FAA's request. So if you see construction going on at any FAA facility that's away from an airport and you have some concerns, if you bring that up to your SSC manager, technical support, or OESG, we can start looking into that and try to find out what it is they're building. And if we think it's going to interfere with one of our facilities, we can get, again, real estate and legal involved to force them to file a 7460, because then that is at the FAA's request. It's 11:10 right now, and we still have another 14 questions on here. We're going to save these questions for the end of day Q&A. We're going to go ahead and break right now for, let's have a 50-minute break and return back at 1 past the hour. Thank you very much. Enjoy your break and look forward to seeing you back. Jeff, turn your camera off. All right, and we're back. Welcome back to the Surveillance Symposium. Just a reminder, this is not being recorded, and all PowerPoint presentations, KSN websites, links, and all that type of stuff will be shared with everyone after the Surveillance Symposium. We have a total of 30 questions in our Q&A right now. We will be getting to those at 3 p.m. Eastern time. Please keep your Q&A coming. Right now, I'd like to go ahead and turn it over to Micah Campbell and continuing with the major challenges facing the surveillance community. Over to you, Micah.
Wonderful. Well, welcome back, everybody. Hopefully you had a good lunch. I know that it's been a busy couple of days and you guys have really hung in there being engaged, especially hard to do virtually. So I'm well familiar with this challenge and just thank you guys for hanging in there. I've got to say too, I'm really impressed just the number of people that have continued to be a part of this, and I'm honored to be able to present to you guys this afternoon. So I know that already we've had a lot of questions around training and that's a significant concern for everybody out there, both from a career progression standpoint, but also just a competency standpoint in order to do your job. So it's something that I'm very concerned about. In the limited time that we have here, I won't be presenting a lot of detailed information on individual courses, but I will be talking a little bit about what my organization does and how we fit into the big picture and how we can work with you in AJW and you as a technician at the ground level all the way up to improve the quality of training and just how you guys engage with us. So slide, please. So one of the first things to look at here is just where do we fit in the organization? And by we, I'm in an organization called AJI, which is Safety and Technical Training. Now, many of you guys are probably familiar with the FAA lines of business. There's 5 of them, and you can see them listed on the side there. One of the biggest, the largest, being the Air Traffic Organization. That's no secret to anybody. What a lot of people don't realize, and I find this to be true whenever I talk to new hire classes of technicians that are coming into the agency, all the way up to seasoned engineers and technicians, is that AJI is a service unit under the ATO, and we have a vice president that works alongside of Jeff Planty and of all the other VPs that are serving under Terry and Tim. One thing to note that is not normally a part of the conversation is that we normally say training, and whenever we say training, we always think of the training enterprise as the FAA Academy, along with everything that goes with that training. One thing to note is that the FAA Academy actually isn't a part of the ATO. It's aligned under one of the FAA staff offices, which is the Office of Finance and Management. And so they align under the MMAC, the Mike Monroney Aeronautical Center, and they answer through the AFN chain. So that doesn't mean that we don't necessarily collaborate. In fact, we are collaborating closer now than we ever have before, but it does mean that they're considered our execution, the ATO's execution arm, where they're actually taking the training, executing it as best they can, and delivering the classroom knowledge and skills, including some of the enhanced hands-on training and demonstrations of performance that lead you directly to certification. So with that relationship in mind, just think about all the training that you've had over your career, how much time you've spent at the Academy. It's probably no secret that you had no idea that an organization like AJI existed. So that really kind of opens the question to what is our purpose in the organization? How do we add value? So if you'll advance the slide, please. Two of the biggest ways that we add value to the organization and that we're trying to make sure that your training is comprehensive and that it's covering the actual performance that you need to do on a day-to-day basis is by having oversight over the orders that support training. The two that you see in front of you right now are FAA Orders 3000.22b and FAA Order 3000.57a. Both of these orders fall under the purview of technical operations training, and the first one being the 3000.22 actually falls to both air traffic and tech ops. So in terms of hierarchy, what does this mean? Well, Order 3000.22 outlines the instructional design guidelines. So if you're going to design a course, you would want to design it in such a way that it meets both the rigor of, does it meet all the engineering requirements? Does it teach any periodic maintenance activities that are required? Does it prepare you for certification and ultimately doing your job? Well, all of that is covered in Order 3000.22b in terms of instructional design. Things like course design guides, outcomes, blueprints to tests to make sure that the tests are linked to objectives, and that the objectives are tied directly to your job, tasks, and skills that you're required to do every day. All of those are outlined in the 3000.22. That applies broadly to both air traffic and tech ops. And under tech ops, we have an order that's specific to our training and to the things that you guys do on a day-to-day basis. Most of the people that deal with this order are your program support specialists and your training program management officers, TPMOs. They're primarily the ones that are familiar with this order out in the field, but it applies broadly and it's available for anyone to read. The 3000.57a is an air traffic, it's labeled Air Traffic Organization, Technical Operations Training, and Personnel Certification. And largely that second portion there is what you end up dealing with on a day-to-day basis, trying to make sure that you're qualified and ready and able to work on equipment. So underneath the 3000.57a, we outline things like what are successful outcomes in a course, what does it take to pass a course, what are the qualifications for an instructor, how do you create training and where does that live once it's created, what are the roles and responsibilities. And we actually do outline roles and responsibilities for the Academy as well as for our service unit and how we interact with AJW in the organizational flow. Kind of the third leg of this stool, if we were talking about that, would be AJM, or the Program Management Organization, because as you're aware, whenever we do new implementations, we also have to implement training as a part of that. And the acquisition management process actually accounts for training as one of the deliverables within that. So we work exclusively with AJW as a stakeholder and a partner. We work with the Program Management Organization, and we work with the Academy in order to create, maintain, and deliver training on a regular basis. Slide, please. So whenever we're developing training, one of the questions that I would be asking sitting in your seat as an ATSS is really, how does this matter to me? And why does it take so long? How do I get issues that are involved in training elevated? Those are all reasonable questions that I think it makes sense. And I think that it's a really good opportunity to talk specifically to those concerns. We have a process that we've been developing over the last couple of years that formerly was a paper process, and it was kind of clouded in mystery simply because we were operating in the Stone Ages. And we only had a certain avenue to get training identified whenever it needed updating, or it had problems, or there was significant changes to the equipment that were coming down the road. That was done via paper, and it was communicated verbally and by email. And what we experienced was that there was a lot of opportunity for failure. There was a lot of opportunity for progress to be hampered simply by paperwork being misplaced, or not involving the right people because you didn't know to, or because the paperwork didn't route correctly. So over the last few years, we've been working really hard to communicate our needs and turn that into an automated process that everyone in the ATO has access to. That's what you see on the screen in front of you. You see the technical training request is actually a KSN that has permissions for anybody in the ATO, and it has a process aligned with it where a requester can submit a technical training request through AJI2, which is my organization technical training. It can be then evaluated, which I will assign that work through my team managers to a requirements lead. And a requirements lead is actually a senior 2101, a J-band 2101 that has field experience and sometimes academy experience as an instructor. And they're going to look at that request that's come in, and they're going to say, does it have instructional need? Is there an engineering component to it? They're going to reach out to in-service management. And there's a real stakeholder engagement piece with the submitter, the academy, all the pieces involved. As that request is reviewed, once we get all of the relevant information, we're going to turn out some documents, such as a requirements document that says this is not only a valid requirement, but here's the outcome that needs to happen. And so that's reviewed and approved. And if it's approved, then it goes all the way through the process of becoming a training development activity, or a training revision activity, or some other version of training activity. Sometimes, like I mentioned, that's in coordination with the program management office. Sometimes that's an independent activity that AJI oversees and uses independent contractors to work on and then deliver that training to the academy. And then sometimes we work with all sorts of stakeholders, including the academy, to update training. So there's a million different ways that this can happen, but it all starts with a TTR, a technical training request. We will be providing these slides to you, and these links should be active for you to actually access the TTR if you're ever curious of it. One thing that I really want to point out here is that we've created a dashboard so that if you submit a technical training request at any point, you can actually go see who's it stuck with, where is it stopped? Is this awaiting some sort of team manager approval, and who is that team manager? Can I reach out to them? And that goes all the way up to our director and beyond. So there's a lot of transparency that we're seeking. I wouldn't say that we've done it all correctly, but we're trying to get there. And I just wanted to make you all aware that the TTR process exists. So after a training request has been submitted, there is a process for development if we've decided that this is something that we need to do for national training. And this applies to surveillance as well as any other discipline. So if you give the slide, please. The training development process is normally something it's complicated, and it's shrouded in a little bit of mystery still, even though we're seeking transparency. And I think at the ATSS level, at the worker level, when you're out there in the field, probably the only questions you're asking is, why does it take so long to get training reviewed, and why is it not up to date on a regular basis? Well, part of that involves the process and the reason the process exists. And that is to make sure that if there was an incident out in the field, and we were to trace, how did this happen? Was there equipment malfunction? How were people trained? All of that has to be traced directly back to how was this training designed, and did it take all the correct factors into account? That's why we go through this process that you see outlined below. You can see in phase 1, that's where the TTR lives, that technical training request, where we're going to take in that request and actually evaluate it. Phase 2 is where we do the requirements gathering, which involves stakeholder engagement. The one piece I haven't mentioned yet is the engagement with our bargaining unit partners, with PASS. We also engage with the union at the academy, PACE, and various other unions that are involved. On the air traffic side, they engage with NATCA and other unions as well. So as we build the stakeholder group, we're collecting all of their concerns, we're collecting the technical requirements, we're working very closely with the program management organization if this is an acquisition or an implementation effort. And then we're working through, what does it take? What are the requirements? Phase 3, you see acquisition strategy, and that may seem a little strange, but in many cases, the correct people to develop the training may be the actual manufacturer of the equipment itself. And that's true in many cases whenever we work with program management organization. In other cases, we'll work with some of our prime vendors like Leidos or SAIC in order to do some of the instructional design development stuff. And this is things like simulations, which we're leaning into at this point. These are enhanced graphics, things that we don't normally keep up with as a federal workforce into the latest technology, the latest methods of doing that. What we tend to specialize in on the federal workforce is instructional design methodology, the requirements and technical specifications of the equipment, and the end outcome that we're looking for based off of the orders and the periodic maintenance that has to be done. That leads us into execution. Execution is where we're going to facilitate project meetings, project kickoffs. We're going to get stakeholders involved, and then we're going to actually do the development of the course itself. And this is where the tedious, laborious process comes in of actually doing content review, of looking at the orders, creating lab procedures, and making sure that the equipment at the academy is sufficient, or if we're doing it in the field, that we are aligning the actual procedures so that they can be safely performed in an operational environment. So there's a lot to phase 4, which is that execution. Phase 5 gets us into validation, and of course this part takes a while as well, but this is where we actually make sure that the training design met the intention and that the execution of the training actually delivered the knowledge, and we can confirm all of that all the way through. Now, where you engage as an ATSS is a really important factor, both as a participant in some of the first course offerings, also as subject matter experts. And you may see some of those solicitations come out to say, we're looking for ATSSs with experience at this level to participate in a course development. And frankly, the better input that we have from an ATSS with experience or from a T-staff member with experience on these course developments, typically the better the outcome is and the quality of the training. Also, we're pushing the boundaries with this development process and trying to do it faster, collapse some of these timelines, and look into ways to do simulation and virtual training. Slide, please. Whenever we look at the actual portfolio for surveillance, right now we have about 25 active projects. I'm not going to list every single one of those active projects because we could kind of go down a rabbit hole with where the status of each of them is. But I will say that we have everything from new developments, course revisions, OJT, and performance evaluations. That's another thing that my organization is required and responsible for creating. Virtualization efforts, and I'll talk more about that here in a second, as well as bypass exams and any sort of training video. That's where you see a lot of collaboration with AJW. We've talked a little bit about our collaboration with Don Taylor, and we're working towards incorporating more video efforts into training overall. Slide, please. Last thing that you see there, and not really last, but I mentioned this a second ago, is virtual training. So you've probably heard a little bit about this. We've been pushing it out there and waiting on some coordination with our bargaining unit partners with PASS. But we've recently gotten that concurrence to move forward and to actually try to deliver some training courses that are traditionally taught at the academy and do that in a different way. It doesn't all come in one form or fashion though. It doesn't, not a one size fits all. What you see in front of you is actually a combination of modalities. And what I mean by modalities is just the method that it's delivered. What we recognize is that you can have things like synchronous instructor-led training. That's your traditional instructor-led ILT. You can also have synchronous web-delivered training. And the only real example that we have like that in the NAS right now is with Unix and networking. But that is through Blackboard, and it is instructor-led. And there's opportunities for us to improve on that and start expounding. We also have asynchronous, which just means self-paced, and that's web-delivered training that can be done on your own, and that could be through Blackboard or some other portal that goes through ELMS. And in combinations, what you see is you can replace a traditional lecture and lab that's instructor-led with some combination of Zoom followed by hands-on at the academy, or Zoom all the way through where you get to see labs demonstrated to you. Or it could be a video that captures the lecture followed by a hands-on lab at the academy, or some combination of any of those. Slide, please. Working with AJW and AMA, one of the things that we pushed really hard for a couple of months ago was to identify courses that we thought could be transitioned quickly to virtual. And we came up with actually, it's a little over 60 courses. What these are courses that we believe that some part of them can be transitioned to virtual, or in some cases, the entire course can be transitioned to virtual. You see on this kind of the spaghetti looking chart down here, it's actually called a Sankey chart, that we believe that within this immediate period of 0 to 3 months, and we're coming up on that 3 months here in the next month or so, that we can get out about 17 courses. You can see it's 25 courses if you consider the courses that are actually in resident at the Academy now. And those go into various combinations of either instructor-led at the Academy, or video followed by Zoom, or video followed by instructor-led. Then we also have courses that fall into that 3 to 6 month time frame that we believe we can transition over into virtual, or even 6 to 9 months. We have some courses that may require some course revision and validation, which that takes a little bit longer, but ultimately we believe that we can transition something like the theory into a distance learning via Zoom, where an instructor is presenting to the students, and then you still come to the Academy for your hands-on training that will get you to certification. And that is really the big bulk of it. You see at the bottom, those are the majority of the courses. But we are ready and have approval now to move forward with virtual training. And we have some courses that will be coming out almost in the next couple of weeks, where we're going to try to enroll and get people trained using Zoom, where the instructors at the Academy will be presenting material, at least at the theory of operations level, and in some cases demonstrating labs. Slide, please. Ultimately, what we're hoping for is there's about 110 courses that are presented to TechOps, to the TechOps workforce at any given year. 110 unique courses offered at the Academy. Well, right now in COVID situation, that's not happening. We're offering much, much less than that. And so we're hoping to ramp up the diversity of courses that can be offered by saying, let's offer some classes in resident, let's offer some classes virtually, let's offer other classes by out of agency training, such as chillers, fire suppression system, battery training is on the horizon. And then eventually we're looking towards engine generators, things that are not unique to the FAA. Maybe we can send you to a vendor to do that sort of training. And then also field conducted training. We're working with AJW to identify field conducted training sites. We're doing ILS right now, Mark 20, Mark 1, and we hope to expand that to other systems. And it was mentioned yesterday that there's a possibility of using things like Tier 3 facilities to do surveillance training. That's something we're very interested in and we'd love to expound on. It just takes time and energy, which we're willing to put into it. Slide. So when you look at surveillance training that's currently available as instructor-led training, this is just an abbreviated list. There's several more on here if you were to actually expand out and to include things like weather, ITWIS, WSP. But in just the strictly surveillance community, these are all instructor-led courses that represent hundreds and hundreds of hours of instructor-led training. The more that we can transition these over to virtual, even for theory of operations, or provide some online training either through ELMS that we can show you the equipment itself before you come and do hands-on, that's something that we could actually transition into recurrent training later on and refresher training, which I know something that Jeff Planey is very, very, very excited about. It's something that we're passionate about, and it's something that AOV, as an organization charged with looking over the safety of the NAS, is also mandating. They want us to have a recurrent refresher training because that's what orders tell us we're supposed to have. So with any of these courses, anywhere that we can switch it to virtual, our goal is to capture that digitally and then be able to represent that to you as an ATSS throughout your career on a more recurrent basis as refresher training or recurrent training as required. Slide. And if you'll take down the slide presentation, that's really the presentation. I know that I went through my 20 minutes pretty quickly here, but that's because technical operations training is complicated. There's a lot to it. We have, like I said, 110 unique courses that are presented at the FAA Academy every year. And that doesn't take into account all of the OJT packages, the performance evaluation, examination packages that are out there. It doesn't take into account all of the different briefings that are conducted either by the program management organization or done out in the field. And all of those fall under our purview as technical operations, technical training. So there's a lot to it. There's way more than I can present in 20 minutes, but I will be happy to entertain your questions. And I'm really glad to be able to introduce my organization to you if you've never heard of it, and offer my contact if you ever have questions or you'd like to know more. I'll turn it back over to you, Noel.
Thank you so much for that, Micah. Turn it over to Jeff Bogan now.
Well, good afternoon, everyone. This is Jeff Bogan again from our WSA OESG team. So I want to continue with the presentation today with some of the technical services surveillance training classes and other agency training resources that are available today for you to participate in. Again, Micah gave a great presentation on Oak City and where they're going with classes and the virtualization of those classes, and it is extensive. And you can see it's quite difficult to put together a class and then to virtualize it. There are a lot of challenges there. And so to augment that, and something we've been doing for many years is some surveillance training that we do in OESG. Next slide, please. So in this segment, I'd like to cover our WSA radar data analysis class. We call that RDAS, and we're going to look at some of the technical surveillance videos that are available on TechNet. We'll also look at the National Radar Service Improvement Seminars that are going on. And in addition to some of those offerings, I would also like to briefly go over how you can request some customized core NAS principal classes, some CMPC classes from TS CMPC cadre teams. Those teams are now developing some really nice training, and I'm going to tell you a little bit more about that later. So first, I'm really excited to tell you about this year's RDAS class. This is an in-depth overview of radar analysis tools that we use regularly here in the FAA. So we're going to really dig into the radar toolbox that's presented by our NASI team, the RS4 tool, the WinPlot tool, and RBAT tools. And those are all presented by the OESG engineering staff. One of the challenges during COVID is that this will all be done virtually. But on the good side, we can have a really big meeting. We never could do that before. Usually those meetings are really small, hands-on training, 20 people at a time, takes a lot of time to develop. But this means that we can roll this whole thing out to all of you that want it. So we can do it for 100 people. Now, it's not the same thing. Radar analysis is artwork. It is, it's quite complicated in some aspects, and you do need a lot of training and experience to be really good at it and need to use all the tools together. But this will give you a great overview, this class that the OESG teams are putting together. So look for an invitation coming out in December about how all of you can get this training. So just for taste, I want to show you a couple slides of some of the tools, just kind of show you what kind of things we're going to be looking at. So next slide, please. All right, on this slide, this is the WinPlot tool. This is really the bread and butter tool that almost everybody in radar analysis uses a lot to get answers. I mean, if you look at this, just this picture, it shows you a lot all on one screen. WinPlot has been developed over almost 20 years. And so things that were asked for by the field, people that really dig into radar analysis said, put this in, give me that. Well, they did. And WinPlot tool has hundreds of options. And what you're looking at on that tool in the top right, Parrot stability, CPME stability. You have multiple display capabilities on this tool. You can see radar reinforced targets, primary targets, beacon only targets, multiple site sensor setups, range and azimuth, height, altitude information. You get all this together in one tool with a highly integrated Google Earth connection so that you can lay this all into Google Earth and really show a great presentation. Use it for AT presentations when you need to show it to one level of audience and having a really detailed analysis in another. So that's one of the tools we'll be going into great detail on. Next slide, please. Then we have the RS4 tool. Here's another tool developed by the 84th Raids. They have a core team of, at one time, almost 10 engineers and specialists working on radar analysis tools. It's all in a nice Windows development environment. And again, it has hundreds of options. What you see is you can collect a lot of data, huge amounts of data, and look at statistics and averages by day, by week, by year. And you can record all that data in very sophisticated ways. Takes a lot of training to use this tool properly, but when used properly with this tool and other tools, it's a very powerful tool to look at some very specific information on target analysis, false targets, and and coverage issues, where you want to look at coverage issues in depth, in analysis in particular places, this tool does all of that. Next slide, please. The radar toolbox is something developed by our contractor, and then our second level teams have now picked this up. It's specific to the ASR 11. This tool not only is a display tool for ASR 11 data, but also lets you dig into the radar processing components as you roll through and do clutter processing at different places. You can look at the way the filter files are set up in the clutter processing for Doppler filtering. And analyze how pulse compression is working at different stages in the processing chain. Very powerful tool. It's the only tool of its kind that lets you do this, and you really need to know this if you're going to be trying to optimize an ASR 11 or even looking at ASR 11 data in detail. So Radar Toolbox is one of those tools. And again, we don't use one tool, but we use multiple tools together to get the kind of answers you need in RDAS. And so this RDAS class will cover all of that. We're really looking forward to putting this out later in the year. So look for the announcement for that. It will go out to all of you, and I hope you sign up. Next slide, please. In this slide, I just did a pull from the TechNet video library. We talked a lot about what's in the library. The library has lots and lots of videos. You get access to it through TechNet. It's a drop-down list. You can see TVL, Technical Video Library, and you can filter on the different videos in the different disciplines. And so, for instance, I pulled up surveillance. Now, there's only, that I was able to find, there are only 7 videos that are available specific to surveillance. Most of those are on the ASD3, replacing the pedestal motor, some more ASD3 information on the shaft, the slip rings, the hubs in the slip rings, and on some periodic maintenance on the ASR3. And there's some stuff that Don referred to, the ASR gearbox problems, and some preventative maintenance issues on the ASR11. So they're really good videos, and go and take a look. It's like being right there. So they're very powerful and very good. Hopefully we can get more of those. You can see COVID is driving us towards providing more video resources, and I'm sure that the technical teams are trying to put that together. I know Oak City's putting it together, and then you as a specialist, you can ask for that information through the process that Micah described, and we can get some of those videos more in depth onto the TechNet video library, so we can have a broader surveillance selection there. Certainly COVID's delayed our TechOps in-person training throughout the whole organization. And one big impact has been the delay of our technical service radar service improvement meetings, and we call those SIMs. Those SIMs are actually a follow-on to this. They cover all stuff, but in much more detail over all the disciplines. So you'll get second level reviews, in-depth reviews of the Common Digitizer and what it's really doing. So we hope to put those on again next year as soon as we can, but we can't do big meetings yet. But we're looking forward to doing some of that soon as we can find a way to get out to you. They go into some, and so in those SIMs, we typically cover challenges that we have in radar tracking, adaptation issues on all the automation systems, as well as bring in the STARS folks, the ERAM folks, to talk about how all the surveillance data is pulled together and how to adapt that into the systems and what the challenges are there. So generally we have SMEs on from our PMO, second level, NASA engineering, the AML teams, the OESG engineers, they're all doing presentations on the SIM. So TS hopes to pull these radar SIMs back into our schedule summer of 2021, hopefully. So please look for the invite for this on this program. And again, it will be a follow-up to this symposium where you really get into depth on some of these things. I don't have a specific slide on this, but the last thing I'd like to share with the team is about how your SSC can ask for specialized training, not just the surveillance logging issues we discussed today, but on any logging issue you may have been challenges with. TS has been busy working really hard to get more TPR and FRD training out to all of you. And I'm really excited to announce that in the first quarter of 2021, we're going to be rolling out individual district-wide virtual presentations on eTPRs and eFRDF training. So look for that coming. And in addition, specific to your SSC, some very short, very concise, and condensed CMPC modules specifically tailored to meet the needs in the field, those are going to be available. So where you see you have a problem and logging, or if it's a certification issue, the NASTEP teams are all going to be putting together very specialized training to cover any of those aspects. And we'll do it right after the NASTEP eval. We'll do it immediately after the outbrief, if that's the way you'd like it, or we could put together a specialized class in any way you'd like. We have folks that are really trying to do that, or we'll do it virtually. So they're short, they're concise, and they're designed to explicitly home in on just what logging or certification procedures, practices you're having trouble with. And these can be delivered, again, right after a NASTEP evaluation. That's kind of cool. So when you have a problem, the specialists that are having a problem, that particular one, we can speak directly to them. And we're hoping that that really makes a difference. That will allow us to get maximum benefit from the NASTEP eval, and then for the CMPC training that will come after that where you have problems. So to get this help, just connect up with your service area, NASTEP, TSOG, or the OESG managers, and we'll help put that together for you. Really, that's all I have to talk about today. So thanks very much for the opportunity to speak to you today about the surveillance community and how big a role you play in all of that in keeping our NAS really safe. So radar love out to all of you. And now back to our moderator, Noel.
Thank you, Jeff. Micah, if you could turn your camera back on and unmute. Jeff, don't go away either. We got a couple of questions here. The first question is, Micah, I think it's for you. What about asynchronous video text instruction assisted by a tutor that is assigned, selected from within the SSC? I have helped tutor several of my colleagues and it has turned out well. This could become an incentivized process, maybe?
Well, that's a great point. I think that's kind of been a traditional thing is you have somebody at your SSC that's good at math or that understands one of the systems really well. And I think that's always been a good method, is to help tutor. As far as institutionalizing it, it becomes a little bit bigger of a challenge. Like you mentioned, incentivizing it. Typically when we put people on details to do instruction, for instance, that involves negotiations with PAS and also grade changes, temporary promotions, things like that. But that doesn't mean it's impossible. We could absolutely tackle things like that if it's going to help us get through the backlog of training that's created right now. One interesting point that I will say is that we've actually started exploring this from a vendor perspective, and we actually have a tutor company, tutor.com, is on board on an FAA contract, and they're providing math tutoring to some of our new hire technicians as they're going through basic electronics and their initial mathematics course. We hope to expand that to other courses just because it relieves the burden on instructors at the academy, and it provides a 24/7 resource to the field. But right now, those are the two courses that it applies to. And if you have more questions on that, or if you have new hire technicians that are enrolled in that, please know that's a resource for you. We're paying for it, and it's turned out we've gotten great feedback on their ability to provide that on-demand math tutoring.
All right, thank you for that answer, Micah. And Timothy, thank you to you for taking the initiative to help out your fellow ATSSs in there. Thank you. Please keep up that good work. Next question comes from Jim Stone. Will the virtual courses be available as non-credit or audit?
So the question about credit, these courses virtually will be for credit. There won't be any auditing of the courses, not at least to start with. And here's the reason why. To start with, we're actually limiting the size of the virtual courses to whatever their restriction was in resident. And the only reason is because we have a lot of unknowns. We don't know exactly how much extra time it's going to take for the instructor to engage with individuals who are having problems or to explain things in a different way to a broader audience. So the last thing we wanted to do was to create a circumstance where we moved too quickly. We wanted to take more of a crawl, walk, run approach. And so the first virtual offerings will be limited. So if it was an 8-person class before COVID, it's an 8-person class virtually. Even though at the academy, if we're offering it during this COVID pandemic, it might be 4 people. So it's still an improvement over our COVID numbers in resident, but we're not to the point of expanding it all the way out to say, we could do 50 people, 50 or 2, it doesn't matter. We expect to start expanding those numbers eventually as we get some best practices and we see how it works. But to start with, again, it's that crawl, walk, run mentality, and we're in crawl phase right now.
All right, thank you, Micah. Next question comes from Albert Hang. Does radar analysis RDAS include the ADSB SBS training?
So not specifically. So you certainly can see ADSB targets and target data. We can look at the asterisk data associated with ADSB targets. We can look at that in depth. But specifically beyond seeing target information, there's nothing, no specific ADSB training beyond that. I simply look at that as an additional sensor to analyze. You can look at it in fused mode. You can look at different ways of looking at it as the stars. We can look at stars playbacks on there and see how it's together. So you do get quite a bit of information about ADSB targets and what it was inside an ADSB target format and how it's presented and how it's fused. But beyond that, there's not much. I don't have specific training in our RDAS class on that.
Great. Thank you. And I think the next question is also for you, Jeff. It's what is the latest version of WinPlot and who is updating it now and in the future?
Actually, I don't know the latest version of WinPlot. It is now, I believe, pretty much handled by one or two people in the FAA at second level. And so I think we have the code. Not many changes are being made to it. It was taken care of by a gentleman named Steve Smith, who really did a huge amount of work over the last 15, 20 years on this. And right now, the second level teams have taken that over.
All righty, thank you. The next question comes to us from Mike Garza. We have some engineering folks that are close to retiring and we're losing all the knowledge. Why not have an apprentice program to shadow them for a couple of years just to absorb all that knowledge?
That's an interesting question. I know that there's some there's movement on the forefront, and I don't want to speak for AJW, but I know that there's movement on the forefront about staffing and the way that we're doing training and the coordination that we're doing in that front. From a technical training perspective, we're working to create that recurrent and refresher training, but how that would be applied to an apprentice model, I'll have to turn that back over to you guys to talk about that.
I guess this, Steve Schmidt touched on this a little bit earlier when we were talking about all of the different ways for us to transfer knowledge, and so that's something for us to consider. Next question is from Philip Sandoval. What will happen with EHOT and DOP certification?
That's a great question. So enhanced hands-on training and demonstration of performance is EHOT and DOP. There's a number of courses right now that have that model. The intention behind that, whenever it was created, was to relieve the SSCs and the districts from the burden of trying to have local people to do the OJT and then different trainers to do the performance exams. And so the idea was that you would do a kind of a combination of some of your OJT and some of your PE in the EHOT DOP process, and you would come out of that training from the academy with the ability to certify. There's been a movement and a leadership desire to go away from that, and so we're actively pursuing sunsetting all of our EHOT DOP courses where it makes sense. There's a couple of them where the course is actually very efficient, and if you were to remove EHOT DOP from the academy, you would only save like a day, but you would institute something like 4 or 5 days of extra training back home. So there may not be a one-to-one comparison where we eliminate it and it just saves a whole bunch of time. But for the vast majority of them, it absolutely will save a lot of time at the academy, but it puts the burden back on the district and the SSC to do the OJT and the performance exam and to have the people to do that. What we've been told repeatedly on technical training side is that AJW has that desire And so they have asked us repeatedly if we can move away from EHOT DOP. So you will see over the next year to 2 years that those courses will start migrating from EHOT DOP to be normal theory of operation at the academy, followed by your OJT and PE out in the field.
Thank you, Micah. Next question is from Mark Hollenhead. Is there a resource for training familiarization with the new Field Fox used on the MODES?
There actually is a video that was done on the Field Fox that was done in collaboration with Don Taylor and that group. I could have some specifics, but I'd have to take a rain check on that, or at least put that as something I can deliver later on in either the notes to this, or I can connect you with actually our surveillance requirements lead, his name is Robert Collins, and he would be happy to answer that question and point you directly towards it if you don't have that resource already.
All right, the next question comes from Mike Goodrich. He says he sees a lot of academy classes that teach NAS equipment, but he doesn't see any engineering type courses within the FAA.
I love this question because I think this is our biggest area of opportunity where, as an organization, as an agency, that we've done a disservice to the engineers. Kind of hire engineers straight off the street, and then there's a lot of homegrown training. There's some industry training where different service areas are sending people to different courses based off of industry best practices. But as a national training apparatus, we have not done anything to facilitate that until recently. We've been working with AJW2. Austin Arant was the executive sponsor, and we've got our folks working directly with them to create an engineering curriculum and training path for an engineer from new hire into being a seasoned engineer. There's a lot to that. It's a lot of new development that's going to have to happen, but we're pretty excited about it. It's in the initial stages of presenting it to leadership. It has been presented to AJW leadership and AGI leadership, and everybody is pumped about it. But it's going to take time and resources, and that's what we're working on right now. The intention, though, is to kind of create the premier path that an engineer coming to the FAA will be able to look and say, I know for the next 3 to 5 years exactly what I'm going to have to do to become competent in my area of expertise and able to do my job safely and to add value to the NAS. And I think that as we develop this, it's going to be a model that trickles over to the TechOps ATSS side of the house too, and we're going to see improvements on both sides. So more to come on that, but I'm extremely excited about that.
All right, thank you, Micah. The last thing that we have here is actually, James Hall is submitting a link which has video tutorials for using WinPlot to troubleshoot various problems. So we'll provide that link to everyone with respect to all the artifacts associated with the Surveillance Symposium after this. It's time for a break. So we will break right now for 10 minutes. And when we come back, we'll have Dan Hickok with the future of surveillance. 10-minute break. Good afternoon and good morning, depending on where you are. Welcome back to the Surveillance Symposium. Just as a reminder, please submit questions in Q&A. At 3 o'clock, we will have we'll bring back all of our panelists for a Q&A and try to answer as many of the questions that have gone unanswered through the last 2 days. In addition, Jeff McCoy will be joining us at 3 p.m. If there are any specific questions you would like to ask Jeff, please submit them in Q&A. So with that, let's get back to it, and I'll turn it over to Dan Hickok with the future of surveillance. Over to you, Dan.
Yes, good afternoon to everybody. Good morning. First of all, thank you to Tech Ops for putting on such a great venue. How's the sound? Is sound coming through okay, Noel? Quick sound check.
Loud and clear, sir.
Excellent, thank you. Thanks to Tech Ops for putting on such a great venue, and thanks for including some folks from the PMO to give their perspective. I'm definitely inspired to do something similar for PMO employees. I think this is an excellent way to get everyone together who are surveillance professionals. So a quick word about my role. I'm the Director of Surveillance Services in the Program Management Organization. And in the PMO, that's a service unit that is dedicated to the acquisition of air traffic control systems. And specifically, we have 3 different directorates, and we divide up the systems accordingly. So we have a directorate dedicated to automation and decision support. We have a directorate dedicated to enterprise services, which are comm, nav, and weather systems. And in AJM4, which is what it's referred to as, we have all of the surveillance system acquisition. So basically my role as director is I'm responsible for all of the successful acquisition of all surveillance systems on behalf of the FAA. So that's a tremendous responsibility and a great job. It's the best job I've had in the FAA and something I really enjoy doing. And it is something we do entirely in partnership with Tech Ops. So surveillance as a function and a service to the FAA is something that we do highly collaboratively with many stakeholders, and principally with Tech Ops as our primary partner in the delivery of surveillance services. So in the Surveillance Directorate, we have programs such as radar acquisitions as we replace radar systems. We have tech refreshes for older systems. We have the SBS Program Office, which is responsible for deployment of ADSB, and also surface surveillance, so ASDX, ASSC, runway status lights. We also have ACAS-X, which is the future of collision avoidance, the advanced version of TCAS, basically. And we also have the new sensor program, which is still in the exploratory phase, but is intended to replace our long-range radar systems. So all those programs are in that directorate. I'll say also that, that surveillance is something I've been involved with for my whole career. My very first assignment after graduating from college was in some R&D programs associated with surveillance, and for the most part, I've been with it ever since. It's a fascinating area. It's something I really fell in love with early on in my career and have stuck with. I think it's my very favorite place to work, and it's very gratifying to do the work of surveillance acquisition. In a lot of parts of my career, I've been envious of the Tech Ops work that you guys get to do directly on operational systems and directly as support of the operation. But in the acquisition world, where I'm mostly involved, we get to do some pretty cool stuff too. And one of those things is figuring out where we want surveillance to be in, say, 15 years. What does surveillance look like in the future? And given that target, what are the key programs and the programmatic milestones and plans that we need to put together to get there, right? Because if we want to be somewhere in 15 years in acquisitions, we better be working on it now, because that's just how long it takes, particularly for radar systems. These are long acquisition cycles, and we really need to be planning long in advance if we want to hit a target in the future. And that work that we do to figure out the future of surveillance is done with other stakeholders. It's not a PMO activity. It's actually an FAA activity that we work on with Tech Ops, with air traffic, with mission support, with NextGen, with our labor partners like NATCA and PASS. And we work together to figure out this vision and the programmatic plans that really will get us there to that future. So it's really fun. It's very interesting work. And that's what this presentation is all about, is just kind of a glimpse of that work, of what are the key programmatic areas that we're involved with now to deliver surveillance of the future. So with that, could you flip the slide, please, to the first slide? Okay, so we can't really talk about the future of surveillance without giving a quick snapshot as to where we are today. And when you think about surveillance and what's come from over, say, the last 15 years, there's been significant change in how we deliver surveillance services. So one of those differences is that ADS-B is now, in this 2020 year, fully deployed throughout the NAS. We have service volumes throughout the United States. We have ADS-B fully integrated into all of our automation systems. And we have a very high level of equipage. Most aircraft in the United States are ADS-B equipped, and all those that operate in what we call ADS-B rural airspace are required to be operating ADS-B equipment. We also have all of the 750, which is really quite an amazing number when you think about 750 ground-based radar systems that continue to play a key role, a vital role in the current and future of surveillance. Just because we have ADS-B doesn't mean we're getting rid of all of our radar systems. These continue to play a vital role in the future, currently and in the future, for things like SSRs, beacon interrogators, continue to be a key backup to ADS-B, and non-cooperative surveillance like ASRs and ARSRs provide a service that only they can provide, such as precipitation data, coverage of non-equipped, coverage for failed transponder aircraft, and so on. So these radar systems continue to provide a vital role and will do so into the foreseeable future. We also have some new technologies, newer technologies, not really new, but newer technologies such as wide area multilateration that I kind of see as a utility player. So when we have a special problem that wide area multilat can solve, we utilize wide area multilateration sometimes to solve those problems, such as at the mountain airports in Colorado or Juneau, Alaska, Charlotte and LAX. And we've got a couple more coming online in the next few years that provide a nice complementary type of surveillance to ADS-B and provide another way of providing cooperative surveillance. And all this is brought together now. Instead of single sensor mode and automation, all this is brought together in a fusion mode so that all these surveillance sources are utilized. You know, every moment that you get a new update in, they all feed the track and provide high quality surveillance data to automation and directly to the controller. So that's a significant amount of change when you think about it. We no longer have single sensors feeding automation. We really have a vast network of surveillance systems that provide layered services. And so this really is a significant amount of change from where we have been, and really signals the place from which we'll continue to improve the way we provide surveillance services in the future. Next, please. So this is just a snapshot of everything in the surveillance world that we talk about when we think about FAA surveillance. So at the top there you have ADS-B, and it's not just ADS-B out, but you have ADS-B in as well and associated applications. And that's just the ability of an aircraft to receive ADS-B data from another aircraft directly and use that for applications. We also deliver flight information service and traffic information service directly to the cockpit, which is a great safety benefit to improve the safety of flight operations. We have still, like I mentioned, we have our long-range radars, MODAS, BI6, ARSA-4, and CARSAR. By the way, we use these terms cooperative and non-cooperative more often than we use the older terms primary and secondary, but I realize we all use those primary and secondary terms as well, and I will fall back on those on occasion as well, but we tend to move more towards the words cooperative and non-cooperative because they really, to me, more accurately describe the service that we're providing there. I think they make a little bit more sense in the current surveillance environment. We have our short-range radars, MODESs, BI6s, MSSRs, ASR 8s, 9s, and 11s, and our wide area multilateration systems. I mentioned surface surveillance. We have all of those systems out there, ASDX, ASSC, and runway status lights, providing critical safety information to pilots as well as air traffic controllers, making airports safer. And again, all this is fused at automation and providing those critical surveillance services to air traffic control. So next, please, a little bit about where we're headed and why this is a transitionary time. When we talk about surveillance acquisitions, a lot of times we're just sort of in that execution mode, we're delivering products. And then we occasionally go through these sort of transformative times, which is really what we're in right now. And this transformative time has been brought about really as we have shifted from a view where a previous way of thinking was that this new sensor program was going to replace all of our radar systems eventually. That's no longer the case. And so we really have shifted into what we consider a decision space where we're trying to decide on what are the surveillance systems of the future that are going to provide this key these key services. And so we are focused on, one, sustaining the systems that we have out there. So all those systems I just mentioned all have a sustainment element to that. And by sustainment, I'm talking about tech refresh programs to refresh those systems continually. So that continues to be an ongoing effort. We have some programs that are called tech refresh portfolios, which look at lots of different systems and apply improvements to them in the way that's most advantageous. We have the divestiture program, which is, we're going to talk about a little bit more after my talk here, which is all about getting the right level of surveillance, the right number of radar systems in this present environment. So I mentioned those 750 radars a minute ago. We don't need quite as many as we have, simply because we now have a new cooperative layer throughout the United States provided by ADSB. So we don't need as many radar systems as we currently have. So we're in this process of determining what that right number is and which systems really are excessively redundant in the current environment. And we now have some new acquisitions on the roadmap, some new programs like the MSBRS program, which is the replacement for the current MODES radars, and what's called ASR-R, ASR replacement program, which is just really kicking off and really won't get underway until next year, which is the planning for the replacements of the ASR 8s and potentially 9s and 11s as well. We don't know the scope yet, but that's really what this exercise is right now, is trying to figure out how many of those ASRs do we need to replace. We can't sustain ASR 8s, let's say, forever. So we continue to sustain them, but at some point you need to replace. And so we're in that analysis period right now. And all of this goes to really determining what those future systems are going to be. So next slide, please. What this does here is lays out all of the systems in our current inventory with an attempt to look at, to display, to depict where these systems are going to end up. So I'll walk through this slide, and I think this will answer a few questions that have come up through the seminar so far. So what you see here, if you look at the top left of the page, you see down the left side of the page, you see all of our current inventory of radar systems. We have green, long range, and the blue, short range, broken down into non-cooperative and cooperative. And what you see there, starting at the top there, is the ARSR-4 has 44 current systems. And as you walk over to the right side of the page there, you see the blue block that says sensor. So what that means is that under the current vision for our current program plans, The RSR4s are going to be replaced by the sensor program. And that's a program that's still in the feasibility study phase. And Ken Harris will be talking about that in a little more detail here in a few minutes. But our plan and our vision is that those RSR4s are going to be replaced by the sensor program. Similarly for the Carsers, we've got 79 of those currently. At least some of those we expect will be replaced by the sensor program. Moving down a little bit more, you got the ASR 8 there. We currently have 42 of those. As we go through the divestiture process, we expect a certain number of those. We're anticipating 6 of those will be divested. And then we have to figure out, okay, so there's still the need for those. How do we continue to maintain that function? And we have a decision point that we're still trying to figure out. As I mentioned before, this ASRR program is in really the study phase. We're either going to continue to sustain those ASR 8s or we're going to replace them with the ASRR program. And that's really what we're in the process of analyzing right now. Similarly for the ASR 9 and 11, current quantities affected by divestiture, and those will be replaced by ASR, or we continue to sustain them. And part of what goes into that decision is ASRs are expensive, and whether or not it's affordable or not to, or more affordable to continue to sustain, and for how long into the future we can continue to sustain them before we have to bite the bullet and do a major program, which potentially could cost billions of dollars. That's really the decision that we're in right now, figuring out how much is affordable and how much, how much longer we can continue to sustain these. And then moving down, you see similarly for MSSR, which is associated with the ASR 11, current quantity of 69, 60 after divestiture. We think those could be sustained. They could be replaced by this new MODES beacon replacement system program, or potentially we're also looking at wide area multilateration. So some of these systems, some of these terminal area cooperative needs could be met by wide area multilateration, as is being done, let's say, for example, in Los Angeles right now. So potentially some of those MSSRs, BI5s, MODESs could be replaced by wide area multilateration. So again, quantities there on the left, say for the MODES short range there, 113. Post divestiture, we expect still to have a need for 101. And then those will either be replaced by wide area multilateration or the MODES beacon replacement system. And this is really, it's like a big puzzle with a lot of different pieces, and we're really trying to optimize our ability to deliver these services with the right number of systems most efficiently. And that's a multivariable problem, and the environment keeps changing, so it's a fairly difficult problem to solve. But it's one that we are currently endeavoring to find the right optimal solution to. So I think that's about it on that one. Let me go to the next slide, please. And just want to talk a little bit about, when you see the whole slide here, these are all the different initiatives that we have going on in the Surveillance Services Directorate. These are all initiatives to really determine the optimum surveillance services of the future. And the ones that are highlighted there are the ones that probably are of most interest to this audience. So we have all of our surface surveillance systems continue to be maintained by a tech refresh portfolio. We're working on the radar divestiture program to determine the right number of radars and right inventory of radars of the future. We continue to sustain those existing radars that we need to sustain in the current moment through what's called a tech refresh portfolio for terminal and en route systems. And then we have these future acquisitions, the MODES beacon replacement system program to replace MODESs and potentially other beacon systems, and the ASR replacement program, which is still in the phase of determining how many and what technology is really best to solve the problem of providing non-cooperative surveillance service to the terminal area. And next, please. So just to wrap up, this this partnership that we have between PMO and Tech Ops is really an interesting one, where PMO really takes the lead role in the acquisition phase with Tech Ops in a support role. And then we swap that as we get into the in-service management for a particular system. Tech Ops takes on that lead role and we support. And it's really essential that we stay connected throughout the entire life cycle, because as we deploy systems and determine what systems we need to deploy and what the requirements are, it's essential that Tech Ops participates in that to determine, to make sure that we can maintain what we buy and that the expertise for doing so is built right into our workforce. Likewise, in the in-service management phase, when systems are in operation, we stay connected to make sure that when we do a tech refresh that we're buying exactly what needs to be purchased to best support the operation. So really the partnership is about ensuring surveillance acquisitions are optimally aligned to meet the needs of the operation. And we do this together through a number of initiatives. We really work to make sure that we retain the right skill set in the FAA on both sides of the service area wall there, both in Tech Ops and PMO. We work collaboratively in places like the surveillance leadership team that's been mentioned before. And our mutual commitment here is really, I know I approach surveillance thinking about it from a big picture, ultimate customer standpoint, not from a service unit standpoint. You know, I think about surveillance from the standpoint of providing the best service to the flying public. And we do that collaboratively with Tech Ops. And I know that Tech Ops shares that view as well, which is why it's such a great partnership and continues to get better. What I've seen over time as I've worked in this surveillance world, we've continued to get better in that partnership. And when I look around to the leadership positions, both in PMO and Tech Ops, I see people who are just as dedicated to, one, the functional area of the surveillance, as well as this need to pull our organizations together and provide the best possible service on behalf of the taxpayer and the flying public. So that's our view, and it's really something that I endeavor to do to make sure that we're continuing to keep that view in mind first and foremost. So hopefully you got a couple of good nuggets out of this future view of surveillance. What I'd like to do now is introduce Devlin Maxwell. So Devlin is our divestiture program lead, and he's a PMO employee, although most of his experience is in Tech Ops. He's a longtime Tech Ops employee, and Devlin and I go way back to the early parts of our career when we worked in surface surveillance together. Devlin recently came to us in the PMO to work on programs in the PMO, which has been a great addition. He brings that Tech Ops background as well as a long surveillance history, so we thought he'd be perfect for this. This really easy program area we call radar divestiture, right? It's really not very challenging, and really you could just sort of sleepwalk through it, right, Devlin?
That's right, Dan.
Take it away, Devlin.
No, thank you for that introduction, Dan. And again, my name is Devlin Maxwell. I'm running the radar divestiture program. And got to be honest with you, I was really excited when Dan gave me the opportunity to kind of run this program, because I do, coming from the Tech Ops side of the house, I recognize the challenges here, and none of us in the program think this is going to be an easy thing to do. I believe it's a doable thing to do, but we recognize it's not going to be trivial. There's a lot of work to do there. And I hope today, when I work through the process with you, we're only going to get 10 minutes today, 4 slides. I don't know if I'll answer all your questions, but I'm excited at the opportunity to be able to communicate. When I first came into the program, there was a lot of energy. There was a lot of maybe some misunderstandings, concern about radar divestiture. And so one of the first things Dan and I talked about was amping up our communication. And so again, I want to extend my thank you to Tech Ops for allowing us to be on here today, because we're excited to get the message out, and more importantly, the front lines. From what I've been told, we're going to be a lot of specialists on here today. So when they give us the opportunity to really kind of broadcast the program, especially to the front lines, the specialists out there, we were super excited to do that. And I'll offer up this. Well, we're going to go through about 10 minutes here. Like I said, we're going to give you an overview And also what I'm going to provide you is hopefully a little bit of a picture of what your involvement is going to look like. What we don't get through, feel free at any time, anybody can reach out to me directly, and we'd be more than happy to take the time, sit down with you and give you more depth here. So like Dan said, a couple of key messages you're going to hear today is radars aren't going away. They're going to continue to play a vital role in our strategy moving forward. What we're looking at is now that we've got some new technology out there, and I'll talk a little bit more about that, we have the opportunity here to right size that infrastructure moving forward. Also, a key thing you're going to hear today, I hope you hear this, is we can't do it without you. Without tech ops buy-in support, we're going to struggle. I just won't be successful without you. So in some ways, I'm going to try to sell you a little bit, maybe get you excited. That might be overreaching, but that's really the goal today. And you're going to hear me say the word candidate radars a lot today, because there's a list. We've got radars that we're looking to divest, but we consider those candidates. We recognize we got a lot of work to do. There's a lot of touch points to these radars. And so you're going to hear me use the word candidate. So with that said, next slide, please. So why are we divesting radars? As again, we're not divesting all radars. We're just divesting radars that we think are no longer needed for the mission. And I always love this picture. Dan, we've used this in a lot of presentations that we see there, but what you're looking at to the left there is there's no PowerPoint doctoring going on there. That's real coverage circles for radars in certain parts of our country. And this doesn't even include the ADS-B that we rolled out. And you can tell there in some areas of the country, as we built the NAS over years, that we get a lot of overlap. And so the difference, radar divestiture has been a discussion point for years. I was reading a document that we got today from 1996 where we were talking about divesting radars. So this is nothing new. The concept isn't new. The difference is, like Dan mentioned earlier, we've just invested and rolled out ADS-B. We've also invested and rolled out Fusion across the country. We've got WAM now as a potential solution in some markets across the country. And so that's the difference between 5-10 years ago and today. And now that technology is in place and it's been fully rolled out, the mandate went into effect on January 1st, 2020, requiring aircraft to be equipped with ADS-B in certain airspace across the country. Now that that's in place, our posture is a little different. And that's just, the program was built on that notion. And so we're looking in areas where you get a lot of overlap is where we're looking to remove radars, and essentially, taking out maybe a layer where we've got multiple layers there now in place. Again, we've been talking about it for years. Part of our investment decisions, strategy moving forward as we rolled out ADS-B and Fusion, was it would give us the opportunity to scale back, right size our infrastructure. As you all know, I know coming from tech ops and on the program, these are expensive systems. Radars aren't cheap to buy, sustain, maintain. They're costly. And so now that we're in a posture, we can remove avoid some cost on the F&E side and also on our ops costs. Another contributing factor of removing certain radars across the country is, of course, the 1030, 1090 megahertz, as a lot of you probably know, in some of our markets across the country, Atlanta's, the New York's, Chicago areas, there's concerns of congestion in those areas. Those frequency bands are heavily used. And so, of course, removing a radar would give us, it's not going to solve that entirely, but it will mitigate that to some extent. It will be less frequency activity going on in that 1030, 1090 megahertz. And again, you're going to see in the process is we're not going to be able to remove a radar if it's not safe, if it's going to impact services or affect the efficiency of air traffic today. So the number of aircraft we move, we certainly recognize the demand, and it's only going to grow to keep traffic moving across this country. So we're not going to do anything that's going to jeopardize that. And so that's kind of our guidance moving forward, or kind of our guiding principles is we're not going to jeopardize the air traffic mission today. Next slide, please. So this is the kind of the what and when. So what we're looking at today is 32 radars, and you saw on the list before, there's around 234 terminal radars we have across the country. What we're looking at is divesting 32, which again yields about 86% it's going to remain in operation. It's going to continue to play a role for providing surveillance services to air traffic moving forward. Again, these are only terminals. So we're really looking at the ASRs, ASR8s, the ASR9s, the ASR11s, and of course the cooperative piece that's co-located at those facilities is included as well. Beyond 2025, I'll tell you that I think Dan and us talked about this, radar divestiture and right sizing our infrastructure as we reshape our infrastructure moving forward with new technologies. I think radar, divestment, maybe not even radars, but technology systems is going to be certainly considered. I don't know what that's going to look like beyond 2026. There's a lot of things that can happen between now and then. So really the focus of this program today is between now and 2026 of divesting 32 radars is kind of what's in scope, what's been funded, and what we're moving forward with. You're going to find out also that the challenges of room radar. You don't show up. I keep telling people you don't show up on Monday, plug on Wednesday, and leave on Friday. There's a whole lot more to it than that, and you're going to see some of that in the process. Of course, safety first is the perspective that we'll be divesting in. And again, local SRM panels are going to be conducted. And so you and Tech Ops, you and your facilities, even the service areas, the way I envision it, the way we're marching forward is there'll be a local SRM panel assembled with the right people, all the stakeholders that have a vested interest in that radar locally. And I look at it as our job to provide that panel the data they need to make a good decision. And so the program is really built. In the end, I won't decide if we turn off the radar or not. That's my job, is really to kind of present that case to the stakeholders through a panel and let them judge that. That's kind of the way we've built the program. For more information, we have put together a website, and we're going to try to keep that updated as we go along. But you get the link there below. Next slide, please. So this is probably the most important slide in the deck. This is our process, and the reason, what I'm going to try to do here, my goal in this is to kind of give you a high level look at kind of the process, but I'm going to try to explain this the way how you're going to be involved with this and help us out. Again, we can't do this alone, but overall, the high level, the process looks a little bit like this. I mean, we've got a lot of data. Our team today, we spend a lot of our time looking at all of these radars that we're looking to divest and collecting data. We've got the ability, I think Jeff Bogan was presenting some radar data analysis tools that we have. Excuse me. Sorry about that. That was my timer, so I've got to get going faster than, that was my 10-minute timer. Anyway, so we're building tools. What we found out is we had a lot of tools that we developed that give us a really good look at coverage, where these radars are, how they're providing coverage across each facility. What we didn't really have was a tool that give us an idea or a look at how these radars contribute to the tracking. And so we've had to develop what we call a run runner tool that allows us to look at it from a Fuse product in Fusion, the automation level, how the radar is contributing to that. And so we have a lot of insight, and we can do a lot remotely without ever coming on site. And we felt upon us before we show up and have discussions that we need to come in, do our homework on your facility, get very knowledgeable about that. The validation and verification is a longer process to kind of go through it. And what we look at is, this is the opportunity for us to look at the radars that are it's going to remain in the service volume. There may be some optimization work required, maybe alignment, but we look at it from the surveillance volume perspective in general, where we have the radars, you have the automation, and what that's going to look like, controllers on the glass. And so this is going to be a pretty timely, it's going to take some time to go through this process. This is where you're going to be heavily involved. And I'll tell you, when we come out to your facilities, it's important to recognize that we're going to be in touch with you. COVID has kind of set us back, and we're kind of trying to figure out our schedule. But at some point when we begin the implementation process out there, we'll be reaching out to you and have a lot of conversation about how your involvement, what we need from you guys, what you're going to need from us. And the way we kind of see it is we'll build teams per site, and we'll have a lot of discussions, recurring like telcons, where we can go through and talk about what we're doing. And again, none of us on the team really, I mean, we realize that what you guys bring to the table that we just don't have is, first, you bring a lot of technical expertise. Like Dan said, I came from tech ops and certainly know and appreciate the work you guys do. And that knowledge is invaluable for us. We're going to require that to be successful here. You also have a lot more insight on your facility about things that we don't know and things you can help us figure out. And so, again, a lot of our messaging and our communications is about getting your buy-in and support, because we're going to need you to help us do this, to get this right. And again, SRM panels be conducted, and I expect a lot of folks in the tech ops community is going to be part of those panels. And so we're working toward that. Operational readiness and suitability is a big event for us. This is the point when we decide and we work it out with the facility that we went through the analysis, we've aligned the optimization or the radars, we've optimized the service volume, we've provided an adaptation to go into the fusion, and that we, at that point, start working with the facility about doing a look before buy. That's what the operational readiness and suitability looks like, is a way that we can remove that radar from the configuration when we all we agree that's the date to do so. And air traffic will use that radar for a period of time to see what it's going to look like without it contributing to the tracks on the glass. And then once they get comfortable with that is when we move toward the last phase there is service discontinuance and decommissioning. A couple of notes that I want to hit on before I go. I know I'm pushing up against time here, but so one thing that's important to realize here is it's not over till it's over. It's not done till it's done. So maintenance of your systems today, even though you may see your radar on the list, maintain that system just as you do today. We recognize we got to go through this process, and the panel has to come to that conclusion that this is a safe thing to do. And then at that point, we can move forward with that decommissioning, discontinuance. With that said, next slide, please. So the key takeaways, again, we still need radars. They're not going away. We were at, somebody's asked, should I find a different career field? And I'm saying, no, we're still going to need radar technicians out there. And I had a lot of conversation with other folks on the team. And in addition, I think, as we go through this process and we work with you guys when we go through divestment, one outcome I think would be great is that I think the responsibility of the specialist may shift a little bit into be more of a coverage analysis as we fuse everything together today, and we look at problems are going to look a little different. It's going to look, what radar you have a track that may get dropped, you may have a false track, things like that. What I hope to do is when we come out that we can bring you guys into that, and also as we go through our analysis, I think it's going to be a great opportunity to grow specialists to use the analysis tools, show you what tools we got, and I'll even offer up anything that we develop on the program. We'd be more than happy to train your local facilities or give them familiarization on those tools so they know how to use that when we leave. I think that would be a great story. Again, as Dan mentioned earlier, our surveillance posture is stronger today than it was years ago. We're in position now to really right-size the radars as we move forward and we kind of reshape our infrastructure. Before we invest in radars and continue supporting these radars that we may no longer need for our mission, now is the time to right-size those so that we can yield cost savings that we need. Again, very data-driven decision-making process. It's a long process to go through to make sure that all the touch points these radars provide today, we analyze it, we evaluate it, we capture what the impact is and provide that to the panel. Again, air traffic safety services and efficiencies will be working under that. And again, I'll end on the note, tech ops involvement is critical. When we come out to your facilities and we start going through this process, I need your help, bottom line there. So with that said, I'm sorry I went over. I was trying to go faster at the end. Again, I'm going to hand this over now to Mr. Ken Harris and Mitch Hughes to talk about the future of en-route surveillance. Thank you.
Thanks, Devlin. My name is Ken Harris. Matt, I'm the NAS Defense Programs Manager. Mitch Hughes will be doing the majority of this briefing, but I just wanted to do a quick introduction. NDP is full of some amazing people. We do some extraordinary things every day. And a shout out to the whole group, NDP, AJW 142, and all of our support. Things that I wanted to kick off with were Dan mentioned sensor transition. The sensor effort is still a feasibility study. There's a lot of people planning for, okay, sensor is going to do this, that, and the other thing. But it has evolved over the last 3 years. It started out as a tech refresh for all of surveillance, and it's nowhere near that now. It is now a replacement for L-band radars, the ARSRs basically, and specifically the ARSR 4s, like Dan talked about. And then Devlin, we've been working together on divestiture, the Air Marine Operations Center out of Riverside, California for DHS, and the Eastern Air Defense and Western Air Defense sectors for Rome, New York, and up in Seattle, Tacoma area. Use the terminal radars for feeds into their systems, into their automation systems. So we're closely coordinating all of that activity. The sticky point with that is the air defense sectors and the Air Marine Operations Center use those as is when available. So if there's a situation where we need to, or Devlin's group and in collaboration with everybody decides that this radar will be divested, then we need to make sure that the as is when available option is clear to DoD and DHS, and work through the processes there. We're all working closely together, and I thank Dan and crew for putting the surveillance leadership team together, because that's put us all together in a really close environment. We talk a couple times a month sometimes, just trying to keep surveillance up front and get ahead of all these future changes. So with that, Mitch is going to go through the briefing for us.
All right, thank you, Ken. Hello, everyone. My name is Mitch Hughes. I'm the manager for the Air Route Radar Systems Engineering team in Oklahoma City. We fully support the NASA defense programs, and it's through a 50-50 cost share with DoD, DHS. I'm going to talk to you today about the future of in-route surveillance, give you a little bit of background, and then where we think things are going to go. So, first slide. The Spectrum Initiative, and that sensor, it's the Spectrum Efficient National Surveillance Radar Program sensor. So that was set up, and it encompasses the FAA, the DoD, DHS, cross-agency team, all working together to look at the feasibility of making bandwidth available in the L-band. So the FAA strategic plan states a strategic priority of a goal to provide 50 megahertz in the 1300 to 1350 megahertz band for FCC auction. The results of this auctioning, whether that be a replacement, full replacement of all of the long ranges, but like Ken said, probably not, or if it's like you'll see, maybe vacating, retuning the radars. We're not sure, but the consolidated radar systems that will be procured will support the missions of the FAA, the DoD, DHS. As you know, the FAA is responsible for air safety. The DoD's concerned with air defense, and DHS is concerned with air security. So whatever we end up with, it's got to support all three. Next slide. So where did this start? The spectrum sell-off came from a law known as the Spectrum Act. It was signed February 22nd, 2012. The basics of that, the provisions of that, were to reallocate the spectrum over to civil commercial use. So we're taking different parts of the spectrum and moving them over for use other than federal. Next slide. So in 2015, another law was signed, and that's the Spectrum Pipeline Act. The major provisions of this were the research and development, the engineering studies that have been ongoing for the last 3 years, looking at the economic analysis and planning. The biggest part of this was it mandates that we start withdrawing or clearing the spectrum by January 1st, 2022. And then there's a projected auction date of that spectrum in the fourth quarter of 2024, and it's thought the cell phone industry will be taking that spectrum. Next slide. Throughout all of this over the last 3 years, the FAA, DoD, DHS have identified that there are new threats. DoD especially has identified some of the long-range threats like the hypersonic glide vehicles and cruise missiles. The DHS is looking at threats from short and medium-range ballistic missiles and also drones. A lot of concern with drones right now. Next slide. Other threats are more and more RNSS satellites are going up. That's the GPS constellations, and it's radio navigation satellite systems. Those are going up, and many of those are in the L band where our radars reside. So we compete for that space, and we do receive interference and interfere with those satellites. Just to note, newer radar systems can operate and not cause interference or be impacted by those satellites. Next slide. Jeff Bogan hit on the wind turbine problem very well, so I don't have to go into that. But this is a threat. Long-range radars are impacted by these, even though we can dial in a few fixes to help. No radar is immune to this. No current radar that we have in inventory, but new radar systems can perform much better in the midst of the wind turbines, and so that will allow the wind turbine industry to progress further. Next slide. So there's a new direction that that sensor is taking, and that's a retune repack analysis. So what's happening right now is that we're working on a feasibility plan to retune the Archer 4s and the Karshers to vacate the 1300 to 1350 megahertz band. The assessment is we're trying to figure out how many radars can we move and what systems can we move. Retuning, it looks good on the surface, but when you look into it, there are performance degradations. So one of the mandates that's been given is no performance degradations when we do retune. So 1300 to 1350, packing all of the radar systems into that small space is going to be extremely challenging. So we're in the middle of that assessment. Next slide. So what does that assessment look like? There's a cooperative initiative going on right now, and that's between my team, radar engineering, the DHS and DoD, at certain radar sites. We've identified those sites where they have certain geographic features. You can see those. These features are very challenging in the radar environment. So tuning to the same frequency, Carcer to Carcer and RS4 to RS4, RS4 to Carcer and Carcer to RS4, allows us to see what the actual interference looks like. And then we're mapping that out to see where we can move in the small amount of spectrum that we have left. Next slide. From the feasibility study, it may end up that we have to replace some RS4, some Carcers. That's still on the table being looked at. We don't know what that replacement is going to look like. It could be a phased array, a multi-beam system. It could be a spinning system or electronically steered. Those are all systems that we've been looking at. More than likely, it's going to be a system of systems. So maybe some shorter range systems for gap fillers and longer range for other areas, depending on what the DoD and the DHS missions and coverage volumes end up being in those areas. But I want to let every ATSS know that you will be cross-trained into the new technology, so there's no worry there. Just like when we put the Carcers in place, there was extensive training on the Carcer, ran it, all of the ATSS through that training, and you will support whatever new system comes online. Next slide. Yeah, I think that's it. So at this time, I'd like to hand it back to Noel.
All right. Thank you, Mitch. Thank you, Ken, Devlin, and Dan. If y'all could all turn back your video, if you could turn your video back on, because we got a couple of questions here that hopefully y'all can answer. First one comes to us from James Tucker. Why were the DoD ASR areas not fitted with ADS-B stations? Ken or Mitch?
We'd have to talk to the ADS-B office. Dan, who would that be? I'm not sure.
So Dan had to drop off. This is Brad Kennemith, AJM41 Group Manager, Legacy Surveillance. If you don't mind, I'd like to take that as an action to get back to the group. We'll get ADS-B Program Office to answer directly.
Fantastic. Thank you, Brad. Next question's from Eric Helms. Has the PMO and OESG established a mechanics of ensuring impacts to contract supplied surveillance facilities services, example ADS-B and WAM, are considered, model, and mitigations described during the 7460 airspace review process? I'll go ahead and take that one. So yes, we've worked, it's not this program office, but it's the obstruction evaluation program office that we, OESG, have worked with to ensure and take care of those impacts. Going to the next question, comes from Neil Angelotti. I worked with the Unstaffed Infrastructure Sustainment Program. We're responsible for HVAC, buildings, roofs, et cetera, for unstaffed facilities. Is there a list of radar sites that are being considered for divestiture? We would hate to spend funds on a site that may be going away.
No, this is Devlin. I could take that one, Noel. So yeah, we've been working with the Unstaffed Infrastructure Support Group. We were Andrew Cunningham and some of his groups in AJW2, where they were saying, hey, disposition of equipment and facilities is definitely something we do, and so we partnered with that group, and so they've said, pretty much as you move forward divestiture and you go through your process, and we've been working through CWP to get those sites in there for planning purposes, so they can they got to go get funding and things. It's a 2 or 3 year process that they got to plan out. But we are working with them to put them in get the sites loaded in CWP so they know that's coming. And then they've asked us that once we go through our process, and we get to a discontinuance, working through the SLT to figure out what we're going to do with the equipment, the radar equipment itself, how we're going to disposition that. And they tell us, once you get the radar equipment out of the way, you get the facilities turned off, we'll take it from there across the finish line. And so that's been a really great partnership, and it's working very well. Hope I answered this question. The one thing I will say that it was kind of built on that question, I hear this a lot, is investments, and I work with Don Taylor quite a bit. So there's this question on radar divestiture. We got radars that we're looking to divest, but there's sustainment projects planned for those facilities. I came out of the facilities group where you got engine generators, batteries, HVAC. There's a lot. And we always tell people, the way we communicate is we're planning to do this, but it's not done, like I said in the presentation. We still got to go through and go through an SRM panel. So you need to continue sustaining the NAS today to keep the services in place and don't account for that and kind of let off the throttle any on that, because you don't want to input any risk on the NAS based on the assumption of divestiture.
Right. And in addition to that, Devin, we need those lists to make sure that we don't add any air-to-ground communications facilities, weather facilities, and all of those types of other types of facilities at those radar sites.
Absolutely.
Yeah. Okay, the next question comes to us from John Pizzicara. Will crypto be incorporated into ADS-B data streams with public-private keys for zero trust operation to make it hat-proof and especially terrorist-proof? And I'm just going to say that we'll get that over to the ADS-B program, and we'll have them provide an answer to that afterwards.
Absolutely, no. Thank you.
Next question comes to us from Omar. What system is the ASR going to be replaced with?
Yes.
So
Brad, go
ahead. More I can. Oh, sorry, Noel, I can take that, and if you don't mind, I'll actually bundle it with the next question as well.
Yes, sir.
If that's okay, which is asking if we are going to replace the ASR 9 with an ASR 12. So I'll try to answer both of those at one time. So as we go through the investment analysis process in the AMS process, we go through what is called an alternative analysis. That alternative analysis looks at all viable alternatives for sustaining, enhancing, or replacing systems. So any viable alternatives that are identified either through SMEs or engagement with industry are evaluated and considered based off core requirements for the agency. So as of this point in time, because the ASRR program has not fully been established, it will be established in 21, 22, and moving to investment analysis in 23. We have not conducted that analysis at this point in time, but any viable technologies in the 21-22 timeframe will be included in that alternative analysis. So the ASR 12 that was specifically referenced in the question, I don't believe at this point it is in production right now, and we can procure it. So, but any technology that is procurable and available would be considered at that time.
All right. Thank you, Brad. The next question comes to us from Kenneth Mowbray. The CTD has greatly enhanced the performance of the ASR-8 radar. An engineer mentioned that the manufacturer of the CTD system also makes a matching transmitter. Has the FAA considered this already developed equipment to replace the aging ASR-8? Brad.
Yep, same type of answer. The ASRR program, again, will evaluate sustainment, enhancing, or replacing technology. So we are not automatically coming out and saying that all the legacy non-cooperatives will be replaced. They may be sustained. So an option that would be evaluated is a major subsystem replacements, like you mentioned for CTD on the transmit side. So it would be a valid option moving forward. During the sustainment activities we currently have underway, the system has been evaluated, and we don't believe we are going down that route of major subsystem replacement at this time for the ASR-8.
Thank you, Brad. The next question comes to us from Robert Lando. At what point in the acquisition process with regard to new radar systems does Spectrum Engineering Services get involved?
I'll take that one as well.
Yes, sir.
So Spectrum is part of the JRC checklist during investment analysis. They are a signatory and have specific artifacts that we develop collaboratively. So during IERD, IID, the AMS milestones, we would be engaging with Spectrum to ensure we're going down the right path.
Thank you, Brad. Next question. How is NDP involved in the radar divestiture?
Oh, very involved. Devlin and I are talking all the time. Took a little bit to get us connected, but once Devlin took over, he reached out and we're talking all the time.
All right, fantastic. Next question from Philip Sandoval. How will radar divestiture affect the manning levels or staffing levels?
So, I mean, from the program perspective, we don't set those. I mean, our part of the program doesn't factor in reducing staffing. That's not our call. So I'll yield that back to the opposite side of the house.
Right, and we'll provide an answer to that afterwards on this one too. Okay. The next question comes from Lorenzo Parks. Is there any conversation for tech ops taking over the maintenance of WAM and or ADSB GBT systems?
I mean, the ADSB folks on there, but that's not part of the conversation. I haven't heard any conversations about moving that maintenance. It's a provision service that we get from L3 Harris today, ADSB, and then WAM services as well through the service delivery points. I've heard no discussion about FAA taking ownership or maintenance of that.
All right. So is there any conversation? The answer is, I guess, no right now. Next question comes to us from Walter McCusker. On divestiture, earlier presenter, SOC and large TRACONs. So this was yesterday, Devlin. We had our SOC personnel and large TRACON. They talked about how they do not allow more than one sensor out at any one time. If we eliminate the overlap coverage, will that only make getting downtime more difficult? Are we looking at what the impact of when we can maintain these systems? All the briefings I have listened to make it sound like we will be working late nights and off normal working hours, since the impact of being analyzed on impact to air traffic, not as much on the impact of technical operations.
Yes. I'm sorry. I can take
basically
that. I mean,
yeah. Basically, it would be the difficulty of us getting downtime with less overlapping coverage. So I would imagine that with respect to the whole process that you talked about, going through the SRM process and all of those types of things, that's when that would be some of the criteria that would go into the decision making.
That's exactly
on whether we divest a system or not.
Absolutely. No, that's going to be part of the process. Certainly, right. I come from Tech Ops, know the challenges already, and it's been harder and harder over time with the demand there. And as we move into the services world, I mean, we will consider that part of our process. We're going to take a look at that N-1 approach, with and without ADSB in play. And so you said it very well, Noel. It's going to be part of the process as we look through, and certainly recognize this is these radars have a lot of touch points, and they feed multiple facilities now. They feed, we feed it to ADSB, we feed it to NDP, DOD. There's a lot of touch points, and so all those touch points will be analyzed and evaluated in the context of the divestment process.
Right, and part of the reason that we're also looking at divestiture is because of ADSB and aircraft equipage, and that kind of migrating over to being the primary. So if that's the primary and we have multiple layers of secondary, then can we just get rid of one of those secondaries?
That's right. Yeah. And we've definitely moved into a fused service-like level now at the automation level. So we bring in all these sensors. I think we're a step farther than we used to be on being able to remove a radar from service and maintain some level of operations.
Yes. But Walter, you do bring up a good point, and that is one of the things that will be looked at with the criteria associated with divestiture of a system.
Yeah.
Next question come to us from Edward Lenz. Why are not ATSS 2101H bands that are ASR and BI6 certified hold a security clearance, not 2101 I-bands. We'll go ahead and table that question also, and we'll try to answer that at a later time associated with that. Next question comes to us from Philip Sandoval. On long-range replacement, the United States Air Force was working on a phased array system in the 1980s called PAVE-PAWS. What happened to that system?
Well, I don't know what that system is. We can certainly look at it, but I will tell you through the sensor program, there have been quite a few vendors that have stepped up and presented what they can do to offer the coverage that is required. So if that's one that was offered during the sensor vendor request, then we can get that answer to you. But everything's on the table right now. We don't know what is going to replace the legacy long-range radars, like I said in my briefing.
Right. All righty, thank you. Let's see. The next question is from Sandra Wright. Earlier today, we heard that current legacy surveillance systems in the inventory ranged from 10 to 45 years. The future for surveillance we heard about this afternoon, we're using ADS-B, replacing systems with WAM or the MODES beacon replacement, and the ASRR. How long are these systems designed to be used and expected to be in service? When would the next major surveillance system update? 2050 or 2070? Question mark.
Yeah, Noel, so I'll take that one. So when we procure the systems, we aim for a 20-year life cycle. So if we're going into a 2030 acquisition, we would be looking at a 2050 end of life timeframe. So Dan's slide that he showed during his presentation demonstrated 2035 and beyond. So we would say 2055 would be the expected end of life at this point for those systems.
Boy. All right. Thank you, Brad. There's just a comment from James Hall. I don't know. Normally, they don't allow adjacent radars, not multiple radars, if they are far apart. And I think that's alluding to getting downtime. But I don't know what the question is there. We'll see if James can provide a clarification on that statement. Next question is from Thomas Mugford. In the case of SSR removals, divestiture program, how will the ASR-11 operate without beacon information to count search onlys? Currently, the ASR-11 uses search only counts to disable editors to control the false alarm rate. Has this major modification been factored into the cost benefit analysis for a MSSR removal?
Yeah, so I'll tell you right now, there's no plans right now to remove just the ASR-11 or break up the ASR-11 MSSR. There was a list that they may have seen. It was based on a very different analysis, and I'll tell you that the next phase, like I mentioned in my presentation, the next phase of divestiture, we'll look at to see what's possible and what's needed. But in our phase right now, what we're funded to do, there's no plans to break up ASR-11 with an MSSR.
Okay. Thank you, Devin.
Devin, I just want to add to that. So we are starting the process of looking at splitting the ASR-11 though. So we are currently, as part of the sustainment program for ASR-11 S3, conducting that alternative analysis I mentioned earlier. So sustainment program, doing an alternative analysis. We are looking at the ability to split the 11 into non-cooperative, cooperative at this point in time. It is one of the alternatives being considered, and we are evaluating the technical hurdles that would be encountered if doing so. So let's say within 6 months, we might have some clarity on how we would satisfy this challenge that gets introduced with splitting that radar.
Thank you, Brad. A comment, PAVE-PAWS is an over the horizon radar in use at Beale Air Force Base in Sacramento, California. Thank you for that clarification. Next question comes to us from Glenn. For an ASR9 that could be shut off, but has a WSP installed, is there a standalone replacement for the WSP?
No, that's a great question. So when we took on the candidate radars, WSP and the weather product that provide air traffic is a big issue. And so as we prioritize the list, we're still working toward coming up with an alternative or solution. We don't have that today. We're going to have to work through that. But certainly divestment without having a substitute for that WSP that are coupled to the ASR9s at a few of our sites, we'll have to address that. Air traffic has made that very clear to us on that. And I think on our list, we had 4 ASR9s that had the WSP mod. So we're working through that solution now.
Yeah. And Devlin, just to, yesterday there was a question about, and I answered it rather quickly, and I guess I shouldn't at this point. The question was, have the sites being divested been identified? And I answered with a yes. And what I should have said for everybody else was that candidate sites have been identified. And there is a list of criteria that will have to be met, and it'll have to go through the SRM process in order for a site to be divested. So if a site does have WSP, that would be one of the criteria that would have to also go through the SRM process.
Well said.
All right.
I would even add there on the, we got some radars to add to the WSP question that the ASR, call them Cat 2, is where we only remove the primary and leave in the secondary. And that's all ASR 9s and Modestas. And we've been meeting with the second level folks. There's certainly some technical challenges of doing that. And so working with Tech Ops heavily on how to work through that.
All right, thank you. So next question is from Stephen Myers. Is the program office handling the NEPA, National Environmental Policy Act analysis for the divestiture and/or sensor program? It sounds like some sort of programmatic document may be required. It got missed in the current DME program that is being implemented now.
So Noel, for divestiture, I'm not familiar with that, but I'd be more than happy to learn more about it. I don't have an answer, but I certainly would take it under consideration if it's something we need to be doing. Maybe they could help me out with that. I'm not sure.
Okay, so we'll look into that associated with that and kind of get back to you, but thanks for the heads up on that NEPA piece. What is the amount of time that the adaptation will be ran once a sensor is chosen to be decommissioned?
Yeah, so I can take that. And we work heavily, and part of our team, our core team, is the automation folks, the Tisley group out of the tech center, who help us with the adaptation and the re-registration and all that. And so as we move forward to divest, like I said in the process earlier, we plan to put it in front of controllers for 30 to 45 days, and that could vary. It really depends on their comfort level and their confidence level, and how much they need to see on the glass. But that's kind of the way we're approaching that.
All righty, thank you. The next comes from James Hall. It's a clarification. He says, my comment was in reference to statement that more than one radar cannot be taken out of service. Normally, if the radars are not considered adjacent, they can be removed from service. So he's just providing a clarification on that. The next question, comment comes to us from Gregory Welts, Jacksonville, Florida. Jax has an ASR 9 with a WSP and is on the list to go away. Yes, and I believe so is Grand Rapids. And again, it's going to go through all of that criteria, go through the SRM process before a decision will be made on whether it will be discontinued. So just because they're on the discontinuance list does not mean that a decision has been made for them to be discontinued.
Yeah, you're absolutely right. And the challenge with the WSP, as a matter of fact, LAX South was at the top of the list in the beginning because we've invested so much in WAM and other things there, but they have a WSP there. And the problem is not really the cabinet. As we work with our partners in second level, it's really a mod kit to modify the ASR 9 to couple to the WSPs. That's the biggest constraint we're working under. And those mod kits are we've been told no longer available. So we're having to work through that.
All right, thank you, Devlin. Next question comes to us from Sandra Wright. ADSB has a high reliance on GPS and alternative PNT programs are being looked at, but a solution doesn't seem in place. For various GPS outages, 10 minutes versus has been unreliable in an area for hours. Are there standardized ATC procedures to handle nationally, or is this unique based on what other sensors are available in a particular area to provide coverage?
So right there is a key piece of why we have to continue the radars and the configuration is that ADS, what happens if the satellites go out, and the radars will continue to provide a level of service in the absence of ADSB. So the divestiture program was built under that context of a backup to ADSB.
Okay. All right, and then the last question, at least for this session, comes from, and it's more of a clarification, Andrew Cunningham. He says, real property disposition, budget line item F26.01-01 will handle the NEPA analysis and action. So there you go.
Thank you, Andrew. I appreciate that.
Yes. Okay, so Brad, Mitch, Devlin, thank you so much. We are going to go over to Jeff McCoy. Jeff McCoy, are you on?
I am on. I have been, thank you, Noel. I've been listening probably the last 15 or 20 minutes. I actually think I was fortunate enough to get in on all these Q&A sessions. Not just the number of questions, but really the complexity of the questions that are coming in and the range that they're going. Really, it kind of proves, it actually kind of proves why we needed this type of symposium and I think how valuable it is. I have to tell you, so I know as I'm sitting here waiting, Trisha kind of texted me and said, hey, I'm sorry we're running late and stuff like that. I said, no, I'm actually learning a lot. And I'm a radar guy from a long time ago. I actually was a radar technician from a long time ago. But this stuff here is just, I have learned a lot. If I've learned this much in 15 or 20 minutes by listening to or by reading the questions coming in and listening to how you guys answer them, I can only imagine the amount of information and the benefit that this entire symposium proves. So thank you for it. Don't know if there's any questions for me. I want to go back to, there was actually one or two questions on there that I think you guys answered, that when I read and stuff that I wanted to tie back to how I started my opening comments today was I'm glad we're looking at surveillance as a service, right? And it really had to do, I think it came in from somebody from AJW too. I think it came in from Neil asking about the facility part of it, the HVAC, the actual facility part. And I think when you start asking questions like that, I think it has us all looking at not just surveillance as a service, but surveillance as part of a service threat, right? I mean, radars without an automation platform have no reason to exist, right? So if you have radar, but you don't have stars or you don't have ERAM, there is no surveillance service. If you don't have the building, which I think Neil was getting into, if you don't have the building, then you don't have it. You can go do all this other stuff, but unless you're looking at telco and power and all these other things, you really don't. This is an extremely complex network that we have. And by network, I actually mean the complexity of the NAS. But I didn't want to take up too much time on this stuff. Like I said, I learned a lot. You guys are probably hearing my dogs bark in the background. I'm sure if you guys are unmuted, I hear some of yours. That's just the way it is. But I do want to thank the people that put this on. I can't thank everybody on there, but I certainly want to go through a list because I know this took a lot of work. It seemed like it was easy in 2 days. This is a lot of work. So I do want to thank Jeff. And when you're talking about Jeff and Tech Ops, you have to specify Jeff Bogan. Since there's so many Jeffs, you have to specify Jeff Bogan. Thank you. Kyle, Darren, Olga, Sean, Dustin, Tom, Don Taylor, Ryan Willis, Karen, Ryan on the comm team. So, certainly know you trying to do this stuff is trying to facilitate this stuff and go back and forth is certainly a challenge. And I also want to thank Tricia Jackson, is our executive advisor on this thing. So with that, didn't want to take any more time. I just want to make sure that you guys take this information now and figure out a way to share it with other people. Figure out a way to keep this conversation going. Make sure that when you give the opportunity that you're giving feedback, not just questions, because I don't think this is the last surveillance symposium you will see. And I think this is kind of a good pilot, a good test for other ones. Somebody said communication. I absolutely believe there needs to be one in comm. I believe there needs to be one in telecommunications, one in nav, one in environmental. I mean, because all these things, and if you are working in the surveillance world and you do happen to get an invite for the comm one, I would ask that you consider listening. There are pieces of every single service in here that touches every part of it. So with that, I don't know, Tricia, no, I have no idea if there were questions for me on this thing, but if
yes,
not,
sir. There is one question for you now.
Okay.
I am just reading the question, sir.
What's the question?
Did you work on the ASR one?
Did I?
It's just a question, sir.
Well, yes, and I still have all my hair, so radars are safe. I actually think that was a great question. Philip. That was a great question. I'm actually glad you asked me that question and asked Tricia if she knew if I worked on ASR1, because she'd have said, oh yeah, even when it was in development. That's a good question. Thank you.
It is. Tricia, you're muted, Tricia.
So I think you were actually, even before that, using the shrimp boats, right? On those radar displays that we saw.
I am going to say it wasn't shrimp boats, but I did work on a horizontal deed, so you're pretty close.
Yeah, thanks. I appreciate you joining us, Jeff, and opening, but also being here to hear some of it and wrap up with us. The team did a phenomenal job putting this together, and I think there's so much value and more to be gained in future ones. We are going to be sending out a newsletter after, Jeff, with all of the resources from yesterday and today, as well as a survey for folks to take. And please, I can't emphasize enough, we want your feedback. We want your input, ideas, and what worked, what didn't work, all of that, because we do intend to roll out future symposiums, not only for the other disciplines, but as we said, this is the inaugural one for surveillance, and our vision would be that we continue to do this, to really engage the communities. And we are one NAS and one FAA, and I think this is definitely a way for us to engage across those boundaries.
All righty, thank you. So we still have quite, I think there's about 30 plus questions. And as long as we have participants, there's still 450 people on here. I think we'd be willing to try to go, an extra 20, 30 minutes in answering questions if that's okay.
Absolutely. Certainly, we can try to get as many questions as we have. One thing before we go into that, I know we have several folks that are called in on the phone. So I just want to let you know that the email address being shown right now is techopsmedia@faa.gov. So if you do not see the newsletter, please reach out to them so that we can be sure to get that information to them. Also, before I hand it back to you, Noel, I got to say thank you, because you were our stability throughout both days, and you did a phenomenal job moderating the entire event. So virtual hand clap to Noel. Thank you for all the work and effort that you put into this as well. Jeff, anything else? I think Jeff should stick around for the rest of the Q&As though.
Okay, so without any further ado, I don't see Jackie on here, but it was maybe Sean Mock or somebody else can answer. On the new ASDX antenna SLEP, will all of the new antennas have internal heaters to address icing issues?
Okay, yeah, I'm here, Noel. Thanks. So yes, so it's pretty new in that acquisition process, and we're currently working with the program office on defining requirements for this new SMR, and that is one of the requirements. It has to be able to operate in climates with cold weather.
Okay, thank you, Jackie. Next question, what is the time frame to replace or upgrade the en route Mode S systems? Brad?
Sure.
Devlin?
Yeah, sorry, I was searching for my camera and mute button. So I expect that.
Let me call you right back, Aubrey. Yeah, sorry about this.
Open mic, Devlin.
Oh, sorry, Noel. I got a call, so I'll yield to Brad. Sorry about that.
Yeah, so I'm expecting we can probably go IOC on MSBRS in 2024 and start rolling out after that. Would be the approximate time frame.
All right,
Does that answer the question?
I believe so. In recent meetings with the mobile and satellite communities regarding 5G, they keep asking, why can't the government work like industry where they upgrade their technology every 5 to 10 years, such as 3G, 4G, now 5G, and standardize equipment such as radars, and allow spiral development and optimization in tech updates for newer generations of government equipment? Ooh. That's kind of like an acquisition question. Do we want to go ahead and, does somebody want to try to take a shot at that one?
No, I think we just table that one and take it offline and try to
All
come
right.
up with an answer.
All right, sounds good. Next question, how do we get the funding to purchase a Field Fox for an en route Mode S? We have the multitude of test equipment you talked about, including the old HP network analyzer. I'll go ahead and take that one. Each service area has a test equipment coordinator, a test equipment program manager, and there is a website where you can go in and put all of your requests for new test equipment. So when we send out all of the artifacts for this symposium, there will be a trifold for WSA, OESG, CSA, and ESA OESG. In those trifolds, there will be the test equipment program manager, test equipment coordinator. Contact that person and they will help you out. Next question. In Jacqueline's slide, the SMRI showed a TERMA antenna and the SMRR shows the ESAT antenna. Is this correct? Is the ESAT being discontinued, or should the slide photos need to be swapped?
No, the slide was actually correct. So that's what I get for putting too much stuff on there and not having a lot of time to talk about it. But the SMRI actually takes a feed from both the TERMA and the ESAT antenna. The ESAT is not being disconnected, only the SMRR equipment. So the transmitter and receiver. The ESAT on the SMRI, it's the one that has the heater mod. So the TERMA does not have a heater mod, so that's why we still need the ESAT antenna.
All right, thank you, Jackie. This was just a comment. The Klystron replacement is greatly helped by having your TSOG rep on site. Helped me out several times over my ASR time. That came to us from Thomas Fizette. Next question's from Steve. Outstanding presentation. One issue, the busiest airport in the world is encountering retention of ATSSs. The past 14 years, 12 ATSSs left for I-band, 2 retired, now down to 4 ATSS, 3 retirement eligible. Schools, OJT basically requires 3 to 7 years for our 11 en route terminal weather stars ASDX PRM automation system. How do we retain ATSSs? Where it is, that would have been a good one for Mr. McCoy. Trish, would you like to take a shot at that?
I'm sorry, Noel, can you tell me what the question was again? I'm not staying on here.
It's going, it's about retaining ATSSs. They're saying that the busiest airport in the world has lost a lot of their expertise. It requires 3 to 7 years for the 11 systems that they contain. So it's about ATSS, retaining ATSSs at these quote unquote hard to staff, I guess at a hard to staff location.
Yeah, that's a great question. And certainly when it comes to staffing, retention has been a problem for a long time. And we have plenty of areas that really are hard to staff locations. We had an opportunity through on-the-spot hiring to bring folks in, and we did. And in fact, I think across the country, we're close to 500 new hires that we have brought in. And so we did do very well with that. Unfortunately, our challenge right now is with our current health emergency and pandemic is our ability to train those folks. And so more so than staffing right now, our challenge and focus is on figuring out how can we get our folks trained. But it is a constant effort. There's a Gateways program out there, which is also a means for us to bring in folks through, it's almost like the legacy, if you will, CTI or Pathways program. So we do have folks that are working on how do we get folks in to the organization and in the right places. But again, our primary focus currently is getting through this current posture and getting our existing folks trained.
All right. Thank you, Trish. So this question comes to us from Bob French. Is there a way to capture the original tuning rod settings on a klystron via the serial number of the tube? I cannot locate this information at my current site, and I know we used to keep those around. Darren.
Yeah, so from what I remember, there's a place on the door of the transmitter where you put that, but maybe that's just in the logistics center we do that. I don't know. Yes, you can get that. We keep a copy of those by serial number because we system test every one of those klystrons before we ship them out.
Okay, so Bob French submitted that question. Bob, if you drop Darren K. Jerome an email, he'll work on getting you that information.
Yeah, thanks, Noel. That's the way to do that.
Yes, sir. ADS-B is causing radar divestiture. I have 3 ASRs in the ESA set for decommissioning in the next few years, according to a PowerPoint from Timothy Smith, PRG, October 2019. Is this still happening or delayed? Savannah, Georgia, ASR 8, Jacksonville, Florida, ASR 9, and Columbia, South Carolina, ASR 11. And Devlin, I think you pretty much answered that in your presentation. And we have since covered everything that needs to go through in order for them to be.
That's correct. And we have briefed the Eastern Service Area. We briefed headquarters and we've kind of briefed the districts. Actually, the directors out in the service areas, we've been kind of working our way out to the facilities, and that's where he may have seen that briefing. So,
all right.
But yeah, you answered the question. Thank you, Noah.
Okay. Thank you, Gregory, for Gregory Welts for that question. Next question is from John Roski. WSA has put together a 3-phase PowerPoint lesson with pictures for replacing ASR 9 rotary joint. Phase 1, identifying failure. Phase 2, signal flow, and phase 3 alignments. KSA website uploads soon. Jeff, would you like to shed some light on that? Jeff Bogan.
Yeah, I believe our teams have put together some information on that. And Perhaps the best way to share that, I don't think they're complete yet. So perhaps the best way to share that, if they are complete, I'll have to check that, is to put them up on the artifact site here for RKSNs. And
Okay.
then you can get access to it. I believe they're in review at this point.
All right, thank you, Jeff. The next question is from Michael. Has there been any plans made to provide any installation-specific training classes for engineering services engineers and technicians? So let me see. Brad, I don't know if this is a Brad question, with respect to, when we get into the point where we're turning engineering services on with the new programs out, how do we pull them in to get them up to speed, like with COR or COTR training, and anything specific on that? Thoughts?
Noel, sorry, I missed the original question.
Are there any plans made to provide any installation specific training classes for engineering services engineers? It moved, and technicians. So
For new acquisitions?
yeah, I would imagine that would be new acquisitions. Yes.
Yeah, so I would assume we would absolutely put that training in place once we get closer to that milestone. We're still 4 years out for MSBRS, and we're probably closer to 10 years out for ASRR. So as we get there most likely will be training for that.
So during the IOC and the CERT first site deliveries and all of that type of stuff is when we would develop all of those types of things for engineering services. All right. Okay, next question. Since Harris is taking over MRUs, are the MRUs becoming part of ADSB? I guess we'll let we'll push that over to the ADSB program so they can answer that question.
This is Devlin. I was going to try to offer some help there. So the ASDX is what has the multilateration MRUs as part of their MLAT service. ADSB provides ADSB today to ASDX, different systems, different configurations altogether. So I'm not sure I follow the question. They're different. There is sometimes confusion on the word multilateration because, you heard in the briefings earlier, we are looking into wide area multilateration that's provided by SBS service or L3 Harris, but that's different than the multilateration that's referenced when you talk to surface systems like ASDX and ASSC.
All right. Thank you, Devlin. Next question comes to us from Sean Cooper. He says, this is not so much a question, but as much as it is an idea. What is the possibility of, instead of having MDT laptops, as to having something like a Surface Pro? I asked this in reference to the earlier discussion question about having training videos for klystron replacement and alignment. One thing that can be done is establish a system block diagram that is interactive and being able to select the section, having it linked to images, videos, TIs, and handbooks. This could greatly assist maintenance tech in the field to have a resource readily available at a moment's notice. It could also enhance capabilities with the coming TAP application. So, Darren and I are both, we're both on the, we're both on the National Innovation Team. And Darren, are you helping out Cody Johnson with that piece?
No.
Okay, but Cody Johnson, he's a district facility manager at.
He's a Tom in the Western Service area.
Yeah, it's either SCT or NCT. I can't remember, but
NCT, I think.
Right. So Cody is working this issue right now and trying to bring that to fruition.
So. He's testing a computer that's on contract because the Surface Pros are Microsoft and you have to go through all these special approvals just to get one.
Right, it's a HP.
He's testing HP. Yeah,
it's an HP. That's a tablet that's just like a Surface Pro.
Yeah,
like that's the kind that I have right now.
So yeah, he's rolling out tests right now.
Next year, a question comes from Matthew Rowland. It would make sense to compensate for any coverage lapses for a few of the MRU sites to be sold or transferred to Harris as ADSB sites to provide coverage for the ASSC.
Wow.
Yeah, this is Devlin. I could maybe take another shot at that. It's related to the other question. And so for runway prediction, there is a service that comes in from ADR ADSB service into ASDX. There's also a multilateration service for approaches for runway prediction. So I'm not sure how to answer the question, but they're just two different services that come into the ASDX, along with our terminal radars.
All right, well, we'll look at that question afterwards and see if we can provide if maybe you answered it or maybe we can provide a better answer. The next question from Tim Ferris, will there be ASR 8 and BI5 training that includes the integration of the CTD? Seems like a great system, by the way. I work on several 8s and 5s. Don, I don't see Micah on, so Don Taylor.
Yeah, Noel, I could try to take that. So we have developed, we have the existing ASR 8 course and we have a CTD course. We are actively working with Micah and his team to determine the final end state of the ASR 8 course or a combined ASR 8 CTD course moving forward. So we are in instructional design with them, having conversation on what does the end state look like. Does that answer?
I believe so. Thank you very much, sir. Next question comes to us from Timothy Ferris. Could the rotational velocity of turbine blade tips be detected and programmed into radar software so it can be identified as a non-aircraft target? Jeff Bogan or Sean?
Yep.
Hey, whoever comes out first, man.
I can answer that. So there's been a lot of analysis on the ability to mitigate turbines by looking at their Doppler returns and processing them. Unfortunately, the Doppler returns that come back off of the blades and quite a strong return off the blade tips themselves, those translate to aircraft velocities that are quite common. And so therefore, it's extremely difficult to simply just do that alone and have that be the mitigation. So just to filter out that particular velocity, and it changes as the rotations turn. Some of these are variable speed turbines. They change with the wind speed. Some are locked down to 3 different levels, but they all translate to aircraft velocities that are used today, and therefore you can't just eliminate them, because then you'd be eliminating aircraft going that speed as well. So that's not quite the right approach, but analyzing the Doppler returns and doing something with that information intelligently is something that's being actively looked at throughout the radar research community. So things are happening there. They're just not yet available in our FAA radar systems.
All right. Thank you, Jeff. Go ahead, Sean.
Yeah, so I also participate in the wind turbine radar interference mitigation work group, which is a partnership between the FAA, DoD, Department of Energy, NOAA, and other groups. And right now, the ASR 11 is one of the most impacted radars by wind resource areas. So we actually have a lot of different potential mitigations that we're investigating. We have multiple software upgrades and software features. In fact, the Carcer has algorithms that has helped mitigate the impact of wind turbines. We're doing a study to see if those same algorithms can be incorporated into the ASR 11. And so we have a lot of things we're looking at, but we also realize that there's always going to be, on these legacy existing radars and the way they function, there's always going to be some level of impact, and it's never going to be perfect. As new radars as acquired, we are putting requirements in there to have wind turbine mitigation capabilities.
All right. That's really good to know, Sean, that you're our representative to that team. Now I know who to call.
I was trying to keep it secret.
Secret no more.
Yeah.
The next question comes to us from Timothy Ferris. Could we talk with stakeholders that install wind turbines and ask if it's possible that something be installed on turbine blades that will allow radar to identify it as a turbine and drop it from detection?
This is Jeff, and again, there's been a lot of research on by the wind turbine industry around different construction techniques for the blades to make them less reflective. Those are structural challenges that the turbine industry, though taking seriously, is challenged to do and maintain strong structural integrity of the turbine blade. So I don't believe that that's widely deployed at this point. But it was looked at, it was and still is looked at by the radar industry, and they're very aware of our concerns about it. And maybe, Sean, you might know a little more about whether or not, I think they've tested this, but I don't believe any large-scale deployment of radar absorbing material is being used. There's other techniques besides radar absorbing material that might be more effective.
All right, thank you. Next question comes to us from Sean Cooper. Has anyone ever considered adding a feed to our automation system to incorporate a NextRad weather presentation for improved weather presentations?
So I will try my best to chime in here. There is a weather on the glass work group that's going on right now, looking for the best way to provide air traffic with the weather information they need. You know, currently surveillance radars are providing a weather product. You know, these radars are really designed for surveillance of aircraft, not surveillance of weather. So this work group that is across ATO is looking at all the alternatives, right? Those of us in the aircraft surveillance community would really like them to find an alternate solution to using our radar so we can focus on surveying aircraft. But that is something that's getting a lot of attention, and especially as we're looking, you know, as Brad in the PMO is looking to do an ASR replacement program, they need to know if weather and providing a weather product is a requirement, because it limits, right, the technologies we can look at, because not all surveillance technologies are capable of providing weather.
All right, thank you. Next question for LCSS. A search box on the home page to search for P number would be very useful. It's been suggested the formal way several times by different people, but still no way to search for P numbers. Darren.
Yeah, I'll have to go with the LCSS team on that. So forward me that question, and I believe there's a way to do it. I just don't know how you do that in the portal.
All right. Next question, Daryl Griffin, Philadelphia Radar. You had stated an NCP was required for relocation of a Parrot CPME. I assume the same goes for an MTI reflector. Correct. Next question from, I can't tell that. ASR9 adding VSWR key parameter checks back into PM scheduler. As an evaluator, we frequently find this out due to being an as required.
Yeah, so that is one of the challenges we have. Some of the key performance parameters that the NASDAQ team is required to look at by order are not included in a PM. And therefore, the specialist may not have looked at it recently because not thinking it needed to be looked at, but it may have drifted from its value that it needs to be and outside of tolerance. So that is a big challenge. It's also a big challenge for the key performance parameters. As we look at reduced maintenance, we're removing some PMs, and again, a few of those key performance parameters may be will be looked at by the NASDAQ team, and it's up to the specialist to ensure that they are looking at all those as neededs on a regular basis to ensure that they're meaning that those parameters are in tolerance. And if they're out of tolerance, you need to take a look at them. There is some work by the reduced maintenance ConOps team to look at key performance parameters and associated PMs to link them up a little bit more closely. So some work is going on that. You may see some more relief on that and a process forward that would ensure that during a PM it was done as well. But second level teams are working with us now. They're aware of the problem, so we're looking at it. But for right now, you need to ensure that key performance parameters remain in tolerance.
All right. Hey, Jeff, hold on, because the next question is, it's from Mike Krass. As required that are KPP, key performance parameters, should be changed to scheduled ? And that's
the essence of the dilemma we find ourselves in. You're right. It seems reasonable to have a PM for all key performance parameters. If they're so critical to the system, if second level is determined they're that critical, why would we not be doing a PM? But then in today, the way the systems work, a lot of the systems aren't drifting. Those key performance parameters should remain in tolerance, but sometimes they're around meter readings and other sorts of things that are like VSWAR that are changed during optimization. Those need to be looked at. And so again, we are working with second level teams. The second level team is aware of this. And I would agree that more look needs to be done to ensure that you're checking those key performance parameters on a regular basis. And the as needed is a little ambiguous. So we'd agree with that comment.
Right. But you're not saying right now to change them to a scheduled.
Right now, that is not in the plan, but that is under review.
Yeah. Next question. Is there anything in the works to notify a tech or SSC when there are order changes? In the old days, we knew when they sent out the paper copy.
Yeah. Hey, Noel. There's subscriptions in TechNet. You can sign up for those orders for updates. And then so go to TechNet, scroll down, sign up for that subscription to change, and then that information will be pushed to you.
Sign up for subscription services at the very bottom, right? And you can sign up for a whole bunch of them. Yeah.
Yes.
Oh. I'm going to save that. Okay, next one is. Okay, this comes to us from Mike Crafts. Don and Stephen, Jeff, Stephen, and myself. Is there any oversight involved in the 7460 OESG process? Will OESG be reaching out more to the affected SSCs? And so, yesterday Jeff stated that there was, in WSA, there was between 60 and 80,000 obstruction evaluations. Well, in Central Service Area, there's between 100 and 110,000 obstruction evaluations. And in Eastern Service Area, there's between 80 and 100,000 obstruction evaluations that we do. So combined, OESG is looking at, around 200,000 obstruction evaluations each year. It's very difficult for us to coordinate all of those, especially with the time frames that we have. We have 45 days to put in a response, and we have different levels of responses. We have first level reviews, second level reviews, and third level reviews, depending on the complexity that's associated with that obstruction evaluation. So we try to coordinate. If there's information that we need from the site, we don't try to go directly to the site. We try to go to the technical support center. And so that either the technical support center can get us that information, or the technical support center can coordinate with the SSC on that. So that's kind of what the oversight that we have. I don't see us going out to the SSC more. I would expect that we would continue going out to the SSC through our current process, going through the technical support centers. Jeff, did I miss anything?
No, I think you got it exactly right, Noel. I mean, it is a machine. When we have to do hundreds of thousands of obstruction evaluations, we can't put anything in the way in terms of review and concurrence that would slow us down. We have experts looking at this, but I would think for the mitigation phase, if there's something we need to engage the SSC on, they are certainly going to be part of the discussion. But generally speaking, for a large majority of the cases, you really have to count on the OESG engineers ensuring that a proper and sufficient review has been done. And we've been very successful with that. If any of the SSCs have a problem where they think that we might be missing something, let Noel or myself or Steve know so that we can make sure that we get all the right information so we can evaluate all these cases coming in expediently.
Next question comes to us from William R. Charles. It is good being able to do courses virtually online. However, as one who is not familiar with the equipment used in the facility, is there any thoughts of the new personnel being able to come in and go through the actual equipment on site at least one day a week following COVID guidelines? I think that all kind of ties into OJT. It ties into the knowledge and knowledge sharing that we're talking about. But William, you do bring up a good point. If we can't pair a new ATSS up with an old ATSS to go around, how do we go about doing that? So we'll see if we can work on another question. We still have some questions that we were not able to get to. Our Faves connection is going to be dropping us here in about 5 minutes. So I'm going to go ahead and stop it right now. I want to thank all of you for participating in this surveillance symposium. I mean, we still have 350 people on. And I want to thank all of the keynote speakers, all of the presenters. Did a great job, guys. Reminder, we will be sending out some information for y'all to provide us more feedback, and we will be providing all of the PowerPoints and all of that information. So the symposium materials we made available in the upcoming Connections newsletter. If you do not receive the newsletter, please contact techopsmedia@faa.gov. Hey, thank you very much. Thank you for leaning in and listening.